Good morning, everyone. I am Dr. Daksh Sethi, and on behalf of the CRSA India chapter, I would like to invite everyone to the CRSA India annual meeting of 2020. CRSA India was the first international chapter of CRSA that was started in 2019 under the esteemed leadership of Dr. Palani Velu and Dr. Vivek Bindal, with a landmark inaugural conference that was held in August 2020. This year, amidst a pandemic, we are bringing a path-breaking and first of its kind virtual experience showcasing the best robotic surgeons from India and abroad. So with that introduction, now I'd like to invite my co-organizing secretary, Dr. Srivatsan, to say a few words and invite Dr. Palani Velu and Dr. Vivek Bindal to say a few words. Path-breaking and first of its kind virtual experience.
Good afternoon to one and all. On behalf of the organizing team, it is my pleasure to welcome Professor C. Palani Velu, Chairman GEM Hospitals Group and patron of CRSA India chapter. He is our teacher and the legend behind revolutionizing newer surgical platforms in India. He did that with laparoscopy in the early 90s and has done that once again with robotic surgery now. Hope to imbibe your energy and passion, sir. Over to Professor Palani Velu, sir, for a few words. Behind revolutionizing newer surgical platforms in India. He did that with laparoscopy in the early 90s and has done that once again with robotic surgery now. Hope to imbibe your energy and passion, sir. Over to Professor Palani Velu, sir, for a few words.
I think the recorded one repeating. Phone, please.
I think everybody mute your other device.
The other device is playing on the background.
So everybody mute the other devices.
I think
somebody has logged in as a delegate also.
Oh, yes. Anyway,
everybody mute your other device.
The other device is playing on the background.
So everybody mute the other devices.
I think somebody has logged in as a delegate also.
Everyone, please mute
control the phone call. You can make mute. Even during advice, will disappear, please. Okay. All numbers. It means it.
Everyone, please
control the phone call. You can make mute. Even during advice, will disappear, please. Admin can have power to complete mutate. That is better. Now it is silent. It's very nice. Okay. Friends, and good morning or good afternoon. We are at 12 o'clock and the time we start. I truly feel very happy to be part of this meeting. And this is a wonderful meeting where we have more than 500 delegates connected to us. And within the short time, we are able to do it. All the effort and appreciation goes to Vivek Bindal and two organized secretaries with him, and Srivatsan and Seth. True, and making entire scientific program very well, and for the beginners and for practice surgeons, it is very nice and well be done. And we have so many international faculties. I think 16 of them are there to connect all these next 3 days. All are world experts, so it is a learning for all the practice surgeons and linked to all the countries. It's very nice, and founding members all have taken a great effort, meeting multiple times, all these short period, and making and programming as well as getting it to. And all the founding members starts with, I will say, and Amit, Arun, Ashish, Avinash, Jagdish, and Surender, Venki, Jaideep, Mohit, R.K. Misra, Somasekhar. Truly, all of you have taken a very good interest in this meeting. Otherwise, making a 500 people in this short time, it is something is very difficult. And two young dynamic organizing secretaries, Seth and Srivatsan, I think they helped Vivek every effort making this program come to effect. And this is the second meeting. Virtually, we are all meeting, and globally, it is known now that Indian chapter of CRSA and holding this meeting. And it is a good promotion today. A lot of young surgeons will be becoming members of this society in future. And also we have a good sponsor, and we have an Intuitive, Conmet, Medtronic, Ethicon. All of them also taken great effort and participating and supporting us the events. I think today we are going to start by 12:15. All of us my sincere appreciation to all the founding members and the committee making this program. Hereafter, this association still more has to go higher level. With all of joint effort, we'll make it up. And we have a specialty like general, we have gastroenterology, we have gynecology, technology, and every aspect being covered nicely. It is going to be very useful. I'm going to attend all these sessions and from starts with now. And that way, it is a very great opportunity. And during this pandemic, people sitting at their own places, and it gives an opportunity for them to get connected to this one. And we tried to, for virtual different platform, we're developing it, wanted to connect to today. And unfortunately, our platform little delayed. Actually, last 2 days back only, I inaugurated that platform, Deliversity platform. It is going to have a very good HD quality, anyone can see. So our CRSA, again, Indian chapter, planned for a next live surgery workshop soon. All of us will sit together, work out. Today we have 3 days deliberations, and sometime later we'll have a live surgery using that platform. It provides you HD quality. Every one of you can link and can moderate, can talk and discuss, and without any loss of time, whether it is in India, whether it is Japan or America. That's what I want to do it during this time, but delayed, but we launched now. Anyway, since no live surgery we are. So I take the opportunity to thank you everybody, and appreciate Vivek and all the team founding members, and welcome all the delegates to be active participants in this conference, learn the best. See you nicely. Thank you very much.
Thank you, sir. Thank you so much. Next, I would like to invite Dr. Vivek Bindal, Vice Chairman at Sir Gangaram Hospital, New Delhi, and Chapter Regent of CRSA India Chapter. He hosted a wonderful inaugural conference last year at New Delhi, and he's the mastermind behind the virtual conference this year. A very energetic and a dynamic person who has taken monumental efforts in coordinating with various faculties, national and international, and the industries to set the foundation for a wonderful scientific program and a great conference this year. Over to Dr. Vivek Bindal for the few words for the welcome address.
Yeah, thank you so much, Professor Palanivelu, sir, for this kind introduction, Dr. Srivatsan and Dr. Daksh Shetty for doing all the effort and bringing this conference live. It is indeed a pleasure to see all senior founding members from across the country connect again in this pandemic on this virtual platform. And really, I think it was the idea of Professor Palanivelu to not miss the conference but do it virtually. We took on that idea, and I think it has come out very well. These are the rays of hope in this pandemic, where all of us can share knowledge, we can share wisdom, and we have had this conference with a lot of industry participation, new robotic systems, a lot of young surgeons putting in their abstracts. We have more than 50 abstracts. A lot of awards will be given for all of that. I especially thank our session conveners, Dr. Venki Mani Krishnan and Navneet Chaklani for the colorectal, Dr. Somshekhar for the gynae oncology, Dr. Amit Gupta, Dr. Jaydeep Paleb for the general robotics, Dr. Arun Prasad for the abdominal wall reconstruction and bariatric, Dr. Ashish Vashisht, Dr. R.K. Mishra for the general robotics and AWR. So it is a huge collected effort of everyone which has led to this day. And I think we just need to enjoy the proceedings, and we need to keep time. I would request all the founding members as well to give a short message, and then by 12:15 we will start the conference by a lamp lighting, that too virtual. Thank you. So Okay, can I request Dr. Jagdishwar God, Dr. Jagdishwar God, can you please say a few words? He managed the upper GI session very well, sir.
Yeah. Thank you so much, Dr. Palnivelu sir and Dr. Vivek sir. It's going to be a great mutual learning for all of us. Looking forward to listen to everyone and hope something robo make in India comes out. Thank you so much.
Yeah, we know your initiative. I think it is a wonderful initiative. Dr. Somshekhar, can we have a few words from you, please?
Yeah, it's what a good day for CRSA. You know, the dream of Vivek, which he carried from his teacher from US, and you know, it's his dream. I know, so the passion and the hard work he has put. 99% hard work of CRSA is Vivek and Palnivelu sir. 1% we are chipping in. Welcome all. What a good day for us, and this is a good message and opportunity and inspiration for us. What Vivek, then Srivatsan and Palnivelu sir has done for all the founding members. We build upon this and build a very big pyramid of CRSA, and this should be sort of the Asian leader, and CRSA International should look us as one of the most successful division they have. So welcome everybody, and then this is just the beginning. You know, this is the spark, and we need to really take this what spark Vivek and Palnivelu sir and the team has put as a founding member, and in coming years we have to make it into a very big pyramid. I welcome everybody, and then congratulations to CRSA, especially to the organizing team, and welcome all my colleagues. Thank you.
Thank you, Dr. Somshekhar. Dr. Kalan, sir, actually it was Dr. Kalan's idea. He pushed me. So I had been tweaking, but he really pushed me into doing this, sir.
Vivek, definitely a proud day for all of us. I think the Indian chapter of CRSA has grown so well. The last conference that we organized in Delhi, and in spite of the adversities, I mean, we were all scared about the pandemic, and we decided, I think, Dr. Palnivelu really said that we must go on. And the idea of the virtual conference, I think, was a great idea and very well executed by youngsters like Vivek and Daksh and all others from Dr. Palnivelu's team. My good wishes to all of you, and I'm very sure this virtual congress is going to be a great success. All the best.
Thank you, sir. Dr. Arun Prasad, please. Can you say a few words, sir?
Thank you, and congratulations again, both to you and your team and the team from Palani side. I think this is going to be a landmark event because this is one of the rare events where we've got a fantastic program as well as a great attendance. So just I'll end by saying congratulations to all the founding members and wishing everyone all the best, and looking forward to celebrate this at a later date. So Vivek, please don't finish up all the funds. Please keep some money for a grand celebration. Thank you.
Yeah, absolutely. I think this pandemic has taken out all the fun from the conferences, and I did just the science. Just the science is remaining. Dr. Amit Gupta, professor from AIIMS Rishikesh, can you please say a few words? You'll have to unmute yourself.
Amit, unmute yourself. Amit.
Yes, now we can hear you, please.
Yeah, thank you. A very good morning to Dr. C. Palnivelu, Dr. Vivek, and all the founding members of CRSA. After a great meeting at AIIMS Rishikesh, we are back again with virtual meeting. So, and the sheer number of the registrants that is crossed 500 is a storyteller in itself, that this CRSA India chapter is going to gain new heights in the coming future. Best wishes for this conference to all of us. Thank you, Vivek, for organizing this.
Thank you, Dr. Amit. Can I ask Dr. R.K. Mishra to please chip in with few words? He is the leading light in training in minimal access and robotic surgery.
Thank you, Dr. Bindal. And it's great to see the pioneer of laparoscopic surgery like Dr. Palnivelu sir, Dr. Arun Prasad, and it's our honor to listen their speech. And I'm just excited to see how this conference is going on. And I congratulate all of you to just get such a wonderful platform to address
bye
the
bye.
robotic surgery. Thank you very much. Thank you.
Thank you, sir. Dr. Avnish Saklani, can we have you give a few comments? You managed the colorectal session so well.
Hi, good morning, Vivek. Congratulations. It's amazing work that everything one has done and so many registrations. I'm looking forward to this great session, and this platform looks awesome, and congratulations to all of you. Great.
Thank you so much for your unwavering support all the time, Dr. Saklani. Highly appreciated. Dr. Ashish Vashisht, I can see him in a beautiful garden. Can you chip in with a few words, sir? You will have to unmute. We cannot hear you. I think. Can you remove this microphone? I think this microphone is a problem. You can directly speak.
Hello, can you hear
Yes,
me?
now we can. Yes.
So it's a special thanks to Dr. Penaliveli and Vivek Bindal for their big efforts. Now the robotic surgery has officially arrived in India, and so exciting to see this journey with all of you, the founding members and the pioneers in all the field. I feel it is the first dedicated effort by Sir Penaliveli founding members, and especially Vivek Bindal. Your energy is just inspires all of us, and let's go ahead today and make it a big success. It is the official arrival of robotic surgery in India. I'm very proud of it. Thank you.
Since you have to change your name, huh? I think you are.
I know this is my wife's number. My phone got broke, sir. So I'm sorry for that. I was outside, was connecting.
Host can change it, sir. The host can change the name.
Okay, sorry for that, but
You know, the wife is the most important person in your life. So that's
even he can change it on the Zoom. Actually, he can
yeah,
change.
I'll do that. I'll do that.
Even we cannot dare to change your wife's name.
I know.
Only for CRSA.
Dr. Jadip Paleb, the first disciple of Professor Giulianati and the first founding member of CRSA International. Can you say a few words?
I very good afternoon, everyone, and a big thank you to Professor Palnivelu in showing the way, and Dr. Bindal. Vivek, I've seen Vivek grow for more than a decade, and I still remember his vigor and enthusiasm when he first met me and said that I want to get into robotic surgery. The fruits of that today in the CRSA India and this 2020 conference with more than 500 registrations. I think it is just a fabulous job of making sure that robotic surgery is indeed arrived in India and is there to stay. Something which I always dreamed of when I finished my fellowship in 2007, way back, and that time there was no robots in India. But now I think we are going to see this grow like never before. So all the best to all of us today to take this dream forward.
Thank you so much, Dr. Paleb. I think we would also now like to thank other founding Dr. Mundari, Dr. Praveen Bhatia. Yeah, so we thank everyone for their efforts. I would request Pratik or Tarun or the audiovisual people to please play the Saraswati Vandana. Daksh, can you please coordinate that?
Yes, sir.
गुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं गुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं गुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं गुरुत्वं कल्याणम् आरोग्यं धनसम्पदः
I think with folded hands, all of us pray to Goddess Saraswati and invoke all the gods to help us achieve our mission in providing the best patient care and the outcomes, and may we be able to achieve good health for our patients, ourselves, and our families. So I think we already are in time, and we would now start with the other session. Professor Palanivellu, sir, would you like to just close the inaugural ceremony, and then we can move ahead?
Yeah, and we welcome all the delegates to begin our scientific session. I thank all the founding members and Vivek and Seth Srivatsan, all part of this. And this inaugural ceremony went on so well. I thank every one of you. We'll start the scientific program. So we'll close this inaugural ceremony. Thank you very much to all of you. Bye.
Thank you.
Thank you. So all of us can log in through the other platform, and here the Medtronic session will start. Thank you.
Okay.
Hi, good afternoon, everyone. And first of all, thank you for all the dignitaries, Dr. Bindal, Dr. Palanivellu, and all the esteemed conference members. I would like to share our Medtronic session. So before I start, I'd like to share a video from our Vice President Marketing, Mr. Mike Stowe. So let me just share my screen. Hello and welcome. My name is Mike Stowe, and I'm the Vice President of Global Marketing for Medtronic's Surgical Robotics Program. It is an honor and a privilege to kick off this session at the CRSA India Conference. I look forward to a day when we can be together in person, but unfortunately the COVID-19 pandemic has changed so many aspects of life. It's changed how we work, how we meet, but it hasn't changed the fact that your patients rely on you for surgical care. So on behalf of Medtronic, I thank you for all you're doing to fight this pandemic and all you're doing to provide care to your patients in these challenging times. We are honored to have the opportunity to partner with you as we address the world's healthcare challenges together. When it comes to surgical robotics, the Medtronic team is committed to expanding access to care and reducing variability through a portfolio of robotic and analytic solutions. India is an extremely important country for us, as we believe there's tremendous benefit to bring additional benefits to patients and surgeons alike. So with that, I will turn it over to Anshuman for the remainder of the session. And again, I thank you for your time. I thank you for everything you're doing for your patients, and I hope you have a great meeting. Thank you. Hello. Thank you. Thank you, everyone. Just give me a second while I get these slides up. Dr. Bindal, can you see my slides?
Yes, sir. Yes. Yes, we can see your slides.
Okay, thank you so much. So again, good afternoon, everyone. I am Dr. Anshuman Yadva, and I am responsible for Medtronic Surgical Robotics marketing in the Asia Pacific region.
I have a background in medicine, and after completing my MBBS from University College of Medical Sciences, I pursued an MBA from SP Jain, Mumbai, and thereafter joined the healthcare industry. Before I begin my presentation, I wanted to take a minute to thank each one of you. In fact, every healthcare professional participating in this conference for your heroic efforts to save lives during this global pandemic. We are honored to have the opportunity to work with you, and we are also looking excited to be with you at this conference to update you on our vision of robotic surgery and how the combination of digital surgery technology with robotic assisted surgery opens a world of opportunity to advance patient care. So rather than making this statement on every slide, I just wanted to get this out of the way up front. I'll be talking about some of the ideas that represent forward-looking statements about Medtronic. And I will also make some statements about a product or products that are still pre-market. So I just want to call your attention to these disclaimers about the nature of these statements. And these disclaimers are fairly standard. So they can be found on our website, investorrelations.medtronic.com. And I encourage you to read these statements. So I know this plenary session is called the future of robotics, but in order to get a good picture of the future, I think we need to be clear on where we come from and where we are today. That's the structure I have used for my talk. I feel this is important because for Medtronic, where we have been and what we have pioneered in the surgery is relevant to what we are going to bring to you in the robotics. And reviewing where we are today will give you the context of how we have designed not just our robotic technology, but our entire robotic business. So let's dive in, beginning with the history of Medtronic, where it has been. So this is really a story that begins in the 1960s when US Surgical was founded by Leon Hirsch. Leon, some of you may know, was both an innovator and an entrepreneur. And he partnered with clinicians to solve what at the time was the toughest surgical problems. So Leon had a vision that he could invent a better surgical stapler. And in fact, he created balsa wood models in his garage. From the beginnings of US Surgical, there was an idea of collaborative innovation, of two partnerships between the industry and the clinicians, and that has continued through Medtronic and Covidien. Importantly, this partnership wasn't only focused on the products. We have also pioneered and established the role of industry in helping educate surgeons and their OR staff on the medical technology and surgical procedures. We supported research that established the benefits of minimal invasive surgery, and that has identified the best practices in delivering efficient and effective care. So often these partnerships that solve the two barriers have limited the adoption of innovation, groundbreaking medical technologies, but it can uncover into how products can be improved, how cost can be removed, and how barriers to utilization can be overcome. I just want to bring this back to Leon. If you look at the image on your right, that is actually him. Leon is in 90s now, and we invited him to our robotics lab last year. And what you will find incredibly fascinating is that he's firing a surgical stapler on our robot. It actually brought tears to Leon's eyes as he reflected back on the balsa wood models, firing a surgical stapler on a robot. So coming to the next slide, I think let's take a little bit now about the dynamics that we are going on the field of surgery. So over 50 million surgeries are done worldwide in the categories where a soft tissue robot could be used. But over 60% of these surgeries are still done open. Below that, you see traditionally minimal invasive surgery, which is laparoscopy. That is about 30 to 35%. But robotics only constitute 2% of the global surgical volume right now. What is important here from Medtronic's perspective is that what is important for future of robotics. Because only 2% of the procedures are looked at the robotic platforms on the horizon. And they think, how is everyone going to compete in this 2% market? But that misses the point. the future of robotics is not 2%. This is about 90%. And this is what we are talking about today. Even more so, the 60% of procedures that are performed using open surgical techniques, that's the problem the market needs to solve, and we are focused on. Moving to the next slide, we believe that this is the statement we carry. It's our connection to the Medtronic's mission to alleviate pain, restore health, and extend life. It's how our team of hundreds of engineers and scientists have been approaching their work on day-to-day basis to solve robotics and analytics solutions every day. At Medtronic, we believe that patients around the world deserve the access to quality care and improved outcomes. And we will expand global access to care and reduce variability through a portfolio of robotics and analysis solutions. So how are we going to do this? So there are 4 key areas of focus. First, we are building a modular robotic platform that is designed from the ground up to expand utilization and therefore expanding the access to care. Modularity has the potential to expand the possible surgical configurations while also enabling components to be shared across operating rooms. So it not only increases the efficiency, it increases the utility within the hospital. As I mentioned earlier, our experience in the surgical instrumentation gives us the access to decades of expertise, allowing us to bring you to the market leading brands that have earned you your trust while leveraging the economies of scale to reduce the procedure cost. And next 2 technology vectors which I'm going to talk about are data and analytics and visualization. It really demonstrates the key that we believe in expanding access to quality care. So once we have deep insights into how surgery is conducted, insights how to improve our training, reducing variability and improving care. And in this line, we acquired recently a company called Digital Surgery. I'd like to say a few words about this technology in the next slides. So, some of you may know about Digital Surgery. They have, in the past, they have been developing the cloud-based platform for recording video and simplifying the user experiences associated with storing, accessing, and reviewing the surgical footage. In addition, the technology can automatically anonymize the recordings, overcoming the patient privacy concerns. I'm sure many of you must be familiar with Touch Surgery app also, which is one of the widely available solutions of digital surgery. If you still haven't installed the Touch Surgery app on your phone, I have provided a link to download it right away through this QR code. So you can actually go on to this QR code and download it. But the technology goes well beyond this first function. We are in the process of commercializing a capability that will automatically break surgical barriers into specific steps or the chapters. This will be developed and launched procedure by procedure. And we believe that is the real power in this capability, allowing surgeons to review their techniques and for departments to compare the variations across their staff. I think it is easy to see the potential of these insights in optimizing care and reducing the variability in outcomes. So we are very excited to have Digital Surgery partner with our business, and I'm sure you will hear more in coming days. Moving to the next slide, I would like to mention here that technology and hardware will not overcome the 2% barrier on its own. Enabling broad access to the quality care is only possible by partnering with surgeons and customers like you who will build the robotic programs. So as I noted at the start of the presentation, we are well positioned to do that. As an example, in fact, we are leveraging our global network to develop and implement surgeons and operating team training. This slide gives you a good sense of the scale and reach of our company. And it stands as a proof that we are truly, we have an ability to truly partner with the hospitals. Similarly, we will have access to companies' full commercial infrastructure, teams that you have already been working with to enable the use of surgical technologies. And in the last slide, in conclusion, I would like to say that we are going to talk about two things that drives Medtronic's vision for future of robotic surgery, where we have been, where we are today. And I hope that as a wrap up, you will agree that our company's history of innovation and collaboration is incredibly relevant to what and how it will be important for your robotic surgery solution. As for where we are today, I am going to draw back to that 2% number. Only 2% of the eligible procedures are done via robotic assisted surgery. And I would like to think over the next 3 days, how 98% of the patients could benefit with robotic assisted surgery. So together, I think we have a great opportunity to overcome the barriers and expand access to the more patients around the world. Thank you so much for listening in and enjoy the rest of the conference. I am happy to answer any questions which may have come. Dr. Bindal?
Yes, Dr. Anshuman, this is Dr. Daksh. We can move on to your next presentation.
Sure, sure.
Yes, Dr. Anshuman, this is Dr. Daksh. We can move on to your next presentation.
Yeah. So next in line is Ravi.
Audience
Ravi?
can ask the question in the Q&A section. So we'll take it at the end of the session.
Sure. We can do that. In fact, you can type in your Q&A and I can go through it and respond at the end of the session. And I would request Ravi Patel, who's our product manager for EBD, to start his presentation.
Yeah, thank you, Dr. Anshuman. Yeah, I'll start with my presentation on energy-based devices and surgical safety devices. We are very proud to introduce our latest innovation in the energy space, that is Sonicision curved jaw cordless ultrasonic dissection, which provides cordless freedom and cordless precision to you. So why cordless freedom is important? Because we feel that you can't afford to be tied up in an OR. The cordless device will help us to reduce the tripping hazards, for facilitate easier instrument exchanges, improve procedural focus, and also feel like a more natural movement without cords, and also improve freedom of movement and mobility. We have redesigned our Sonicision device, and now we have made our jaw of the ultrasonic dissector as curved with the good durable quality of Teflon, which can give precise access to the tissue planes. Also, we have intuitive single button activation mode, where single button can help you decide the energy mode you want to choose for your procedural step. If you want to use more of dissection, you can choose maximum modes. And if you want to choose more of coagulation, you can choose minimum mode. Both the controls are available in your hand, and in the sterile field, you can control both the steps. And also you can control the minimum and maximum mode in single step as well. We have also redesigned our battery and generator. Our battery is now giving more than 88% greater capacity intraoperative, so that one battery is enough to perform the majority of the complex cases like Whipple's, LAR, where the time of surgery is more. And also we have now double the cases than our earlier version. Now the battery life is for 200 cases. And our generator is now autoclavable, and there is no need of the torque because it has been made integrated in the generator design. And the whole bulky generator is now redesigned into a small designed generator which can fit to your palm. And it is having now 150 cases. So all of this will help us to reduce the reorder quantity and reduce the per procedural cost. I'll just play a small video on Sonicision curved jaw, which will describe overall benefits of the Sonicision curved jaw dissectors.
Experience the evolution of freedom of movement. From the trusted name in cordless ultrasonic dissection devices. Introducing the redesigned Sonicision curved jaw cordless ultrasonic dissection device. The cordless design reduces the challenge of managing cords in the sterile field and provides freedom of movement and mobility during your surgical procedures, contributing to a safer and more efficient OR. Available in 4 shaft links to help meet your specific need, the Sonicision Curved Jaw Cordless Ultrasonic Dissection Device enables secure vessel coagulation and efficient dissection in open and minimally invasive surgical procedures. The tapered design of the curved jaws enables precise access to tissue planes in confined spaces. The intuitive dual-mode energy button is designed to improve focus on the surgical field and procedure. The Sonicision Curved Jaw device has an improved reusable generator that is now autoclavable and enables 1.5 times more procedural uses than the legacy device. The improved battery can be used in twice as many procedures. The redesigned charger features a user interface that provides easy-to-interpret battery charge status and battery end-of-life indications, enabling efficient battery management. The non-sterile nature of the battery also removes the need for sterilization and streamlines preparation for reuse, and provides an 88% increase in battery capacity, which may mean fewer procedural delays due to mid-case battery exchanges. The Sonicision Curved Jaw Cordless Ultrasonic Dissection Device. Feel the freedom.
Yeah. The next is, we would like to thank you for your trust and confidence on the LigaSure vessel sealing technology, which has completed more than 20 years, and it has been used in more than 20 million procedures, and it is backed by more than 1,300 clinical papers representing around 63 countries. Now, our LigaSure devices like Maryland, Blunt Tip, Impact are coming up with nano-coated jaws. So we have added nano-coating layer of hexamethyl disiloxane, which is a hydrophobic material, on the jaws of the device, which help us to improve our non-sticking benefits, more effective cleaning, and lesser SR buildup. So enjoy the non-sticking benefit with our newer devices. The latest addition to our LigaSure portfolio is LigaSure Exact Dissector, which is an open device and which can help you to dissect with precision and a cooler jaw. The jaw of the LigaSure Exacts are 177-degree cooler than any ultrasonic jaws. So enjoy the extended version of the small jaw, because the blunt dissection capacity will help us to reduce the instrument exchange, and it will reduce the procedural time as well. We also have introduced our FX8 energy platform, which is an electrosurgical unit. We have introduced our next version of product after almost 17 years. And this is the latest generator in electrosurgical category, and which is more faster and give you the precision the way you want in your steps. We also have LigaSure 10, which is LS10 device, which is a single generator device, and it is a plug and play device for LigaSure technology. If your OR is already having electrosurgical unit, then and only upgradation of the LigaSure technology is needed, then this is a standalone device option available with us. We do have VeliLab FT10 energy platform, which is a combination of LS10 and FX8 Gen plus bipolar resection capacity, which is the fastest generator available with us in Medtronic. So enjoy our expanded advanced energy portfolio as well. We also have RapidVac smoke evacuator, which is compatible with all the electrosurgical units. It is compatible with our VeliLab energy platform like FX8, Force FX, and FT10 generators through interlinking cable, and optional accessories available to make it compatible with any other electrosurgical unit. We do have 4-stage filtration, which is ALPA filtration, a standard of care in terms of filtration, which provides 99.9995% filtration efficiency at the 0.12 micron particle size. The filter life is also a longer filter life, which is 25 hours of activation times. So the amount of time the smoke evacuation is active, that time is only calculated for filter, with reducing our overall per procedural cases, per procedural cost. The components of the smoke evacuation system are like vacuum source, which evacuates the smoke at maximum flow rate of 44 cubic feet per minute, or 1,246 liter per minute, and it can be of very used in the open procedure because the smoke has a tendency to get evaporated in open procedure to OR ventilation system. The filtration system is also all-in-one system where there is no requirement of pre-filter or post-filter. the pre-filter captures the larger particles in some fluids. Alpha filter captures the smaller particles. Activated carbon absorb toxic gases and odors. And the final is the post filter, after which the filtered air is returned to the OR ventilation. We have different tubings option available for open and lap, and also pencils varieties are available. So thank you very much for this. Was about our energy-based portfolio, and feel the freedom with ultrasonic dissection with Sony Cision Cordjo cordless ultrasonic dissection system. Over to Lakshay.
Hi, Ravi. Thank you. Thank you very much. And I will take the audience to our next generation of Signia as well as tri-stable technologies. Just start sharing my screen.
Lakshay, your video is not coming properly.
Is it fine now?
It's grainy, I think, but yeah, you can start.
Okay, everyone. So that was Signia. I'll just start with the presentation. Thank you. So hi, everyone. My name is Lakshay Bassi, and I take care of product marketing for stapling access as well as instruments. And today we are here to demonstrate our, the power in Signia stapling as well as tri-staple and the next generation technology in circular stapling. So as Anshuman had previously explained that, we have a very, very rich history of market leading innovations. In fact, it not only starts from 1990, it starts way before that when it comes to stapling. So in endoscopic stapling, in stapling, you see that, we have a very, very rich history of innovation, be it in the reload or it be, the stapler itself. And it was somewhere in 2011 that we launched iDrive, which was our first powered stapler globally. And the tri-staple was launched around the same time. Now, we are here to discuss and share, the Signia stapling system. It was launched somewhere in 2017 globally. And so this system is basically very, very smart. So when I say smart, it is, it doesn't really, it not really senses the tissue, but it also ensures that the speed that it will fire at, it should decide on its own. So this is one of those staplers, unlike any other stapler, which has its own small, cute little brain inside. So as you can see, It offers power rotation, articulation, firing, jaw opening, as well as jaw closing. So everything is powered, and nothing is sort of a battery operated thing where you just have to remove the battery. Now the next best feature is its smart feature. Now it automatically senses the tissue, and then it decides that at what speed it should fire. So if it feels that the tissues are too thinner, then it will fire at an optimum, a bit higher speed. And if the tissue is a bit thicker, then it will fire at a slower speed. So imagine this speed and the force at which it will deliver the staple is actually in its own hands. And the speed ranges from 5.23 seconds to up to 20 seconds, depending upon the tissue thickness. It has, you can actually see all these three different zones of its firing on the device itself. So whether it's zone 1, 2, or 3, the 3 being for the most, the thick tissues, it fires very slowly. And it tells you that I'm going to fire slowly. Now, the big thing with this stapler is 300 cases. Imagine only one stapler and 300 cases power that it gives you. And it will certainly relieve you of all the inventory that you maintain for 300 different stapler for 300 different patients. All you have to do is just get this stapler and keep on charging it and then using it. It has real-time feedback. It has a small OLED screen on the device where you can actually see what's the kind of reload that you have attached, what is the zone that the stapler is going to fire in, and it will also give you recommendations on the cycling of the device when you attach a reload, and it will also tell you how many firings are left in the battery, in the adapter or in the handle. It will tell you the battery status. It will tell you how many firings are remaining for this particular handle. So it will tell you a lot of information right on the screen itself, and you don't have to keep a count of anything. Okay. Another best part about this stapler is one unit that is compatible with more than 50 reloads that Medtronic has launched till date. So it has a universal reload attachment capability, and then you can attach any color, any size, any specialty. That's the best part. You don't have to worry about different staplers for different kinds of reloads and different types of specialty reloads as well. It fits in everything. Okay, now I'm going to share about reload technology, which is tri-staple, which I'm sure a lot of us are aware. So tri-staple is not just 3 rows, it's actually 3 staggered rows. And what it delivers is, it actually ensures that there is a very, very less stress or an optimum stress on the tissues, which actually allows greater perfusion because of its staggered or stepped cartridge. It allows more blood to flow in and more blood to go out, so that the tissue healing time is retained and there is no necrosis. And then finally, if you have variable tissues such as the stomach, where you can just, you should be least concerned of either a blue or a green, then you can just go with purple because that gives you a medium thick variation into the tissue thickness. So that gives you the kind of flexibility that you would want in a stapler across a variable tissue thickness. Now, tri-staple is not only present in linear stapling, but it is also present in specialty. See, the first one is a radial reload, which is good for your LARs. The second one is a curved tip reload, which is good for very, very tight spaces, especially in the thoracic cases. And then you have black reload, which is optimum for very, very thick tissues. Then you also have a very, very slimmer profile of 30 mm reloads for vascular access. And then finally, we have buttress material integrated reinforced reload with tri-staple technology, which actually ensures that there is no over suturing, and then you can actually have a buttress material while stapling the tissue. So these are the kind of specialty reloads that we have in our portfolio. And I would like to share one thing, that the innovation does not stop here. And we are proud to introduce to you in India that, a stapler that we have recently launched. It's called EEA circular stapler with tri-staple technology. So yes, you heard me right. Now we have a stapler which is there with 3 rows. And it is a 3-row tri-staple circular stapler, which actually offers maximum security than any other stapler and maximum perfusion because it comes with tri-staple. That's it. Thank you very much. And we continue to be on our mission of alleviating pain, restoring health, and extending life. Thank you very much. And over to the next presenter, Haridhar.
Yeah. Thank you, Lakshya. Hope I'm audible.
Yes, you are.
Yeah.
Please
Thank
carry
you.
on with your presentation.
Thank you, Lakshya, and good afternoon, everyone. First of all, I would like to welcome all on behalf of Medtronic for this esteemed conference. And my name is Haridat Kaushik. I am the product manager for soft tissue implant business of Medtronic, which includes wound management and hernia care. So I will take you through the hernia care portfolio first, where we are improving lives with the proven results. So in Medtronic, for hernia care, we provide the complete solution for successful results. So just to reiterate the worldwide usage of our hernia portfolio, we have one of the established brand name Paritex composite mesh, which is widely being manufactured. Like we have manufactured more than 1 million of pieces since 2000, since 1999 to 2017. And total mesh manufacturing, if we see, we are manufacturing more than 800,000 units annually. And with the latest of innovation in hernia care in the name of ProGrip, we are able to sell 2 million implants for ProGrip. So in hernia, we have complete comprehensive portfolio, and we started the hernia journey in 1988. And over the years, we have been introduced, we were able to successfully introduce many of the breakthrough products, which were first time in the world, like Paradex composite mesh we launched in 1999. And in 2000, we came up with the laparoscopic dissection device. And in 2006, we introduced ProGrip, self-gripping polyester mesh. And in 2014, we launched our latest innovative product named Relitech articulating reload fixation device. So over these years, we could able to successfully launch some of the breakthrough technologies into the market, which are ultimately helping and giving freedom in the surgeons and improving patients' outcome. So in hernia care comprehensive portfolio, in the bottom of this table, you can see we have a comprehensive portfolio spread it through lap anatomical meshes to the bilayer mesh, self-gripping mesh, and composite mesh. We also have a material of construct for mesh, both polyester and polypropylene, and with the dissection balloons as well. We also have comprehensive portfolio in fixation device like permanent and absorbable, both kind of product we have in our portfolio. So in mesh, you can see extensive laundry list of different kind of meshes which are suiting and suitable to the surgeon's need, which can ultimately help patients for early recovery as well. In the mechanical section, we have spacemaker, balloon dissector, and new product which is going to introduce is spacemaker pro, which will come with the structural balloon dissector and the trocar along with it. And in the fixation category, we have Prodac, which is well established in the market when most of the surgeons are aware about this, and Absorbatec with the absorbable fixation category, and Relitec, which is our latest introduction in fixation device, which gives freedom of articulation while performing any MIS surgery. So let me talk about composite mesh category. So this is one of the premium product category, and we are very proud to say that we have extensive options to offer to the surgeons, starting from Paritex composite mesh, which is the oldest in this category. And here you can have a material of construct polyester made up of multi-filament uh, and weight of 78 gram per meter square. The second layer in this mesh is made up of collagen, which get absorbed. Then second category product here is Symbodex, which is monofilament polyester mesh, which has a large pore size, macroporous in nature, with 3.3 into 2.3 mm, and the weight of mesh is 68 gram per meter square. Again, the second layer is made up of collagen derived from porcine origin, and with with the launch of Paratin DS, which is newly launched this in FY20 in 2020, we have been able to launch this polypropylene composite mesh made up of monofilaments, and the pore size is 2 into 2.4 mm with 46 gram per meter square of weight. The best thing about this mesh is the absorbable second layer, which is completely synthetic in nature and derived from copolymer of glycolide, caprolactam, and trimethylene carbonate and lactide. So this offers a different, which can suit to the different need of the surgeon. And in fixation category, the well-established product Protec, which is gold standard in fixation, is there in the market for last 20 years and has proven clinical improvements in hernia repair. With the Protec, more than 300 million titanium tacks we are able to successfully deploy worldwide. And the best part of these tacks is biocompatible and inert nature. So low profile of titanium mesh interface also provided with Protec. And in the absorbable category with AbsorberTech fixation device, which was launched in 2008, AbsorberTech is having a flexible cable drive mechanism, so which ensure every tag is delivered consistently. AbsorberTech device is even 2 times stronger than the competitor device in the market, and with the shaft self tapping mechanism, it helps surgeons to get more control in their hand. Realitech fixation mesh is providing the articulation while performing MIS surgery. 65 degrees of articulation can be delivered with this product. And Realitech device have a deep purchase tech, which demonstrates superior fixation strength compared to any other absorbable tacker. So these are the 3 different tackers that we have in our portfolio. Coming on to the ProGrip laparoscopic self-fixating mesh, this is a unique innovative product that we launched into the market, where the fixation requirement is not there and entire anatomy can be covered, where the fixation device cannot be introduced. With the more than 5,000 resorbable PLA micro grips on the surface of this mesh, helps in the deployment, and it stays there for a longer period of time. And with 40% of mesh weight is being resorbed. I would also try to play small video of ProGrip, although this is very And with Dextile, which we are going to launch soon in India market, this will add a new feather in our hernia portfolio. This is an anatomical mesh made up of polypropylene material, and with the large pore size that mesh has, provide the better tissue integration and transparency. This mesh is designed for efficient repair and easy handling, and the 3D anatomical shape ensures that large inguinal area is being covered with the mesh. So within 1 or 2 months, this mesh will definitely will be in your hand, and we would like to seek your feedback on this mesh soon. And with taking hernia repair further together, I would also like to touch upon the wound closure portfolio that we have in Medtronic. And wound closure is a heritage which is there for more than 108 years. We started the journey in 1909, and currently we have a very wide range of different sutures in this portfolio, starting with polyzorb, which is made up of polyglycolic and polylactic acid. And this suture has 140% out of package tensile strength. And the benefits and features of this suture is excellent strength, which provided by the suture, and which is ultimately helpful in critical wound healing period, and excellent knot strength with the excellent handling properties and very predictable profile of absorption. So this suture is excellent in nature with the V-lock. This is a
Hari, yeah, sorry to interrupt you, but I think the attendees have to join another session. So probably, I think, thanks for covering this. And I just like to summarize, you have seen the breadth and the experience of Medtronic's experience in the surgical platform. And we would like to just give a confidence to you that we are guided by our mission of alleviating pain, restoring health, and extending life. And we will continue to serve you with our innovative solution of robotic surgery and surgical solution in the coming days. Thank you so much, and all the best for the next sessions. We are really honored to be partnered with you. Thank you, Dr. Bindal, and thank you, Dr. Palani.
Thank you, Dr. Yadav, Dr. Kaushik, Dr. Patel, and Mr. Bassi. So I think it was a wonderful session, got a lot of insights, and I'm sure it is going to ignite a lot of interest in your new products. Dr. Daksh, can you take it forward, please?
Yeah. Thank you so much, Dr. Anshuman. And with this, we start the next session on general robotics. And I would like to invite the chairpersons, Dr. Jaideep Palep, who is a member of CRSA India, Dr. R.K. Mishra, the director of World Laparoscopy Hospital, which is one of the largest training facilities for MIS in robotic surgery, and also a founding member of CRSA India, and Dr. V.K. Malik, senior consultant and head of unit, Department of General and Laparoscopic Surgery, Sir Gangaram Hospital, and ex-senior professor, Maulana Azad Medical College. I would request him to call on the first speaker and then proceed with the session. Over to you, Dr. Palep.
Hi, very good afternoon, everyone, and thank you for joining us here on this session for general robotics today at the CRSA India 2020. And I welcome my co-chairs, Dr. R.K. Mishra and Dr. V.K. Malik. And without further ado, let me invite my very old friend and former colleague, Dr. Mario Anicchiarico, who is an Italian surgeon and a very famous one at that. Presently, he is the chief of the Division of Oncology and General Surgery at the Rumo Hospital in Benevento in Italy. And I would like Mario to start with his talk today. Mario? Mario, are you here?
Yeah, he is joining as a panelist in a moment.
Yep. So just to give a brief about Mario, me and Mario trained and did our fellowship training in GI robotics in 2006 and 7. Hi Mario, ciao Mario, come stai?
Hi, bene, bene, how are you?
Molto bene. I'm glad to see you. And without wasting any time, let me ask you to start your lecture. Will you please share your screen and begin?
Okay. Can you hear me?
Yes, very well.
Can I start?
Please.
Okay, thank you, thank you. Good morning to everyone. Thank you for this invitation. Jadip is my old friend that I met him when he went in Italy some years ago. He asked me to talk about can you see the screen?
Yes, sir. Yes, so we can see
Okay.
the screen.
Okay. So Jadip asked me to talk about how to develop a robotic program and how to set up a robotic OR. So I start my lectures with the shows of some key points of this lecture. In particularly, we will talk about the design of a robotic program, the purchase of a robotic system, the surgery cost, the implementation, the marketing of robotic surgery, and also about research and outcomes, and about the improving of efficiency and quality. Before the develop of a robotic program is very important to have a good program design with the consideration about some important aspects like costs, the population of the lands, and about your team, your surgical team. So if it's better to training a newborn surgeon or to recruiting a mature robotic surgeon. Both the choice can have some benefits and some cons. Also, it's very important to have an adequate surgical volume, almost 3 or 5 cases per week. And another important aspect in an hospital is a multidisciplinary approach to robotic surgery. Here we can see some costs, American costs about robotic surgery, costs of the system, costs of the instruments for assistants, and the other variable costs related to the execution of surgery. And also costs about the training and the improvement of our team in robotic surgery. After the starts of robotic program is important, even some details for the implementation of this type of surgery, like the design of OR. So we speak about the accommodation of the console, of the cart, of the anesthesia equipment, and of the old the technology that is included in the robotic system. We also must have a good space for the stock of surgical instruments. It's preferable to have a dedicated robotic OR for this type of surgery, even in terms of lead of training of the coordination of the team in robotic OR. Another important aspect is the training of the equipe, of the robotic team. And so I mean that it's very important the training of the surgeon, but even of the nurses and of all OR team. We speak about the exercise, the lab training on cadavers or on porcine models, case observation, video learning, proctorship in first procedures, and also is important to do a very good selection of patients at the start of the program, in order to avoid some difficult and some dangerous cases. About the implementation, OR team, in OR team are very important two figures, the nurses. So we speak about the organization, the configuration of the instruments of robotic art, and even is important for solving some technical issue during the surgery. And another important figure is the table-side assistant that is important for suction, for irrigation, for refraction, and for all things that the first surgeon asks during the surgery. Here we can see some example of what the table assistant do during the surgery. Here we can see the retraction. So with the laparoscopic tools, the assistant give a good exposure of the operating field to the surgeon. Here we can see the suction of smoke and of bleeding during liver resection. Another important role of the assistant during the surgery. And here we can see how the assistant can be very important during a surgery. Here we have a subhepatic bleeding during an hepatectomy, and with the help of the assistant, the first surgeon can control the bleeding, can put some stitches on the vein, and so we can complete the procedure with a good safety and a good result. Can we go on? It's important for the operating room team education, the observation of robotic surgery in other hospitals with a good experience, and so it's important even the training in dry lab, and in order to have to acquired important skills like connection with the robotic system components, calibration, and to resolve all troubleshooting that will have during the surgery. Another key points about this object is the marketing after the starts of robotics or robotic program. And so it's important to have a good promotion by the hospital. It's important to show the benefits of this technology. It's better if we can have even some paper on about this type of surgery. It's important to the promotion on hospital or surgeon website, and so all things that can promote have good outcomes about the surgery. So I think that is a very important have a database on functional and oncological outcomes. It's important to have some audits about our clinical results, and even about the economic costs and all economic aspects about the clinical outcomes. Enough is important even for implementation to have inside audits about your procedures, so you can have this with some video of your procedure is very important. It's important to have a good time pre-surgery, and to have even a good time of surgery. We know that robotic procedures are longer than laparoscopic or open procedures, but with the experience, with the training, is important to have more shorter time of surgery. So it's important even to have a good stock of instrumentation, and so in order to perform all scheduled cases, it's important to have backup instruments for some trouble during the surgery, and so it's important that all personnel is has a very good know about all the steps of the surgery. Now we can see some slides about the setup of operating room. This is a chronological line about setup. We can divide this step of the OR in two steps. So the step in which we draping the robot, but we can even start with the anesthesiological preparation of the patients, and then we have the step of the docking of robot on the table. Now we can see some short video about the docking and the preparation of robotic cart. You know that we have in XI model a touchpad in which we pre-select the side of the cart where we will position, will put the cart, and even the anatomical region of the patient where we will do the surgery. In some case, we can have even an integrated table motion that give the possibility of move the patient even with the robotic cart connect to the patient. Here we can see a short video about the draping of the cart, how you can see the nurse deploy the robotic cart for the wrapping is very easy in this type of Da Vinci, and then the nurse can draping the cart in a very easy way. So after the draping, the robotic cart can be put on table patients, and we select the anatomy of the patient after the draping, and we can docking the cart in a very easy way, how you can see, with the connect of the arm of cart to the trocar. So it's important in the docking the right position of arms. So it's important adjusting arms, flex joints, so that all them work in parallel, leaving a first wide spacing between the arms, bringing the patient clearance joints down, fist wide spacing between the arms and the patient, and less space is needed for robot movements. This is a shorter video about the position of the arms, how you can see the arms, the arms are in a correct position with a good space between the trocar in order to avoid some conflicts between arms. This is our ideal final setup of OR, with the 2 console for surgeon, with the anesthesiology equipment on the head of patients, and with the assistant surgeon and the nurse on the other side. This is a real imaging of the OR setup, and thank you for your attention.
Thank you very much, Mario. That was a very nice and concise presentation to give everyone in the audience an overview of how to set up a successful program. I think you've already been part of at least 4 successful robotic programs developed in Italy in major hospitals in different cities. If there are any questions, we'll take them all together later on. I will invite the next speaker, that is Professor Amit Gupta from AIMS Rishikesh, who is going to speak to us about robotic surgery, training and credentialing. Mario, please stay around for a while if you can.
Hello, Jaideep. Can you hear me?
Yeah, hi, Amit. We can hear you very well.
Okay. So, a very good afternoon to all and sundry. I start with my slides. First, greeting from AIMS Rishikesh. So, as already has been discussed by the previous speaker, that the field of the surgery is ever evolving field. So newer technologies and devices, they emerge, they keep emerging, thus paving the way for need for continuous education and training. Standardized curriculum for training and credentialing of robotic surgeons has unfortunately trailed behind the adoption of this technology. To address these issues, in June 2006, 2 broad bodies, surgical bodies, namely SAGES and MIRA, they came on the same platform and formulated certain standard operative procedures and recommendations for training and credentialing of robotics in surgery. So it was observed that simulation-based training can help tackle the barriers faced by trainee surgeons during their learning curves in a safe and controlled environment, bridge gaps between the safe acquisition of surgical skills and effective performance during live robotic surgery. The key elements of robotic training are enhancement of surgeons' abilities and competence, and alteration of the traditional direct local contact between surgeon and the patient. That is, there is loss of haptic feedback in robotics. So technical training and capability, you have basic knowledge and practical familiarity of the devices prior to the clinical use. Training should include how to safely and practically remove devices in an emergency, what to do if the system stops responding, how to respond if the system makes movements that are potentially unsafe to the patient. All such reasonably foreseeable situations must be anticipated, practiced, and understood very well. So this is the pathway for robotic training, but is commonly served by the SAGES and Myra group. That is online e-learning modules, virtual reality simulation, which follows mentored dry lab, and then there is a mentoring on the wet lab on some animal model like porcine model, and then there is modular training, and then the trainer sits on console on human body and becomes console proficient surgeon. So the algorithm goes like this. First, you have online e-module, e-learning, you clear the exam and you obtain a certificate. After that, you are exposed to video-based discussion of procedures and methods of avoiding complications and troubleshooting. Simultaneously, you are taught how to do trocar positioning, how to do docking and de-docking of the robot. And after you gain proficiency in this, then you are mentored on a virtual reality simulation on basic and advanced tasks. And when you do that task, you are of your each step and your task are given some score. That is robotic OSAT score, robotic objectively structured assessment technology test score. So you have to score more than 18 for each step or for each task. Otherwise, you cannot proceed for next higher step. So the main components of this are training, that is giving competence to perform robotic surgeries to the surgeon, and credentialing, which addresses the individual learning needs. Now here I want to stress upon this point that credentialing predominantly remains the prerogative of the hospital or the institution where surgeon is working. So these are the broad aspects of the training. You can have technical training and non-technical training. And remember that use of robot for specific operations, because all the situations demand very different specific set of skills. So on one hand, you can have a fully trained and competent laparoscopic surgeon who have come to you just to learn the finer nuances of robotic surgery. You just have to add specific knowledge of robotic technology to his existing skills. On other hand, you have a surgeon who has just begun his journey in the field of minimal access surgery. Like there are many centers in India who are now providing FNB in minimal access surgery, and MCH also in minimal access surgery, which was first started at AIIMS New Delhi. And with this July session, our center has also started MCH in minimal access surgery, which is now country's second such center. So as I already emphasized that there is a great role of simulation in robotic training. So these are 5 virtual reality simulators which are helpful in robotic training, but the 2 they are ROS simulated surgical system, which was devised by Buffalo Hospital, New York, and secondly Da Vinci Trainer, which was a byproduct of the combination of Da Vinci and Mimic Technologies, Seattle University, Washington. And cost is here an issue. If you are setting an OR of robot in your setup, then definitely if you are adding a simulator to the system, that cost definitely becomes exaggerated. There are web-based robotic training curricula like FRS program, which is similar to FLS program, which is has got accredited by American Board of Surgeons and ACGME board. There are Da Vinci intuitive technology training pathway also, which I will later comment upon. So these are the fundamentals of robotic surgery program. It is divided into 4 separate modules. First, you have to give introduction to surgical robotic system. In second module, you have didactic instructions for the robotic surgical system. In third module, you have psychomotor skills curriculum. In fourth module, you have team training and communication skills. So this is intuitive technology training pathway. They again divide it into 4 main phases. In phase 1, you have introduction to Da Vinci surgery product. In phase 2, you have Da Vinci technology training. And in phase 3, you have initial case series plan where some lighter cases are taken and skills application is taught and checked. In phase 4, you have continuing development or skills application. So you cannot jump any escape. You have to cross all the phases. You have to do phase 1, then only you will go to phase 2, like that. Now, on-site robotic assisted surgery training program are there, like one conducted by SAGES, other conducted by Robotics Training Network curriculum. This is online. Fundamental skills of robotic assisted surgery, that is FSRS training program. So this program was designed by Roosevelt Park Cancer Center, Buffalo, New York. This training program offers 3 levels of certification courses. One is basic course, which is of 2 days duration, then intermediate course, which is of 1 week duration, and then advanced course, which is of around 3 to 4 weeks duration. So this is how various modules in FSRS curriculum appears. You have module 1 where you go for basic console orientation. In module 2, you go for psychomotor skills training. In module 3, you again had basic surgical skills. In module 4, you have intermediate surgical skills. Here you are given some tasks, and they are a pre-validated task, and all your coordinated tool control, ball placement, needle handling, and 4th arm control, these things are checked. This is just an example. I just want to show the audience. And many metrics are measured here, like what was the task time, what was the distance by the hand, between the hands, tool out of view, how many times, tool collision during the performance of the task, and what was the tissue damage, whether it was there or not, what was the distance of the camera, number of the critical errors which happened. So these are certain parameters upon which the trainer is evaluated. Now, coming to surgical robotic training simulators, as I told that intuitive surgicals and mimic technologies, they both join the hands together, and this is the end result. This is the trainer, which is just like a small box which can be attached to the console, Da Vinci console, and learner can sit and do all the exercises. The exercises begin with simple exercises, they go to intermediate exercises, and then to advanced tasks. So this is a very beautiful robotic simulator, and we are lucky that we have this simulator at our center. This we have in our own experience noticed that this is a very big virtue and very easy to learn from this, because this is 95% near to the Da Vinci instruments. This is an overview of the curriculum content. You can see that you have the curriculum proposed by University of Orlando, University of Toronto, and then European associations have their own robotic curriculum. Then FSRS, I have already told. Then you have FRS courses, which are similar to FLS courses. So the problem here is that there is no coherence in any of these courses. Each course has its own set of tasks and its own set of skills. But yes, the ultimate goal is to achieve the competence in robotic surgeon, just providing a safe surgery and safety to your patient. So structured training curriculum is when you have online learning modules, that is where you learn theoretical aspects of the robotic training. Then you have virtual trainers, fundamental mechanics and maneuvers, which are essentials to perform robotic surgery. And then you have live animal labs or proctored human surgery. So proctorship has a great role in training. You do first few cases under proctorship or mentorship of a lead surgeon or an expert surgeon. He sees all of your movements, and then he can rectify your lacunae, and thereby you gain proficiency in cases. The lack of structured training curriculum lends itself to serious disparity in the quality of robotic training depending upon training location and specialty. Now, non-technical skills I was talking about, they are of paramount importance when we talk about team building, communication, situational awareness, and decision making, and task management and teamwork. When I say team, I mean to say together each achieves more. So a word about credentialing. In India at present, there are no governing bodies which are mandated for credentialing guidelines in robotic surgery. Credential requirement varies among hospitals, not competency based, but rather require a number of proctored cases. So any talk about training will be inadequate if I don't mention about Vatti Kutty Foundation and Professor Mahendra Bhandari, who have done a phenomenal job in imparting education and training in robotics. So they every year issue national and international fellowships, and this is their website. Every year by December they ask for applications, and I think by Feb or March they complete the procedure of selecting the fellows. There is a very stringent criteria which is being used for selecting those fellows, which are being paid, and it's a paid fellowship. They are being paid $2,500 per month. So in India, presently we have 74 Da Vinci system, 7 in government and 67 in private sector. We have more than 300 trained surgeons and 10 training centers. So this is just a map of the India showing the various training centers and the directors of those training centers. Now a new journey in India has begun. CRSA India chapter has last year been founded, and we are now in a planning to start some credentialized and MCI recognized robotic fellowships, which will impart robotics training in India. To conclude, there is need for validated training curriculum in robotics, global evaluation of robotic skills, and fundamental of robotic surgery training models need to be assessed, and there need to be standardized structured model which is applicable to national and international level across all the specialties. Thank you. Again, wishes from AIIMS Rishikesh. I'm open to any question and answer question session. I will like to answer.
Thank you very much, Amit, for a very nice talk and giving us an overview of how budding minimally invasive surgeon can gain accreditation in robotic surgery. And we will have the question at the end of the session after Dr. Yugaraja finishes his talk. And I would now like to invite Dr. T.B. Yugaraja. He's the head of Department of Robotic Surgery at the Kokila and Dhirubhai Ambani Hospital. I've also had the proud privilege of working with him in this department for 5 years and seen how Yugaraja has single-handedly taken this program to a different level altogether, not only just in Mumbai but in India, and shown the way for so many other private hospitals on how to develop an economically sustainable robotic surgery. Yugaraja is a very renowned uro-oncologist in this country today of India, and I don't think there is any person than him who can talk about how to develop this program, because now, because of his efforts, Kokilaben Dhirubhai Ambani has not one but 2 robots working regularly in a multidisciplinary fashion. Yugaraja, over to you.
Thank you, Jaideep, for your kind introduction. Can you hear me, Jaideep?
Yes, we are hearing you very well.
Yeah, thank you so much. I think it's my privilege to talk on this platform. As you told that, I think everybody wants robotic surgery now. So now, can we do this in a sustainable way? So this is the question everybody asks. So in my talk, I think it's a little bit overlap on Dr. Mario and even Dr. Gupta. So I think we may have little overlap, but still I'll be able to tell what I feel. So we know that it's an emerging medical technology, and it has opened new frontiers. Whatever we think as surgeons to have a minimally invasive approach to our patients, I think the dream has come true. So in a way in which we wanted to do it for our patients. And so now it has, we know that the future of robotics is that everywhere in the robots will be there. So that's what we assume that, in the future will be a world of robotics. And the question is that how successful we will be to and sustain this program. That is the biggest question. So we have, initial cost, per procedure cost, which is adding it to our procedure. So now whatever we do, new technology has to be cost benefit also, not only the technology benefit. So, and how surgeon training already Dr. Gupta has told, so how speed at which we can implement all these things. These are all important issues when we start a robotic program. So we know that, the world is full of robots now. It's more than 5,000 robots in India. Also, we have more than almost 80 robots. We're not lagging behind. So thanks to the Institute of Surgical and Vertical Image, and now they're targeting 200 robots in next 2 years of time. So that is how we are going to evolve. So now let us divide this into 5 major topics. The one by one I'll just explain. So the first is that the finances, when we look into the system, so we look at the direct cost to the hospital when the robot is bought. And we have indirect cost, that is associated material, training of staff. And we have many other accessory instruments which are used along with this, like sonography, intraoperative robotic ultrasound. So many things will be added into the cost, including air seal system. So now, before planning anything, so what we had, whenever I talk in this talk, so I think a little bit of my own experience when what we did in our hospital. So we created a committee, so which consists of administrator, anesthesiologist, surgeon, and a trainer, so that how to implement it. So when we procured it, we had a couple of meetings. So once the program started, then there was no role of committee. But in the initial procuring the finances, as doctors, we don't understand much about finances, the initial finances. So I think the committee is a very good opportunity. So that's what everybody should do it. And before procuring the reports, some homework is required. So for example, so we should understand what is the competition, to evaluate the development of other hospital programs, how they are doing it, how they are maintaining or sustaining the program. So everything we should have an initial plan. And then we have a patient population. We know that it's quite attractive to the patients. The robotic program itself is quite attractive, and the patient feels that they're being operated by highest technology. So that's what we have to take the advantage of this situation. And I think we are doing great thing by doing robotic surgery on this patient, and we should promote in this way. So patient population has to be taken, whether they are really into this understanding or they have awareness of this program. And most importantly, you can know that now robotic prostatectomy all over the world, almost 90% are done by robotic technology. Hardly 1 to 2% is done by lap and remaining by open surgery. So now, as been discussed earlier, so we have an initial cost. This is a burden for us. And in addition to that, we have per case disposable fees, almost we can say 1,500 to 2,000 US dollars. So that the cost remains the same across the globe. That is the problem with the Institute Surgical. So they don't decrease the cost when they go to the developing countries. And the most biggest headache for all of us is the maintenance contract. So it does get a huge amount of money. Unless that, so we cannot work with robot because now and then they give some problem and it has to be maintained. So now to answer this question, so now we have a little bit the new robots that are coming into the picture. Although we don't have scientific evidence or we don't have much publication about these robots, but they are there in our country now. One is already Cambridge is there almost in few centers, and now Mantra is coming up in a big way. So it is very similar to Cambridge. I think hope in future, so as surgeons we want to do the same thing in a lesser cost. Can we do that? So only disadvantage is not proven standard because Da Vinci has set a highest the technical level, so the other people will be hardly able to satisfy that to a surgeon. So now how to obtain this 2 million? So that is the main finance what I feel. So it's very difficult. So we have some way to combat this one. So we have central government, state government, funding grants, and then we have donations, and then we have patients, memorials, loans, and finally self. All these are possible. Many times it works in combination. I think we have to take in combination. Sometimes even the company gives on loan where you have to per case basis you can give the money back. There are many modules which are available, and to initiate a program, if you have a less money, you can go to a different one, and if you have more money, you can buy it. So all are available with the robot, both the Da Vinci and non-Da Vinci robots. So now to develop and successful and sustain that So I feel personally there are two important things. One is that creating a multidisciplinary team or a micro team, what I call, and identifying the lead surgeon. So when this surgeon, the program was started in our hospital, there was only one question. So who is going to lead the program? Because everybody, you have seen that, wherever the robot is not working properly or the program is not working, you can see that every surgeon says that, yeah, I'm the lead surgeon. It's not going to work in that way. At least one or two lead surgeons should be identified, and depending on the volume, and all other people will be supported by these two lead surgeons. And then all other things are there. We have to have maintained the operation time and operation procedures, and training is an additional to this one. So in our hospital, we started with a multidisciplinary approach, as Dr. Jaideep has told. So you can see that, all the disciplines came into picture. So although I was appointed as the lead surgeon, but important is the gynecology, gyne-oncology, head and neck, thoracic, bariatric, GI. Everybody played a significant role. Even Palap has done, a good number of cases when he was in our hospital. So the first thing we did is created the team, and the team includes anesthetist. So the one thing major mistake we do is that we leave out the anesthetist. No, it's important. And assistant doctors, excellent and very, very important. Nurses, technicians, supporting staff. We created a team in the beginning, and all of us had training, either in Delhi or in Belgium. So, and we started the program in 2012. I think we procured the second robot in 2017, and now almost we have done highest number of cases by any institute, at least in Western India. So when we did say that, when we say the leading surgeon, it is not that the surgeon is going to do the surgery in a different way. No, it's the same surgeon. Only thing is that in my specialty, the indications for robotic surgeries are huge. Almost 90% of the uro-oncology cancers can be managed by robotic technology. Otherwise, you see the numbers of other people. I think they have done a wonderful thing. And this is how a team evolves. So there is no competition inside the team, because we have two robots. We don't have time competition. We don't have anything. So we don't have any competition about the cases, because individual discipline is different. This is what the model works. If one surgeon says, this is my department robot, surgeon, if you do one case and after a month, if you do another case, the program is not going to sustain at all. At least 3 to 5 cases per week, preferably by 1 or 2 surgeons only. It is not like that the 6 surgeons do 6 cases differently. No, it is not possible, especially in the initial period. And identify one person. So what I always tell this in a private setup, especially, so the one person does and other person helps them, and they share the patients, and that's how the program sets up. Once the program sets up, then the finances comes into picture. Once the volumes builds up, the finances automatically go down. So everybody should learn the initial the method of implementation of this program. And then, so again, this has been explained earlier. So first few cases, so you have to have straightforward cases. So this just I gave an example of prostate. So because once the program starts, and if the program fails, if you have untoward complications, the entire world is looking at you. So be careful. And after that, once the complication appropriate trained surgeon, I think Dr. Gupta has told very clearly, team's competence is important. Why all this is important for economics? So now if you have one complication, the entire thing is going to change. So the patient is going to have to bear the bill, and everything is important for us. So then there comes the marketing, because by marketing, your cost, whatever, the finances are going to be looked after. So you have to market as a cutting edge technology, satisfactory results, and you have to have previous experience from patients, physician referrals. I think website, conference, social networks, everybody knows about it. You should have a wide marketing skills. So that is very important, because now as a doctors or as a medical profession, we always felt that marketing is not a good for us. So nowadays it doesn't hold good. Marketing is a part of our specialty. So you have to have internal review annually, discussion about among the robotic team, and presenting our experience and complication, and a surgical audit. I think surgical audit is one of the most important thing. So once you know this is how we are doing it, then how to improve the volume, how to improve the cost, so we can plan. So data collection, data analysis, very important. That's finally the outcomes which speaks, not the volumes. The outcome speaks, and then add to the volume, and when the volume is added, the finances. So then how to decrease it. So there are many ways of doing, decreasing the cost. One is that one volume, and another is decrease in the instrument use. So we use 4 to 5 instruments per surgery. So now we have started using only 4 instruments or 3 instruments. In specific situation, we use only 3 instruments. And only thing which is not advised is that, using the same drapes for the next case, and, we try to do that. That is not a good way to do that, but it's not acceptable. And even the drape should be discarded after each use. And we are in talks with now Institute Surgicals too. And the entire world is talking with them to increase the usage of this this instrument from 10 to 15. Hope that they will accept to this request. And to improve the efficacy and quality, so you have to have a surgical time. So we should have exactly how the flow chart goes in the inside the theater, start to end. So we should not have any delays. And then theater room requirement, equipment, supplies, everything has to be there. Because once the patient or even the surgeon becomes unsatisfied, then it reduces surgical workload. That means you don't feel like operating in the theater. So this is common with all surgeries, but especially because without instrument, we can't do anything in a robotic scenario. So then how to make a robotic program more affordable, reduce learning curve cost. That means you start training the surgeons while they are doing residency. No need to go for a separate training, paying around 2 to 3 lakhs. So it will add to the hospital. And reduce investment purchase, and you have to have finance initial investment, and then reduce instrument employed, as I told you, discussed earlier. So you have to reduce the number of instrument and try to take the help of the assistant ports, interdisciplinary use of robotic platform. And the important is that it's a competitive market. So more platforms are available now. I think with the reduced cost, I think this is how we are going to maintain the entire program. So not to get disheartened in the beginning, you have to have huge investment, but followed by very satisfactory results. So to launch a robotic high volume center, reduce the investment purchase, maintain cost. So only thing is that there are few things which are compulsory, like in urology. So we have to have a hydraulic steerers, because of prolonged surgery, we can't have any complication like DVT. The ultrasound machine, optional, especially when we do a partial nephrectomy, it becomes mandatory. But we were using laparoscopic ultrasound, which was there earlier, but now we have switched on to this. Once you are, financially viable, so I think you can add all this instrument to your armamentarium. So interdisciplinary utilization and recruit mature robotic surgeon. The initial surgeon who starts the program has to be qualified, and it should be able, he should have volumes. That is the most important thing. Especially this works for private setting. In government setting, it doesn't matter at all. As has been discussed, credentialating, proctoring, and learning curves. So only thanks to this robotic technology, learning is much easier when compared to robotic technology. So that has made many average surgeons like me to become, have good volumes of this type of surgery. Thank you so much. I think it's a brief overview. The individual finance is very difficult to collect, and because individual hospital has got an individual different way of calculating and the income and all those things. Thank you so much, Pale.
Thank you, Dr. Yuvaraja. I think that was an excellent talk in telling us how you created a successful and economically sustainable robotic surgery program. I would like to throw open the discussion and have any questions from the audience and the participants for this particular session to any of the 3 speakers, Dr. Mario, Dr. Amit Gupta, and Dr. Yuvaraja. Please feel free to ask for any doubts or anything related to how to build up a program or train, and we'll be glad to have your speakers talk about it.
Jaideep?
Yep.
Can I ask a question to the other colleague?
Yes, of course.
How much costs the robotic system in India?
You can get Jaideep.
Yeah, Yuvraj, how much does the robot cost in India, and what is like the in terms of rupees? And
the initial the instrument cost, the capital cost will be $2 million.
$2 million.
So the capital cost is the same that Intuitive gives it for any country. but
Yeah.
the working cost is probably a little different with respect to annual maintenance contracts.
In Italy, I think it's more expensive.
Yeah.
Yes. Because I think you still have
May I-
Abimedica
I
running
think,
in as an intermediary.
Yeah.
Wonderful
Yes,
talks.
Vivek.
I think I would like to thank everyone. Dr. Yuvaraja, a question to you. How do you convince the hospital managements for, robot being a good investment? Because I think it's very difficult to convince a corporate hospital that what they think is a big investment in PR. Do you agree, or do you think that it is not just PR, but financially in terms of statistics also it will make sense?
No, everything is in combination. We cannot isolate one over the other. So initially it was our luck, our chairperson, Mrs. Ambani agreed to get this one. So we could convince her. I took 3 years for that. It is not overnight. So I was from 2009 to 12. So I was behind them. Finally, we got it. Once we got it, the only thing which I felt was that, so as surgeons, we should be really enthusiastic to do robotic surgery. So many people, what happens once, even if after getting it, no, I do better laparoscopic surgery, why should I use this? I do better open surgery, so that doesn't work. And once you show the volume and there is no end, so they will give you whatever you want to do. So they want is volume. The initial hitch is the one which you have to do somehow. Otherwise, once you got the robot, it is your responsibility. A hospital will not be responsible for that.
I agree on that. And Mario, it was great to see you again. Great talk. I believe in the system you work in, it is a public system, and the money is being spent by the government for robotic surgery.
I think Italy, all the centers are governed government. It's a public health system, so all the robots are sustained by the local provincial government.
So
In Italy, there is a public system of health, and there aren't a specific refund of the robotic surgery or while common surgery. So for this reason, in Italy is even more expensive robotic surgery, because the public statement don't give a right refund of money to the hospital.
Is it done?
All right. So I guess if there are no more questions, I would like to once again thank all my three speakers, my dear friend Mario and Dr. Yuvaraja, both of whom I've had the pleasure of working with, and Dr. Amit Gupta from Rishikesh, AIIMS Rishikesh. And thank you very much, everyone, for being here. And we could probably move on to the next session. Dr. Dash,
Thank you.
can you take it from here? Thank you so much.
Sure.
Bye-bye. Ciao.
Thank you. Bye-bye.
Bye.
Thank you, Dr. Palep, and thank you, Dr. Palep. Thank you to all the speakers. Now we move on to the next session, that is AWR and hernia. And I would like to invite the chairperson for the session, Dr. Pramod Shinde, who is a senior hernia surgeon from Nashik and an executive member of the AWR SC, and Dr. Tarun Mittal, who is a senior consultant in the Department of General and Laparoscopic Surgery at Sir Gangaram Hospital, New Delhi. Dr. Shinde, over to you. Please unmute yourself.
Thank you, Laksh.
Sir, you are on mute again, sir. Yeah.
Yeah. Thank you, Daksh. It's a great honor and pleasure to be at this great event, which is the first CRSA India chapter conference. And it's my pleasure to be here on this session on hernia and AWR. And to begin the session, I would like to invite Dr. Vivek Bindal, who is the Regent CRSA India chapter, and in fact, the person responsible for founding of CRSA India chapter, and also the reason why all of us are here. He is the vice chairman of IMAS and bariatric surgery at the Sir Gangaram Hospital. He has many degrees and papers and accomplishments to his name in a short span of 6 to 8 years. Also visiting faculty to the Duke University, USA, and a teacher for FNB Minimal Access, one of the most highly reputed programs of DNB or FNB Minimal Access, and a great person and a very young leader to which all of us and the entire India and possibly part of this world is looking up to. So I invite him to talk on robotic abdominal wall reconstruction. Over to you, Vivek.
Thank you so much, Dr. Shinde, for those kind words. I think you have been extra kind. Thank you everyone for joining in. So starting this session, I'll talk about robotic abdominal wall reconstruction. That is something which is close to our heart, and Dr. Ramanna is here. He has been our mentor to guide us through this process of abdominal wall reconstruction. So I bring greetings from Sir Gangaram Hospital. This is our hospital where we work in New Delhi. We have been doing robotic surgery since 2012, so it has been more than 8 years. And the question is, why abdominal wall reconstruction? We have been doing laparoscopic hernia surgery for long, but why do we think about abdominal wall reconstruction? It is because of these kind of hernias. You know, this is a post-open cholecystectomy hernia. You see how big is it, and this is a post-laparotomy recurrent hernia, operated twice earlier, and you can see the bulge. You can see it is almost through linea semilunaris. And all these kind of things, if you want to do it laparoscopic, it cannot be dealt by just a lap IPOM. That is not going to give a functional result. And that is where abdominal wall reconstruction comes in. So, what are the steps of abdominal wall reconstruction? Basically, the abdominal wall reconstruction would involve the reconstruction of midline, the closure of the defect, the anterior and posterior closure. Just say, I think this just give me a moment. Okay, so this is kind of PowerPoint is hanging a bit, so I'll just continue. So basically, abdominal wall reconstruction consists of, you know, reconstructing the midline, the closure of anterior and posterior defects, and then placing a large piece of mesh to reinforce the giant visceral set. That is the concept of AWR, and some of these steps are pretty difficult to do with laparoscopy or even open surgery. So when you do it laparoscopic, it is difficult to suture, it is difficult to dissect, difficult to do adhesiolisis in these kind of difficult situations. And that is where the robotic surgery would help us. So I'll quickly move on to the video while the presentation is getting loaded. This is a 55-year-old lady who presented to us after an open appendectomy and open cholecystectomy with a large hernia. So you can see the entire bulge there. And on the CT scan, you can see multiple Swiss cheese defects right from xiphisternum to umbilicus with defect size ranging from 2 to 5 centimeters. So these kind of patients are good on her. This is the photograph of hernia sacs and the scar. So we are doing optical entry from left retrorectus space at the point where we do optical entry for ETEP, and then we have placed in a trocar in the suprapubic space. So we are doing a bottoms up approach here. The Da Vinci trocar has been placed, and we are now placing the other side Da Vinci trocar. So there are two working trocars, one midline optical trocar. This is the final trocar position, and the robot is docked. So after docking the robo, we extend the retroreactor space on the right side. And then we divide the medial edge of post-reactor sheath. So on both the sides, and then this is the area of linea alba. So we are moving along the linea alba, and these are the contents which are being reduced. So the robotic platform provides a lot of advantage in terms of maneuvering, in terms of stability of the platform, better deflection, and a very ergonomic console. So, you can sit on the console for a good 3-4 hours, do the procedure without getting tired. So this, we are approaching Xiphis sternum. So we started from pubis, we have dissected all the way up to Xiphi, and now we are doing the right TAR. So you can see we are going medial to the neurovascular bundles. We are doing the right TAR, and now we are freeing up the peritoneum laterally. Completing the TAR superiorly. So after we are almost, this is the diaphragmatic area, diaphragmatic fibers can be seen. And then we see that PRS can now be closed without any tension. So this is very important to close PRS without tension in these kind of cases. We are closing the post-reactor sheath here. With a barbed suture. And this is an absorbable suture. We will always close any kind of button holes also. So even a small peritoneal rent we would close so that there is no migration of mesh later or migration of ball inside this retroreactor space which we have created. And then we close the anterior defect. So this is being closed using the 1-0 non-absorbable barbed suture. And you can see the large Swiss cheese defects in the anterior wall. There were almost 6 to 7 defects more than 7 centimeters in size. So the entire linea alba from Xiphi till infraumbilical area is replaced by all these defects. And then we place in a large 25 by 23 centimeter polypropylene mesh. So it lies flat and we are fixing it with Xiphis sternum using sutures. So all this is done using these 4 ports, and you can see that the surgery has been done, and this is a post-operative result. Before discharge, you can see good cosmetic result, only 4 punctures and no bulge remaining. This is at the follow-up. So these are, there is another case which I would like to share, and this is a large lateral hernia post appendicectomy. You can see a large hernia there, which is a post appendectomy hernia, and it is through the linea seminaris. So if we see the CT scan, the linea seminaris is deficient, and these are very difficult cases to tackle. These are the lateral muscles, this is the rectus, and there's a large defect with bowel inside. And I'll just run the video first. So this is the left rectus space. Dr. Ramanna was there in this particular case. This is without crossover, we planned it. So we have entered the right-sided retrorectus space, and we are developing it. And now putting in the robotic trocars. Then we enter the sac from this extraperitoneal space. So ETAP is not totally extraperitoneal. We go intraperitoneal from spaces. We are now dissecting the contents of take care there is no bowel injury. So it is the initial entry is extraperitoneal, but then we go intraperitoneal. And this is the robotic system which has been docked now. So we are basically making the space. The previous surgery sutures could be seen around the sac. And the plan would be to do a right-sided TAR. So these robotic scissors are very versatile instrument. And they are very stable. And the 7 degrees of freedom provided by the robotic platform actually enables us to do this surgery very well. So this is the transversus abdominis being divided on the right side, medial to the NV bundles, which you can see up there. The visualization on a robotic console is also much better than what you see in laparoscopy. So here the lateral peritoneum is being mobilized from the transversus abdominis muscle after the TAR has been done in that particular part. So we gradually do the TAR, we move lateral, then we complete the TAR. So the TAR is being completed now on the lower side. And then we are suturing the posterior defect. So it was adequate mobilization to enable suturing without any tension. And this is the place where robotic system helps us a lot to be able to suture. Here we are using a 5 mm robotic needle holder, again with a barbed suture. And then we are suturing the anterior defect. This is being sutured along with the sac. So we take the sac so as to reduce any kind of seroma formation and good functional result. And after the anterior defect, we will place in a large piece of polypropylene mesh there. So this posterior component separation allows us a nice posterior and anterior closure and placement of a large 25 centimeter mesh. And so this is the patient after 3 months. You can see the bulge is all gone. And just these inline ports were there. So this was a very typical case of docking where we typically we use a triangular fashion in docking. But here we have used a different kind of docking. I think there was some issue with this PowerPoint, which so there have been articles which we have published, but I think this PowerPoint is hanging. So I'll just stop
Vivek,
share right now.
Dr. Vivek,
and, we can go to the next talk. Thank you.
Thank you, Dr. Vivek. It was a nice presentation and a lot of points of the benefits of robotic repair have been brought forth by you. I could see a question on the chat box and I have questions and maybe my co-moderator Tarun would have some. So my question was that position of the table break is what we do for laparoscopic E-tap repair, 20 to 30 degrees. So would that break also be required for the robotic platform, or robotic platform allows you to do cases with less amount of reverse break or no break at all?
Yeah, very nice question, sir. So we do the same kind of break for robotic platform as we do for laparoscopy. And but the only thing is that in order to change the position, like in laparoscopy, while we suture the PRS, we typically undo the break. And for doing that, we need to undock the robo, unless until you have a XI system with a table motion technology. So if you have a XI platform with table motion, you can change the docking, but it is typically not required. So also there was this question about can you rotate the camera and switch your anterior fascia on the floor? So yes, we can rotate the camera 30 up and 30 down, and we use it all the time. So like in the case I just showed, we had switched from 30 degree up and down. In SI platform, you have to manually switch it from 30 degree up to 30 degree down. In XI, you can just press a button and it will switch to 30 degree up or 30 degree down, and you can switch it to the position where you want to, so that you can you know do the requisite kind of switching.
Well, I had one more question to ask about your approach. ETAP approach was really more popular because of the ergonomics, because the ports come closer to the midline and suturing becomes easier. But in a robotic platform, suturing is no issue in any position, is what I get. So, and I know some centers who are using the transperitoneal approach rather than the ETAP approach. So why not use a transperitoneal approach with a robotic platform, since that ETAP ergonomics is not really all that required for a robo? First of all, am I right in basing my question, and what's your take on that?
Yeah, I think that's a very nice question, and there are different approaches. Initially, most of the people who started robotics in AWR did transperitoneal approaches, and a lot of them still do. In transperitoneal approach, mostly you will have to do a double docking. So you go from one side, you do a tower, you go from other side, you do another tower. So typically there are 6 trocars. But as you just had a look in this video, in an ETAP approach, we can do with just 3 robotic trocars and 1 assistant trocar. So you can do a bilateral tower. So the number of ports are less. The docking is not required to be done twice. ETAP is a difficult approach. So I think that is why people were doing more transperitoneals, but there are certain advantages to transperitoneal in some situations where you have to do complex visualizes. But if we are able to do ETAP, in my mind, I think there's nothing better than an ETAP approach. And suturing with robot is definitely easy, as you said. But if you are not docking it in a proper position, there can be a huge amount of external arm polishing, which can actually take away the advantage of robotic platform in suturing. So we need to be also also thoughtful of the fact that the kind of docking would also change the outcome in terms of ease of suturing.
Thank you. Thank you, Vivek, for a very nice talk and all the Q&A. I think they are past 2:50. So I would hand over the session to my co-moderator, Dr. Tarun, for the next talk. Thank you. Thank you.
Thank you, Dr. Shinde, sir. Now I invite none other than our Dr. B. Ramanna, Head of Department and Director, Department of Minimal Access Pediatric Hernia and GI Surgery, CMRI Hospital, Calcutta, and founder AWR Surgeons Community. Sir, over to you, Dr. Ramanna.
Okay. Thank you very much, Vivek and others. I will not waste time. There is very little time, so let me share my screen and I will start my talk. Okay, can you see my screen?
We can see it.
Yes, sir. Yes, sir. We can see your screen.
Thank you. And just let me start and say that the entire subject of lateral hernias is like a Dalmatian horse. You know that it may exist, but you don't really know much more than that about it. So lateral hernias are also like that. You know that lateral hernias occur and they do exist, but do we really know everything that we know about midline hernias? Not really. So here's a little more exposure for those who just have a rough idea, vague idea about lateral hernias. So causation, this is a patient who has a loss of domain, okay, from a post kidney transplant incision. That was a Battle's pararectal kind of incision, and that denervated the muscles completely and led to a huge muscle loss. Now this is an inguinal incision which gave way laterally and then led to a lateral recurrence. You can see it's also a loss of domain. This is a rare and very interesting case of an elephant injury in a temple that led to muscle loss with evisceration, and that led to a lateral hernia. So you get 3D reconstruction images like this, which are very exciting. This patient underwent an iliac bone graft for some orthopedic problem in his leg for bone grafting, and then subsequently he developed a hernia there. Now, this is a lateral hernia at the end of a chevron incision. That could be for Whipple's, that could be for liver transplant, or for any other upper abdominal surgery. Now, this lady had just a simple open appendectomy, and you can see what is the situation of the abdominal wall following that. This lady had a recurrent incisional hernia following a post-kidney transplant recipient area. So this is there's a kidney transplant right underneath it, and now she has a large defect here. So this is another iliac bone graft with a colonic injury. So obviously you can understand that when something like this happens, the mitigation by the surgeon would lead to a muscle loss, a muscle defect, and a subsequent hernia. This is a lateral hernia which has been caused post herpes zoster, and the patient develops denervation and bulging. Okay? So this is also a very unusual phenomenon unless you know that it exists. Of course, all sorts of parastomal hernias constitute lateral hernias for the most part. Now, a rare hernia, just for curiosity's sake, is a post-open TAR hernia. You can see this hernia created by the separation of the two meshes which were sewed together, and that made me realize subsequently that there should actually be an overlap between the two meshes, not just sewing them together, but actually having an adequate overlap. So this is a very interesting cause of lateral hernias. Now you all know that we have the EHS classification. Under the ribs is subcostal, and in the middle is flank, below is the iliac, and posteriorly is the L4, and it's all lateral to the linea semilunaris. So I will not be able to deal with the subject in any kind of detail because of the time. So let me go into why lateral hernias are difficult for us to operate on. Now, if you see that this is the linea semilunaris, the iliac crest is below, the rib cage is above, and the defect is further away to the side. So it gives you a very limited area, irregular myofascial area surrounded by bony structures. So the defect often doesn't want to get closed. And the area for proper mesh overlap is limited because of these same factors. So it's a very irregular shaped area. There's plenty of nerves there, and not all of them will be predictable in their locations. So the chance of you injuring one of these vital nerves is also significant. And here you can see that the psoas muscle is visible, the genitofemoral nerve and the lateral femoral cutaneous nerve are visible. And during the dissection, you can actually identify them, and ideally you should have a layer of fascia transversalis on it. And you can see that once you go above, you will see the ilioinguinal, and above that the iliohypogastric nerves. So these normally should not come in your regular TEP, TAPP kind of approach for inguinal hernias, but in the lateral hernia, you will encounter them and you should safeguard them. Now, another feature is that there is an associated atrophy of the muscles, also called a pseudo hernia or a phantom hernia or a lateral diastasis. There are various terms for this. Now, how do you approach these hernias? Now, one is, as a big one, you can go straight away for open. Now, you can go directly through the flank scar. So that's a lateral approach with, if you need medial overlap, you would need to get into the retrorectus plane by means of a reverse star operation. That's again a complex procedure which is not easy to explain in a few minutes. And if you want to go in through the midline, especially because there is a midline component, that is also possible. And sometimes you have to do both midline and lateral. Now, when we talk of minimally invasive, we talk of both lap and robotic. Ideally, it is robotic, but lap in good hands is also doable. So that could be a simple TAPP for a smaller defect, and it could be ETEP for any kind of defect. All right. So, and there is a hybrid which kind of makes the best of both worlds. Now, the ETEP can be a standard ETEP, which we all know, with a release, lateral release, because without the TAR, you will not be able to give lateral coverage. So the ETEP is only for the retrorectus coverage. Once you do the TAR, it allows you to go beyond the boundaries of the linea semilunaris. And we also can do a lateral ETEP, which means that you do not go medial to the linea semilunaris, you do not go retrorectus, but directly into the retromuscular space on the flank. Okay, so now I will show you a video of a lateral ETEP for a lateral incisional hernia. And for time, I will fast forward this. So this is that lateral hernia because of the iliac bone graft, and that is the defect. This is the CT scan. I'm just fast forwarding it, and you can see that. Now it's better to watch it a little slower. So that's the external oblique in pink. This is the internal oblique in green. And these are all now anterior to the defect. That's the transversus abdominis. Okay. The psoas is on either side of the vertebral column. The quadratus lumborum is behind and lateral to it. And these are the erector spinae muscles. Now, when you're dealing with these flank hernias, it's important for you to identify every one of those structures by name. And that is how you will correlate with the requirements of the surgery. Oh, sorry. So I will, yeah, let me, okay. So that's the hernia that you saw, and this is the metal prosthesis in the hip joint from the previous surgery. Sometimes you may also find an inguinal hernia along with a lateral hernia. So don't forget to check for that, because you need to cover that part as well. Okay, so the patient is turned lateral, bang lateral on the wall table and strapped properly, and there is a break in the table. There is the usual stuff, the SCDs and the padding and all of that, and you mark the boundaries of your lateral compartment, and all your ports are lateral to the linea semilunaris, and they are in line. They can be in one straight line. So the central port is your camera port for the starter, and then you use the two accessory ports for your left and right hand instruments. Okay, so the way you can go in is either through an optical entry. Now this is a case where we did a transperitoneal optical entry, eyeballed the hernia contents and reduced them, and then we went extraperitoneal. You can see this is a transperitoneal view of the colon inside, and we reduced the content and then we went extraperitoneal. So you can use the Phillips technique to create an extraperitoneal space for your trocar, and then that is fixation of the skin around the trocar to prevent leak. Now the three instruments will be put inside, and the space is created either in the preperitoneal space or in the pre-transversalis space, as you see here. There's good reason to stay pre-transversalis if you can, but really if the plane, the preperitoneal plane is very giving, then take it. Then just go in the preperitoneal space. So you can see that it's a combination of blunt dissection and sharp that takes you further laterally, and you can see the transversus muscle fibers are in the ceiling, and now we are reaching the edge of the defect. So that is the hernia defect, and we will be dissecting all around it. And in a big defect, you will have to be patient and dissect all around it. And remember that in all these lateral hernias, the external oblique constitutes the anterior limit of the defect. So there's always intact external oblique. That's the external oblique you can see from inside, and that is compressed fascia transversalis. So we are reducing the contents and the sac gradually. And again, I'm just taking this faster. So once we do that, you will see that the defect has been fully delineated, and then we have to create the rest of the space towards the pelvis. And that is a very important part of the operation, because again, the myopectineal orifice has to be dissected completely, preserving all the important structures like the nerves and the vas, etc. So you can see that the dissection is now going towards the psoas fascia, which is very dense. You can see this is the psoas fascia, and we are not going underneath it, we are staying on top of it. Laterally, because the colon is there, we are mobilizing extraperitoneally the right colon, and that will continue till you can see the inferior vena cava and even beyond that. You will see this now as we are mobilizing the kidney and the right colon. That's the psoas muscle and the quadratus lumborum. You can see that. How tenuous these adhesions are going to be depends on the case. If it's a reoperated case, it will be more tenuous. Otherwise, there will be planes for you to find more space medially. So medially, you keep on mobilizing the kidney and the right colon. This is the right side, of course. And you can see the gradual appearance of the inferior vena cava now towards the center of the screen. You can see that. That's bang in the middle. You can see there. There you go. So that's one of the most important landmarks of your dissection. And you have to expose this throughout the length of your operative area. Okay, so we are now looking at the defect, and now in many of these cases, you cannot fully close the defect because it is bounded by bone. So you can take bites on the compressed fascia transversalis and the undersurface of the external oblique and flatten the defect. So instead of a deep saucer or a cup, it becomes flat like a plate. So it provides a platform on which the mesh can integrate itself. So this is exactly what we are doing circumferentially. And you can see that now that big hollow is getting flattened out, and it will provide a template for the mesh. So unless you do that, the mesh can once again eventrate out just like we see in IPOMs. So that's the closure of the defect that you see that. That's probably the last couple of bytes going reverse. And then we measure the defect. It's an irregular defect. So you have to be careful about tailoring the mesh and take your time tailoring it properly. So it saves you a lot of hassle inside. So you roll the mesh and there you go. So you just pull the kidney and the colon, which you've already mobilized, pull it medially, let the lower edge of the mesh cross the inferior vena cava going past the psoas major. Yeah, let that lower edge of the mesh all along go medially, as far medial as you can. And then you just let the organs roll back into position. Now, fixation has to be very carefully done. If you are not careful enough, you may take one of the nerves, leading to severe postoperative neuralgia and pain. Okay, so that's the remaining part of the fixation. We are rolling the mesh on the ceiling, and at the ceiling there is not much problem fixing it with tacks or sutures as you see fit. And it's important that the mesh is flat, and you just go inside the peritoneal cavity and take a look at how it looks. And that is all. Okay. The key points in ETEP for lateral hernias is that you must give adequate overlap. If you do not, you're going to have a recurrence. So typically the lateral edge of the mesh should go up to the midline, and in lateral ETEP up to the linea semilunaris. So what you saw was a lateral ETEP, and the reason I did a lateral ETEP was because the lateral edge of the defect and the linea semilunaris, that distance was around 8 or 9 centimeters. So anything more than 7 centimeters give you adequate overlap, and you don't need to violate the retrorectus space. Otherwise, you go from one side of the linea alba, retrorectus dissection, TAR, and then go all along, cross the IVC and psoas, and go up to the medial edge of the psoas. So the fixation options are limited. Okay, so don't try to fix it. Overlap is what is going to get you the stability needed. So the publications on this are very few. So Yusuf Qudsi has one publication on this, and the Gangaram team has recently published a case report. I think Vivek showed the operation, and I'm grateful to be part of the team. And otherwise, the results of this operation are totally dependent on your technique. So this is a patient who has had ETEP TAR for both a midline and lateral defect, and you can see the stability. So sometimes you may need to do an open operation, and when you do a minimal invasive surgery, the results are not only functional, but also cosmetic. So this is a very complex parastomal hernia, which was repaired by open technique. Anyway, I will not go further into those details, and I will conclude and invite you to join us all on November 7th for an online intercontinental conference with Australia, New Zealand hernia. And thank you very much once again for the opportunity.
Thank you, Dr. Ramanna, for such an excellent talk. As the organizer wants to skip the questions and to start with the panel discussion, so I invite Doug to start invite the panelists for next panel discussion.
And thank you, Dr. Tarun. Thank you, Dr. Ramanna, for a wonderful talk. Now I would like to invite the moderator for the next panel discussion, Dr. Jignesh Gandhi, Senior Professor and Head of Unit, KEM Hospital, Mumbai, and the panelists, Dr. Arun Prasad, Director of Robotic and Bariatric Surgery, Apollo, New Delhi, Dr. Mukund Ketan, Senior Consultant, Department of Minimal Access, Metabolic and Bariatric Surgery, Sir Gangaram Hospital, Dr. Pavnindra Lal, Executive Director, National Board of Education, and Director and Head, Department of Surgery, Maulana Azad Medical College, Dr. Vivek Bindal, Vice Chairman, Department of Minimal Access, Metabolic and Bariatric Surgery, and Regent, CRSA India, and Dr. Ramanna, Head of Department, Director, Department of Minimal Access, Bariatric, Hernia, and GI Surgery, CMRI, Calcutta, and the founder of the AWR Surgeons Community Trust in India. Thank you. Dr. Gandhi, please take over.
Yeah. So I'm starting my time now. Good afternoon, everyone. At CRSA, Vivek has done a great job. So without much delay, we will start with this panel discussion. As you have already seen, we have got an eminent panelist, team here, and we're sure we're going to generate some great discussion. So the plan for the next 30 minutes is I'm going to have one question per panelist, preferably a single response. If you can give it to the question, and if we have time, we will have additional opinion. We will go through some literature review as we go through along with the expert opinion. And then we will come to case-based discussion. Again, this I will be putting it up to individual panelists. And I would request a panelist to try and answer in a way that a surgeon who wants to start a robotic, maybe what you would expect out of him. And at the end of the session, we will try to summate what we have concluded. So when I was preparing for this discussion, I just put on the PubMed robotic hernia, and you can see just 600 odd articles. So it tells us that today this is still in the stage of infancy, and there are a lot of other things which need to be done to see that how robotic hernia cases can build up. So let's start with Dr. Ramanna. I would like each of the panelists to unmute themselves. Dr. Ramanna, what value addition do you think robot has brought in the field of hernia today?
I think that's a very broad question, but it's a very important question. There are very complex procedures which are beyond the pale of most laparoscopic surgeons. in AWR, there are plenty of procedures which the majority of laparoscopic surgeons will not be able to do. Even a lot of open general surgeons would not be able to do those. The robotic platform makes it possible for these surgeons to do complex work safely because they can see far better than they can see with an average laparoscopic setup. And the difficulties of an operation are overcome with the robotic platform, but not completely. I mean, it's made easier. And a lot of these open cases can be converted into minimally invasive procedures thanks to the robotic platform.
Okay. So the basic advantage, as you rightly pointed out, for the robot, and we have re-emphasized, is better visualization, better ergonomics, because that's the reason we can take up more challenging cases. A single docking option, as we can see now with the X-ray robot and the boom concept, better instrumentation because we have to suture at odd angles. We just finished a talk on the lateral hernia, and we know that you have to suture at a very odd place or place the mesh. And competitive environment today with more and more companies are giving an advantage to the surgeons in terms of robotic and hernia. Dr. Lal, you are with us here. What, according to you, should be the case selection criteria for a groin hernia repair? Mind you, I'm talking everything only about robotics. So what do you think we should start off with in a groin hernia as a robotic case?
Well, so very good afternoon. Thank you very much for making me a part of this panel. Jignesh, it's been 21 years now since I have been doing laparoscopic hernia repair. I started with inguinal hernia repair. And till today, I have not found a reason enough to justify getting a robot for doing or accomplishing an inguinal hernia case. Having said that, there could be intricate, special indications where one could like to do a robotic inguinal hernia repair where it is recurrent many times and there are challenges. It is some of those cases were shown by the previous presenters, Dr. Vivek and others, and Dr. Ramanna as well. But in general, I would not think that a normal laparoscopic surgeon needs to get to a robot.
So probably you would, probably you were trying to say that if it's a complexity of the case which you will decide for the groin hernia, rather than just the indication that the patient comes to you with a simple direct hernia, that you'll be doing robotic, right? Correct me if I'm wrong.
Well, what I want to say is that for accomplishing any kind of a routine inguinal hernia, whether it is large or small or recurrent, you do not need to resort to a robotic hernia repair. However, if you have the access to a robot, then possibly for certain situations or certain complicated conditions, it could be providing additional, use.
Okay. Vivek, do you think robot is just a new technological tool, or it has really helped the surgeon get over the learning curve in complex hernia cases? What do you feel, Vivek?
Yeah, I think it is just a technological tool. So learning curve is there, AWR learning curve, ETAP learning curve is going to be there. Robot is not going to take it away, but yes. So, once when I do a robotic ETAP TAR or when I do a lap ETAP TAR, at the end of the procedure, I am much more comfortable after doing a robotic ETAP TAR. But that does not take away the learning curve. Learning curve remains the same, I would say.
Same in both of them. Okay. Mukund, how easy or difficult you think it is for a surgeon to adapt robot for a hernia surgery today?
Thank you, CRSA, for involving me in this ARWR part of discussion regarding the robotic use. So to adapt robot for the hernia surgery, it is not as difficult as we adapt from open to laparoscopic repair of an hernia, especially when we talk about an abdominal wall reconstruction. Because as Vivek said, and as the initial talks were there, where we see that the robot is definitely giving us a better visualization, as you said, a better ergonomics, a better easy suturing. As Vivek said that it is a longer same learning curve. I will say it has a shorter learning curve because it is easy to learn suturing by robotic as by laparoscopic because of the ergonomics and the vision, the 3D vision, which gives you, and the camera is in your control. So I'll say it is easy to adopt a robotic repair as compared to laparoscopic, but one has to go through open lap and then robotic platform rather than skipping the laparoscopic part.
Okay, fine. So your crux is that laparoscopy is a bridging for you to go from open to robotic. I think that's a good valid point. Arun, you are here with us. Arun, do you think in future robot will replace laparoscopic surgery if the cost of the robot comes down? Your view, Arun. Arun, are you around? Vivek, can you take this question if Arun is not around?
Hello. Can you hear me now?
Yes. Yeah, Vivek. Yeah, Arun, we can hear you now. Yes, Arun.
Yeah, sorry. The answer is no. It will not take over. And if you could give me a minute, I'll make one sentence comment for the previous questions. Your first question about the advantage, I think the sole advantage of robotic is the articulating instrument. If you ask for a single advantage. Number two, talking about inguinal hernia, I think inguinal hernia robotic surgery has absolutely no role except if you are doing the hernia surgery along with some other robotic procedure. So concomitant
Arun, I will come to that separately. Right now, let's focus on my question because I have that question.
No, you had asked Pawan that question,
I know,
so that's why I answered.
No, I remember, but then I'm coming back to you for the groin hernia specifically. It's a 30 minutes. We are just 8 minutes and 3 seconds now. So I will come to you. So your answer is that no, robot will not replace even if the cost comes down, correct?
No. And one of the important reason is that the tactile feedback which we need will never be the same with the robot. So robot, I think maybe for complex incisional hernias, yes, but otherwise it will not replace for other straightforward hernias.
Okay, sure. Dr. Lal, this is the next one coming for you. Presence of robot in a teaching institution, would you think it would be a game changer? Because you and me both are from a teaching institution. Do you think it will make a game change for us?
So as a general answer, yes, it is a game changer because it is able to give us many other reaches because of the ergonomics, because of the articulating, because of its reach. Yes, a training institution or with high volume, minimal access surgery must invest in a robot. That is a single answer for this. However, as we have already said, there are limitations for its application in hernia.
Yeah. So second question, Dr. Lal, do you think companies, because I'm sure they are hearing us, should have a different capex for medical institutions so that we can train more surgeons? What are your views on this?
Absolutely. I think we need to have, the main companies which are investing in robotic must come in and partner with the training institutions, the majority big ones in major cities which have high volume centers and training programs, especially fellowship programs, so that the capital inlay investment is kind of compensated for, and we are able to give high volume, good quality research, which can be from the Indian perspective for various kinds of procedures, including complex and complicated procedures in hernia.
Okay. And do you think you at the head of the thing, a super specialty course in robotics surgery is going to be the near future?
Yes, it is a possibility. We already have a fellowship program. We would definitely need. Basically, I would agree. There was a talk just a couple of days back in which we had the opportunity to interact with Sir Alfred Kusheri, and he very rightly pointed out that it is not robotic surgery. It is robotic assisted laparoscopic surgery. A robot still assists a laparoscopic surgeon. So keeping that in mind, it is a skill which needs to be enhanced, and there need to be high-end focused fellowship programs in high volume centers which train our trainees in robotic surgery. There is definitely a role of it.
Okay, great, thanks. So just to summarize what if you see in the literature which is just published this year in April, they have come out with an indication in the robotic that RTAP is a safe and effective option for unilateral and bilateral inguinal hernia. So this is what the evidence we have from the URIs group, that they have recommended TAP as a robotic option. And again, to emphasize what Dr. Ramana said, the current perspectives in robotic hernia, again published in 2017, emphasize all these 3 points. And the most important was that complex abdominal wall hernia should be done in robotic way. Dr. Ramana, again coming back to you, how do you select your cases for robotic ventral hernia repair? So how do you decide if you have two patients, same criteria, same demographics? How do you say this is for robotic or this is for lap?
If possible, I would like to do every minimally invasive procedure by robotic platform, simply because of better visualization, more stability, and it's simply a superior tool. I just look at it as a tool for a laparoscopic surgeon. As Pawan said, it's RALs. So I don't look at it as either or. I look at it as part of the toolbox of a laparoscopic surgeon. It's like you having a 1688 and I'm doing it with an old single chip camera. So
and how do you and how do you counsel your patients for the cost benefit ratio, because this is very important today when we are in a competitive world? So how do you counsel your patients or convince them for robots?
I'm sorry, to answer your previous question completely, any parastomal hernia, any kind of obesity where a complex AWR has to be done, I would prefer a robotic platform to a straight sticks platform. So my counseling will be appropriately directed towards that kind of patient about the costs and the benefits according to that.
Okay, so when you see a hernia on clinical examination, you know that when you start the counseling, you will start it with robotic to begin with only. I think that's a very good message we should have. And how do you think one should get trained in the robotic today? Do you think the way is mentorship or it's a formal training that you have to spend a couple of months in a center, or you need to do a certificate course? What do you think is the right way
There
today?
are three things. One is knowledge of anatomy. Number two is constant access to the device. And number three is mentorship and proctoring.
Okay, good. So I think that summarizes it pretty well. So if you see the cost analysis of robotic versus lab, this article did mention that the patient-centered clinical outcome can be identified well. And what they mentioned in that was that robotic, we believe that robotic is not an effective use in the limited healthcare. So this was in 2016 SAGES, where they said that it is an expensive tool, but I think the concept is changing now. Question for Vivek and Arun, both same set of questions, one by one. How steep, Vivek, we'll start with you, is the learning curve for robotic hernia? Do you think a bridging course in lab AWR is necessary before going on to robotic?
Yeah, see, if we talk about AWR or TAR or posterior component separation, it is a steep learning curve, basically because of the difficult anatomy, not because of the use of robo. But bridging course in laparoscopy is not something which is absolutely necessary. So there are surgeons who have switched from open to robot directly. And actually they have done better and they're more convinced of the technology because they have not been able to learn laparoscopy. That's why they were open. So we have examples of very prominent robotic surgeons in India who never have done laparoscopy in their field. So it is not necessary, but yes, if you know laparoscopy, it helps you get into robotics faster.
Okay, what do you think, Arun, about the same thing?
I would like to differ slightly. I think a laparoscopic knowledge of the anatomy is very important. Otherwise, without the tactile feedback, with the robot, you can easily go into the wrong plane and make mistakes. So some anatomical exposure laparoscopically is important, but the learning curve is much less than the laparoscopy. That's where I agree with Vivek.
Okay. The second question, Vivek, again to both of you. Why do you think in India we have not picked up in robotics? So is it the robot or lack of training or caseload is less or acceptance by the surgeon? Vivek.
See, I think it is basically because of access to robotic system, the cost, yes, and the type of cases. So I think all of us agree that there is not a lot of advantage of doing inguinal hernias with robot. So we have been doing robotic for last 8 years, but we have not done any inguinals using robot. And most of us are good laparoscopic surgeons, so we are able to do it. But now, AWR business coming in, we are able to place a cheaper mesh in a better retrorectus plane. And that takes away the cost difference which used to be there in laparoscopy and robot, because we save on almost 70 to 80,000 on the dual mesh and tackles, and that is the extra
Okay.
cost of a robotic platform. So it makes it cost neutral,
Okay.
especially in AWR settings.
Right. Arun, would you agree with the same thing, Arun?
I would broadly agree, but one of the problems I face is that almost all my hernia patients come with an insurance. Insurance will not cover robotic. Even if I tell them that you are saving 70,000 on the dual mesh and the tacker, and please give me that 70,000 for robot, they are not going to agree. And so that is one of the biggest challenge. So I am only able to do robotic surgery in hernias on self-paying patients, the number of which is rapidly reducing.
I agree
So
on
that's
that.
a very
and I
good
think,
point.
But now with October 1 onwards, the insurance companies are going to reimburse for robotic surgery in all the cases. They cannot refuse.
No, I disagree. That is a myth. That is a myth. The
Okay.
insurance companies are not going to give.
Okay.
If we
So
go
we
through
will
the
discuss that
details-
further, Arun. Just a quick question to you, Arun. Starting the robotic hernia, amongst this classification, which one would you choose if it is your patient, a primary or a recurrent?
A recurrent ventral hernia is one.
No, I'm
and-
talking about groin. The question is for you for groin hernia, Arun. You
Okay,
can see the slide here. I've talked about EHS groin, primary or recurrent. Which one would you choose for robotic?
I didn't see the slide. Yeah. Okay. Now I can see the slide. I would not go for either a primary or a recurrent hernia for groin unless I am doing it concomitantly with some other procedure.
Okay, got it. I'll show you a case scenario. So primary groin hernia, a systematic review, if you see, this is published in 2019 in Hernia. And what they mentioned was all techniques are comparable. This is a very good take-home message for the audience. All techniques are comparable, and individual surgeon expertise and tailor-made approach is the key when it comes to doing robotic. And this is STAMS 300, what I call very famously robotic groin hernia repair. 300 cases, very large. What they mentioned is that the learning curve was a key to success when they had this large series. So all of the factors left aside, the learning curve to pick up robotic was that. Coming to you, Vivek, coming to ventral hernias, which one of these classification in EHS would you take up for robotic case?
Yeah.
Out of these
the
four.
lateral ones, I would
lateral ones.
definitely like to go in with robot, and the primary epigastric and umbilicals can easily be done with laparoscope. But again, so we need to also understand it is not about me, it is about surgeons in general. There are many surgeons who will be more comfortable once they start with robot as compared to laparoscopy.
Right. So maybe lateral hernias first. Dr. Ramana, coming again back to you. This is a case, I'll just play the video for you. So what additional workup would you need to plan up this case in terms of if you want to take it up as a robotic case?
In my hands, this would be a robotic hybrid or an open, depending on many factors. So obviously, apart from the basic metabolic workup and cardiology, fitness and all that, the CT would be the primary.
Agreed. So for robotic, I think CT would probably help you to do that. Dr. Lal, this was a gentleman, you can see that. He has a bilateral groin hernia. As you can see, the right side is bigger than the left side. Robot, lap, or open? Yes, Dr. Lal.
This would possibly be best with the laparoscopy would be, robot, I don't know. I haven't attempted. Laparoscopic or open, both options are there depending upon the experience. This is large, maybe a direct would be, an open may be a good option.
Okay. Mukund, for you, this was a case, who had an open epigastric hernia recurred and has come back again. What approach and decision based on what factors? So Mukund, would you take up this patient for a robotic case? He has an onlay mesh there and it has recurred. Mukund, are you with us?
Laparoscopy is a good option. Am I audible?
Okay.
Laparoscopy is a good option,
please go ahead.
but if the CT scan shows that there are bad adhesions into the previous mesh and all that, then is the time when the if the surgeon is well versed with the robotic platform, then the robot additionally helps in a good adhesiolysis because of a good ergonomics and a better vision to do a better adhesiolysis, and the anterior repair can be done robotically better. But if it is a reducible hernia, then a lap and robotic, they do same job. So it's robotic is having no added weight.
Yeah, so what you and Dr. Ramanna combinedly said is very, very important to understand that when you have a battlefield abdomen inside, I think the robotic definitely scores because of the better vision that you can perform a better adhesiolysis, and your chance of enterotomy also subsequently goes down. So Vivek, this case, anyway, you can see the marking there, robotic, lap or open. You have got an epigastric hernia and a groin hernia. Maybe even Arun can respond to that after Vivek. Yes, Vivek.
Yeah, so is this would, if the patient can afford, it would be robotic. Otherwise, I will do a laparoscopic TAPP. So yes, but a robotic would be better.
Okay, Arun, for you, a robotic case, this one,
same
combination?
Same choices, robot first, lap second, open third.
Okay, fine, great. So this is what, the help of the robotic docking system is, that you can always do a lateral placement, gives you a lot of room for space and works there. This is just a small video to show all of you that how the vision today, I'll just go to that part, that how the vision and the ease of suturing on the roof really helps each one of us today in terms of robotic. This is one of the cases where, this patient was a really recurrent hernia. And just to show to the audience that how suturing on the roof and, doing the ergonomics better with visualization helps each one of us today in terms of performing it better when it comes to robotic. So difficult cases with a lot of adhesions, previous to mesh, second repair, third repair, I think it works up very well over there. This is, again, we will start with Dr. Ramanna and then ask everyone, would you take up this patient for a robotic? Dr. Ramanna.
Possibly this patient would be best served with a quick open bilateral release. So I'll probably go just open with this because his skin cover needs to be taken care of. His scar has to be excised. So that's going to basically be a incision over at least 60% or 70% of his midline anyways.
Okay. Dr. Pavanendra? Robotic, open, lap?
In our institution, I would do this hybrid. This is the exact cases which we are taking up for hybrid surgery. It takes care of the scar and excises the skin. We are able to, dislodge the adherent bowel, repair the sheath with the open, either even if using, other mesh options. And if required, do a tar, and that is the end of the thing. If it is possible to approximate, go inside and apply a mesh.
Okay. Vivek?
Yeah, I think I would, we would do it open because a lot of superhanging space there, a bilateral tar open would be better.
Okay. Arun?
See, robotic would not be a good idea at all for a few reasons. One is that it will have to be 3 ports on either side. You'll have to do it transperitoneally. Next, the 3 ports which you put, the edges of the ports are going to be very close to the edge. So your instrument, which needs to be at least about 10 centimeters inside the abdominal wall, you will not get that much. So the instruments will not move freely. They will clash with each other and it will be a disaster. I would go for open in this case.
Okay. Arun, you have always impressed me with your third dimension, because that's what I wanted to come up with. That technically sometimes, even if you're a good robotic surgeon, just because of the sheer space of working in that affects our ability to do it robotic. Mukund, what would you do for this, Mukund?
Definitely straightforward and open. We have to evaluate the risks and the benefits of what platform you are using. So an open is a straight way because robotics and lap will definitely be more challenging.
Okay. So this kind of cases, even if you have the robot, as the panel has rightly said, technical factors is one which has to be most important in evaluation, and second is the clinical factor. And I think the last thing which comes up in a center which have robot is the cost. Coming to the last of the few slides published, otherwise we'll perish. Very well proved by the Gangaram group. Very rightly this has come up. Vivek, do you think that with these kind of robotic publications, having a robotic hernia registry is going to be the future? Vivek, your opinion?
Yeah, I think so. And you are the right person to lead that registry. So you should take that
Absolutely.
initiative and you should carry it
So
forward.
yeah, so your articles like this always encourage all of us, and I think we should each one keep a record of what we are doing, and that's going to be the way forward. I still have about 3 minutes left with me. So the final verdict of robot and hernia, Dr. Ramanna, it's a big yes or no, or you have an equivocal response?
No, it's a big yes, absolutely.
Okay, big yes. Dr. Pavanindra?
Yes, in very special situations where intracorporeal suturing, ergonomics is an issue, yes, it is essential, and it is important for us to train our younger, surgeons. They need to be equipped with all technical, abilities, and this is just another instrument that one should be well versed with.
Absolutely, very well said, very well said. Mukund, a big yes or no?
Yeah, it's a big yes. As Dr. Ramanna has said, that robot is not a different platform. It is a tool which everybody, as an laparoscopic instruments, everybody should have as an robotic as a tool, and one should lose whenever you need that robotic tool is required to take care of a complex hernia or what sort of hernia you're dealing with.
Okay. Vivek, Arun and Vivek, I would like you both to answer it a little differently. Do you think you would, I'm sure you're going to say yes, both of you, but do you think there is a bias because both of you have an access to robot? Let's start with Arun first.
No, the answer is that just like laparoscopy, after the pendulum swing stops, you know exactly which one you would like to do by laparoscopy and which one you would like to do open. Similarly, after a certain number of robotic hernias, you will realize that, okay, this one is good for robotic or lap or open. So yes, the robot should be available, but after the initial enthusiasm, you are going to settle down as to what is the best for an individual patient.
Okay. Your response?
Yeah, see, I think it is definitely a very good platform for doing hernias. We should, if we forget the cost and other ancillary stuff. So it is a non-inferior platform. It has some advantages. Now, the cost issues and other, loss or lack of haptic feedback, all that stuff is going to go away in next few years. So it is, it is there to stay. And we should, we always look at the non-inferiority of the platform, which is proven beyond doubt. Cost is a very relative issue, as we already discussed about the dual mesh and other stuff. Which
yes, absolutely. So I think the final verdict for everyone here, when I give you the crux of the panelists, is that we've got 5 on 5. So robot is going to be the way forward for hernia today, because it's evolving in India because of the cost constraints, because of the capex, and as Dr. Pavanindra rightly said, that teaching institutions, the companies should look at a little differently of us. The training is the key, and getting over the learning curve faster, and mentoring yourself with technical guys like Arun. You saw how he puts the 3D picture into the mind, going about 10 centimeters, 12 centimeters. These are very, very good technical points. And select cases, as Dr. Ramanna, Dr. Mukund rightly said, have a good mentor around with you, as Dr. Ramanna has been for the Gangaram team. Arun can be, each one of us can be a mentor for the programs. Hybrid approach always to begin with, so that you can have things much, much better and get off your learning curve faster. And please maintain your data, publish, and I think slowly we should all evolve towards forming a hernia registry for robotics, because from that we will have a lot of things to learn up. So I thank the panel, and along with these lovely kids, I think we all are in the prayers to see that how the pandemic gets over very soon. I thank all of you watching, all of us, for your kind attention. We are always available. The resources are available for us to contact each one of us whenever required. And over to the team for any final comments. Thank you very much.
Thank you.
I hope you all had a very good panel discussion.
Thank you, Dr. Gandhi. Thank you.
It has been a great session, and I think the team can take over. And
yeah, I think thank you so much, everyone, for this wonderful session.
Hello?
I think Daksh has some internet issues, but I would like to thank everyone. Daksh, are you online now?
Yes, sir, I'm here.
Can you start the next session, please?
Yes, sir. Now we'll be starting with the colorectal session. I'd like to invite the chairperson, Dr. Suviraj John, Senior Consultant, Department of Minimal Access, Metabolic and Bariatric Surgery, Sir Gangaram Hospital. Dr. Amanjeet Singh, Senior Consultant, Department of GI Surgery, Medanta, Gurugram, and Laparoscopic Surgery in Bangladesh, and the Chairman and Chief of Laparoscopic Surgeon, Japan-Bangladesh Friendship Hospital in Dhaka. Thank you. Over to you, chairpersons.
So good afternoon, everyone. I think all of us enjoyed this panel discussion. So now we'll have 3 master videos on colorectal surgery. So first of all, I will invite Dr. S.P. Somashekar. He is a director of surgical oncology at Manimal Hospital, Bangalore. So he'll be showing a video of robotic right hemicolectomy using the technique of CVL and CME.
Thank you very much, and I thank CRSA and the chairperson for allowing me this. Since the time is just 8 plus 2 minutes, everything in 10 minutes, it's impossible for me to show the every aspect of robotic right hemicolectomy with central venous ligation and then Japanese D3 type of complete mesocolic excision. I have taken the liberty of using the important key points on the step, and I'll highlight those parts so the tips can be taken. The most important tip is half the job is done if you have a very good position given. Port placements, right position is half the job done, and identifying the right instruments. Patient should be supine with iliac crest over the midpoint of the table, and you break it, and you'll be surprised to see that at the level of IC, and especially between the duodenal curve, the extra length you do, so the bowel drops down on this side and that side will really help you. And padding and securing of the patient, 10 to 15% rivet Trendelenburg position, and flex the table, and then the lower patients so that there is no collision of the arms. This is the position. Remember, in radical right hemicolectomy, all the quadrants of the abdomen will be visited except the left iliac fossa. So park all your bowel. I use 3 Versa band or 3 T-lift. 1 to take the stomach up so that the stomach and colon momentum is lifted up by a hitch stitch to the abdominal wall, and the colon goes on the left side, and then the small bowel mesentery is on the left iliac fossa. This position really helps. Now, depending on what robot you have, X, XI or SI, depending on the location of your tumor, proximal or flexure or the ascending colon, depending on how far you have to go to the plane flexure or to the left of middle colic, you can place this port placement 1, or you can place this port placement if you have it more distally. But there is a modification I have done in my S robot. Even though it is recommended that you keep all the ports 2 finger bed to the left of umbilicus as a universal port placement in one line in XI, don't do that. You will struggle a little bit. Try to do an inverted smile, McDonald's smile. It's a limited inverted smile incision ports is the best. This is the port I normally use. You can see that I take one at the suprapubic port. That really helps me to take a staple or a Hansian anastomosis, which I do. And then this is one of the port. If it is more distal, then I move the suprapubic to the left part of it. And this is how the robot X would come or SI would come. There are 2 techniques available for you to do. Medial to lateral, lateral to medial. I cannot show both the technique in the time given. I will limit myself to medial to lateral approach. Lateral to medial approach are also available. And when it is a bulky lesion, T4, T3, or you have to do a concomitant margin of the liver or right parietal wall, you need to do that. I'm not going to show this particular area. I'm going to show medial to lateral. Now there are 3 choices of instrument you can take. Left side is a fenestrated bipolar. Right side, I recommend you to take a robotic hook in the learning curve. If you have mastered it, then go for hot shear. For beginners, robotic hook is recommended. Arm 3, you can use a cardi forceps or a pro grasper, or if you have a X and XI, up tip bowel grasper. Alternately, if money is not a problem, then you can use a vessel sealer. So no clip, no resection, but mind you, 57,000 is more. The settings are very important. I use 36, 36, 40 setting, monopolar pure setting, coagulation spray mode, and bipolar. If you have X and XI, please go for this particular instrument. The operative steps would be in medial to lateral different, lateral to medial different. Medial to lateral, this is how central venous ligation and central vascular ligation. Japanese D3 complete mesocolic resection, then transection. Then there are 2 types of anastomosis in the robot. I'm going to show you this particular area. At the end of when you do a central vascular ligation and Japanese D3, extended mesocolic excision, this is how it should look. The entire duodenal loop should be seen. Pancreas head is seen. See all the 3 vessels, iliacolic pedicle, right colic pedicle, and right branch of middle colic should be seen like this, tied. And I'm going to show you in the next video how this particular area is seen. Robotic right hemicolectomy on a Da Vinci X system. 10-year-old male,
with a ECOG of 0, presented with loss of weight and generalized weakness in 6 months. Ultrasound of the abdomen showed a mass lesion in the right iliac fossa arising from the ascending colon. CT scan showed a circumferential thickening of ascending colon with full thickness wall involvement of 3.5 centimeters and length of the involved segment around 7 centimeters with luminal narrowing and fat stranding. There was no evidence of any ascites or metastasis. Serum CEA was colonoscopy confirmed the findings with lumen compromised. Biopsy revealed it to be a transverse anastomosis was planned on the Da Vinci X system. Principles of a right hemicolectomy include thorough inspection of the abdomen and assessment of mobility, mobilization of hepatic flexure of colon, identification of vascular pedicles and ligation, mobilization of colon from right lateral parietal wall, that is line of Toll, identification and preservation of right ureter, careful dissection of the duodenum, transection of terminal ileum and transverse colon with adequate margins, and iliotransverse anastomosis. The main vascular pedicles in terms of a right hemicolectomy are right branch of middle colic artery, right colic artery, and the iliocolic artery, which are the branches of superior mesenteric artery. Patient is kept in supine position for the robotic docking. Ports put are shown in the following diagram. Camera port is taken in the subumbilical line to the left, while R1 is taken in the supraumbilical region below the costal arch. R2 is taken in the suprapubic region to the left hand side, while R3 is in the right iliac fossa. The assistant port is triangulated between R1 and R2.
The most important thing is, this port on the right side in the right iliac fossa will be actually different and it changes depending on the location.
While assistant and scrub nurse are to the left.
You can see this is how the robot would come. I told you that in the beginning learning curve, robotic right hook is something very useful. But once you are expertise, you have done over 100 cases, you can use hot shear, then you will understand how to do a very good, central vascular ligation. This technique I'm showing is medial to lateral. I'm not able to show lateral to medial, maybe some other time. So I keep an inverted J-shaped incision ranging from the right iliac fossa at the IC junction up to the root of the mesentery. Remember, you do medial to lateral dissection, so go and take care of the vessels first. So you can use a hot shears, use it like an open surgery. Under the guarding of that, you can do. One advantage of hot shears, once you master, is the dissection of the vessels. So you take the iliocolic pedicle, go down up to the pancreas. Now, depending on whether you use a vessel sealer or a robotic clip applicator, you can go and ligate them at the level of pancreatic area and duodenum. Normally, if you have a vessel sealer, now I quite often use a vessel sealer. I don't have to ligate anything. Now drop down the whole pancreas, head of pancreas, and then the duodenum. As you do this particular area, we know in 15% of the time, the right colic could directly come as a separate branch and not as a part of the branch. Identify this particular anatomy, and then you take care of the right colic. Kindly note, I will put normally 2 T-lift. There is a stay switcher, one lifting the stomach greater curvature, which is hitched into the anterior abdominal wall. So it acts like a natural retraction. So whole transverse colon, transverse mesocolon, stomach momentum is lifted up for me, and that avoids one more extra port. So there are all 8 mm ports for you, which is available easily. Then look for the right colic, whether it is 15% of the time separately it has come or as a part of it. Take all the nodes in the central vascular ligation, do a very good microburst. Advantage of robot is, you can do, tip of the instrument is 3 mm. So all the node, fibro, fatty tissue, lymphatic tissues, take and sweep all towards the specimen side, skeletonize the vessels. Kindly note, we have not even touched the other part of the colon. It's just the vascular approach first, and everything is from medial to lateral by inverted J-stick incision. I prefer using 30-degree camera because when I turn left or right, I can easily get a right and left view. So skeletonize each vessel. You can see that now whole vessel is skeletonized. The whole, mesocolic should come like a frill of a frog without a buttonhole, like a Japanese D3 complete mesocolic excision. So once you take the vessel, hardly anything is there. So now you can see that I'm going around. I take the right colic branch, then you can put a clip. Alternatively, if you have a vessel sealer, you can actually straight away fire it with a vessel sealer. That would save some time, but remember it adds another 50,000. Then you identify the right branch of middle colic, ligate it. We know that it's a very small one, 3 to 4 mm. So you cut that particular area. Now all the vascular ligation has happened. As I told you, the whole thing is there. Now, you know, it is very easy to go ahead and lift it with between two types of pad of fat. That is the golden yellow and pale yellow, and the ureter kidney will drop down and you are at this area. As I told you, this is how the field would look. You can see that the whole duodenum, C loop, and then the pancreas, and then the three clips, ileocolic, right colic, and then the right branch of middle colic is seen, and very easily you can separate it off. Then you can come back and then release the stay suture of the stomach greater curvature, do a omentectomy, transverse colon, and then the right hepatic flexure mobilization. Then you transect the colon, then transect the ileum. There are two ways in robot you can restore. One technique is intracorporeal anastomosis using 3-staple technique, where you take 2 hitch suture, double staple is fired, and then close it with the 3rd stapler. I'll show you a short video. Or the second option you can do is intracorporeal total hand sewn, the main advantage of the robot. So once you take the tinea and then the ileum, you take 2 stay sutures here on one end, and then you take the stay suture on the other end. There is a double staple technique, there is a triple staple technique, all intracorporeal. So if you are planning to do a triple staple, then you need to have 2 staples, because then the anastomosis doesn't get narrowed. Then you create this small rent on both ends, sufficient enough for the staplers to go in. You already taken 1 hitch. Normally what I do is I put a Versa band, or I use a T-lift and I hitch that to the right parietal wall so that I don't have to hold. You can hold this with this. Then you take 1 stapler, you go through this. I don't prefer taking a stay suture here, because then it fixes up and sometimes the staple can go to the anti-mesenteric end and then it would not be a proper one. So you can now thread it completely and take 1 staple here. Totally remember, it should be at the anti-mesenteric end and no end of the mesenteric should be there. Between the staple line and the vasculature, there is enough length. If you do a tri-staple technique, then you would need 2 stapler inside, because the last part is going to be encropted in the 3rd stapler, which is work like a Lambert suture. If you are going to use only 2 staple technique, the outer rent, if you are going to close it completely with hand sewn, then only 1 staple is enough. Now, what I normally do is I take a 2 or 3 stay suture of this area, because this is a tri-staple technique which I have shown. So you take 1 angle stitch, which would lift it. Remember, this is going to ultimately come in the specimen. So these are only traction sutures. Then you can do a 2nd stitch. And remember, by pulling it up, the stapled end, which is lower down, is pulled away. So accidentally, inadvertently, I'm not going to tent it, or I'm not going to take it off and then going to narrow the anastomosis or fire the other end by mistake. So take 3 stitch. Normally they're just a stay suture. You can alternatively use a puppet technique, which is explained by Khurshid Guru. You can just hang it out into the anterior abdominal wall, lift all of them above, all the 3 together with 1 clip, you can lift it up. And then once you do this, you can fire 1 stapler. If you do triple staple, you need 2 staple inside. If you do only double staple technique, then you don't have to fire the 2-1, then all of them will come in one area, you can fire it off. Alternatively, you don't have to worry about this particular technique. You can straight away do the whole thing. It is up to you. Normally, I always do a overseeing, which is not compulsory, but you can do it. Alternatively, you can do the entire anastomosis hand sewn, which is the most important thing in the robot. Nowadays, I prefer this, so I save the cost of the 3 stapler, which in itself will bring down the cost into that of a laparoscopy. So the total duration normally is about roughly 1.5 to 2 hours. Consult time is not more than an hour. Blood loss is very minimal. And this was the histopathology of this patient. And in the time allotted, this is how much I could show, and I cannot show a lateral to medial. Thank you very much.
Do we have discussion or we go to the next presentation?
I think the time is up, Dr. John. You can proceed with the next one.
Thank you, Dr. Somashekar. It's my privilege to introduce to you our eminent next speaker. He is Dr. Venkatesh Munikrishnan. He's Director of Robotic and Colorectal Surgery at Apollo Chennai and founding member of CRSA India. He's going to be presenting to us on a robotic low anterior section. Over to you, Dr. Munikrishnan.
Thanks, guys. Great meeting. I think it's come out fantastically well. Well done, Vivek and the organizing team. So let me just share my screen. So this is going to be a video which has got some audio in it. Hopefully it's audible enough. So let's crack on with that.
Surgeon at Apollo Main Hospitals, Chennai. As part of the standard setup for a low anterior section, the patient is put on a steep head down, slightly rolled towards the right. A sandbag is positioned under the pelvis at the level of the anterior superior iliac spine. This breaks the pelvis so that the small bowel is held in the upper part of the abdomen during the procedure. The robot comes in from the left of the patient at a 45-degree angle. We routinely use 3 robotic ports, the central one being the camera port, which is positioned 1 inch above and lateral to the umbilicus. The right robotic assist port comes in 8 centimeters to the right of the camera port, and the left robotic assist port comes in 8 centimeters to the left of the camera port. We also use 2 extra assist ports, the one on the right iliac fossa being the 12 millimeter assist port through which we introduce swabs or Johans retractors to help us retract or move the bowel. Through the left assist port, we use the air sail equipment, which gives us a fantastic pneumoperitoneum and also sucks the gas out during the procedure. Once the robot is docked in, we use the 30-degree down camera through the camera port and a curved monopolar scissors through the right assist port and a bipolar grasper through the left robotic assist port. The success of any operation depends on standardizing the technique, and in the case of TME, it depends on breaking it down to further small steps. The first one being the ligation of the inferior mesenteric vessels, followed by medial to lateral dissection. This is followed by the total mesorectal excision, and you carry on if you want to do an intersphincteric dissection, followed by a splenic flexure takedown. As far as this video is concerned, we'll be concentrating on the total mesorectal excision and intersphincteric dissection part of the operation. In this video, we've already taken down the inferior mesenteric vessels and done a medial to lateral dissection, identifying the ureter and the gonadal vessels. We're just reaching the top of the rectum, just about to start the TME. This video is at a speed of 4 times the normal, and it is mostly unedited so that you could see the benefits of the robotic technique. We completed the medial to lateral dissection. We're just starting the TME part of the operation. The rectum is lifted up, the bipolar graspers in my left hand, giving the stretch on the rectum, displaying the beautiful angel hair fibers, which shows the TME plane. If there's any bleeding, the bipolar graspers used to control it. The rectum is put on a stretch using the left robotic bipolar grasper instrument. This displays the angel hair fibers clearly. As you can see, the hypogastric nerves are coming into view. It's important to preserve them. As you put a stretch, you'll identify the angel hair fibers, which give you a key to where this dissection should be going. As long as you identify the TME plane accurately with the help of the angel hair fibers, you should have no problem in identifying these key structures and nerves and preserve them so that there is no damage done to them. We carry the dissection down to the pelvic floor. It's important to maintain the traction using the left articulated wrist. Put the rectum on stretch so that just like that, so that the angel hair fibers are clearly demonstrated, showing you clearly the exact area where we should be dissecting. It's very important to use the traction and counter traction. I think that's where the robotic technology really is useful to get very low in the pelvis. As you can see, the the rectum sort of curves as you get down deep into the pelvis. It's important to follow the curve of the mesorectum as you carry the dissection down, otherwise you will hit the pelvic vessels and cause unnecessary complications and bleeding. This is a very important point, particularly encountered when early in your careers. Keep the stretch on the rectum so that the fibers are clearly demonstrated, and then you use the art of the instrument tips to get to the awkward angles, which can be quite challenging when you're doing laparoscopic surgery. As you can see, the pelvic floor is just coming into view. Seeing the pelvic floor marks the end of this section posteriorly. Next, after free,
Sorry.
I'm making the angle. Important to follow the curve of the instrument tips to get to the awkward angles, which can be quite challenging when you're doing laparoscopic surgery. As you can see, the pelvic floor is just coming into view. Seeing the pelvic floor marks the end of this section posteriorly. Next, after freeing the rectum from the right side of the pelvic side wall, the dissection is carried anteriorly. As the peritoneum is incised anteriorly, the non-villous fascia comes into view. It is important to make sure that the fat stays with the rectum. There is a very clear fascial plane which differentiates the non-villous fascia and the fat on the rectum. It's important to stay in this plane. With traction on the rectum with the left instrument, traction counter traction identifies a clear plane of dissection so that the dissection is carried anterolaterally, then anteriorly, and then the left lateral part of the rectum. Always bearing in mind of the non-villous fascia to keep it safe so that the nerves are preserved. We proceed to free the distal sigmoid and the upper rectum so that we could dissect the rectum from the left pelvic side wall. As we open up the peritoneal attachments, freeing the distal sigmoid and the upper rectum, you should be able to reach the dissection point, which you'd already done through the medial to lateral dissection. You should be able to see the ureter and the gonadals once this peritoneum is incised on the left side. The proximal sigmoid attachments are freed through careful dissection. The anterior pelvic peritoneal folds may come in the way of your anterior dissection. So I tend to use a ethylon stitch through a straight needle to hike up the peritoneal fold so that it stays out of the way. Also frees up an extra hand to help you with the dissection. At this point, the rectum is pulled to the right. The left peritoneal attachments are unzipped so that the rectum becomes completely free from the attachments on the lateral pelvic side walls. Again, we're using the tip of my monopolar scissors as a paintbrush to divide the peritoneal attachment so that the rectum can be freed from the left pelvic side wall. The dissection is carried on to the left lateral side wall and then onto anteriorly. Traction is applied using the left instrument onto the rectum so that the tissues are stretched. You can see the anguli fibers again coming into view. This is very important to stay in plane at this point when you're very low down anteriorly. The key to low pelvic dissection or low rectal dissection is to maintain the traction and counter traction so that the tissues are put on the right amount of stretch. The anguli fibers are again demonstrated here. The dissection is carried carefully down so that not to damage the rectum or the important structures very low in the pelvis. As you can see, we're approaching the intersphincteric space and we're onto the rectal tube. Now looking deep into the pelvis posteriorly, any last few fibers which are holding the rectum down are dissected so that the rectum is completely free now. A rectal examination is done to assess the level. The next final step would be to cross-staple the rectum on the pelvic floor. We tend to use a Covidian tri-staple purple cartridge stapler. The reason being the articulating lever is external and makes it much easier when you're doing a very low staple on the pelvic floor. The thicker jaw of the staple is usually kept posteriorly to the rectum so that it doesn't damage the wall of the rectum when it's not in the field of view. The stapler is now manipulated using the lever so that it lies parallel to the pelvic floor and fired. Usually we need 2 fires to go across the rectum at this very low level.
Thank you. So I'm going to stop there. So that sort of covers most of the important steps which I wanted to add, and most of this I would suggest. I mean, I would advise the younger audience who are getting onto robotics is to go visit lots of centers. I particularly visited Professor Amjad, who's here. It's a privilege to watch this video because most of what I do is picked up from him and all the other masters, Somashekar, Avanish, and all of them. But most of the technique was from Amjad, so I'm very grateful for that. Thanks, Amjad, for joining us today. Thank you.
Thank you. Thank you, Munikrishnan, for a beautiful presentation. And I take this opportunity to thank Vivek and all the organizers. And I definitely thank my co-chairpersons, Dr. John and Dr. Singh, and the previous presenter, Somasekar and Munikrishnan, for beautiful presentation. Now I take the opportunity, because we are not having any question and answer session at the moment because probably we are running short of time. I just straight away call upon Dr. Avanish Saklani for his presentation. Well, as you know, this is Dr. Naeem from Bangladesh. Thank you. Thank you. Avanish Saklani, please go to your presentation.
Hi, good afternoon, everyone. Thank you, Dr. Naeem, for introducing me, and great to see Subiraj again, and that's awesome.
Oh.
Somashekar and Venki did some great presentation.
Should I tell that he's the senior consultant in the Department of Surgical Oncology at Tata Memorial Hospital, Mumbai, and he's one of the founding members of CRSA India. Thank you. Thank you.
That's right. Okay, that's great. So that's great. Awesome. So I think I'll just show some video, which I think I'll try to keep up with Venki. So I'll just share my screen now. So I'm going to talk about, it's a bit different case with lateral pelvic node dissection. It is good for anatomical view rather than anything else.
Demonstrates robotic abdominal perineal resection. This video demonstrates robotic abdominal perineal resection with pelvic node dissection. Our patient is a 37-year-old gentleman with rectal neuroendocrine carcinoma with involvement of the left lateral mesorectal fascia by nodes. Patient was given 50 gray in 25 fractions along with 5 cycles of cisplatin and etoposide. We begin the dissection by creating the plane below the inferior mesenteric vein and dissecting along the mesocolic fascia from medial to lateral. Following this, the rectal mesentery is then dented up and the peritoneum is scored below the inferior mesenteric artery. The dissection continues below the inferior mesenteric artery from medial to lateral along the mesocolic fascia. The root of the inferior mesenteric artery is then bared and clipped and divided. Further medial to lateral dissection continues along the mesocolic fascia till we reach the lateral peritoneal attachment. The dissection then continues in the pelvis and the posterior dissection is completed till the pelvic floor. The lateral peritoneal cut is then taken to mobilize the descending colon. We now begin the pelvic node dissection by scoring the peritoneum over the iliac vessels. The ureters are then dissected and medialized, and the vesico-hypogastric vein is defined and kept intact. We then dissect the nodal tissue along the external iliac vessels, followed by dissecting the nodal tissue along the internal iliac vessels. The distal end of the obturator artery is then identified and divided. As the dissection continues further, we are able to identify the obturator nerve and the obturator vein. The distal end of the obturator vein is then identified and divided. The nodal tissue along the obturator nerve is then dissected carefully, and the injury to obturator nerve is avoided. The obliterated umbilical artery is then identified, clipped, and divided. This is followed by identification and division of the superior vesical artery. The remaining nodal tissue along the internal iliac vessels is then dissected completely. The distal end of the obliterated umbilical artery is then also identified, clipped, and divided. The remaining nodal tissue along the obturator nerve is then cleared, and the obturator vein is clipped and divided at its origin. The dissection then continues further down along the internal iliac vessels till we identify the lumbosacral trunk. The internal pudendal vessels are then clipped and divided. Continue further down, the sacrospinous ligament is identified, which serves as the landmark for the ischial spine. The lateral dissection of the rectum then continues, keeping the vesico-hypogastric fascia intact, which helps in preserving the hypogastric nerve. As we continue with the lateral dissection, we also encounter the middle rectal vessels, which are then clipped and divided. We then continue with the dissection along the internal iliac vessels, and the entire nodal tissue along the internal pudendal vessels is then cleared, and the internal pudendal vessel is then clipped and divided. The anterior peritoneal cut is then taken, and the anterior dissection continues, preserving the seminal vesicles. The mesorectal fascia was involved by the node at the ischial spine. The sacrospinous ligament is cut further away at its origin from the ischial spine. As we continue further down, the right levator ana is also cut, keeping adequate soft tissue margins. The specimen is then divided proximally with the help of an endostapler. The remaining part of the surgery is then completed perineally, and the specimen is excised through the perineum. Area highlighted by the arrow shows the attachment to the sacrospinous ligament. The final histopathology revealed large cell neuroendocrine carcinoma with negative proximal, distal, and circumferential resection margins.
Okay, that's good. Okay, I think that was it. Thank you very much, and okay.
Thank you, sir. Thank you to all the chairpersons.
Yeah, thank you.
Now I would request Dr. Venkatesh Munikrishnan and Dr. Avanish Saklani to continue as the chairperson for the next session, that is the CRSA Gold International session. And please call on the next speaker.
Okay, welcome everybody to this CRSA International Gold session. It's been a privilege to be part of this program and taking it online. Again, great job, the organizing team. It's fantastic because we got 3 great speakers today. They're all masters in robotics and colorectal surgery from around the world. So I would like to introduce the first speaker, which is Professor Amjad Parvez. Professor Amjad Parvez is Professor of Colorectal Surgery. Professor Amjad Parvez is Professor of Colorectal Surgery at Poole Hospital. He is one of the pioneers of laparoscopic and robotic colorectal surgery in the UK. He heads the Minimal Access and Robotic Colorectal Surgery Center at Chapalimau Foundation in Lisbon, Portugal, where people could sign up for a course, demonstrate their skill sets, attend the course, and then you get certified in robotic colorectal surgery. So it's I think it's going to be the future where people will get certified, for example, robotic teaming, and I think he's leading that front. And Prof. Amjad Parvez closely works with Prof. Hield, and Prof. Hield more or less considers him his sort of protege, absolute #1 protege. So welcome to the meeting, Professor Amjad Parvez. The floor is yours.
Thank you very much. I think, can you hear me?
Yeah, absolutely.
If you ask the admin, please, to unblock my video setting, because it's not letting me do that from here. It says it's been stopped by the host.
I'll get it done. Just give me a moment.
Thank you. Okay. Okay, I can see you now. Well, first of all, thank you all for very kind invitation. CRSA India, Venki, who's a close colleague and a friend of mine for years, and some familiar faces and names. So thank you for the opportunity to come and talk to you about a subject which actually is quite close and dear to my heart in terms of teaching and training in robotic colorectal surgery. So I think it would work like that. Okay. Can you see the screen?
No, sir.
All right. I did say sort of share it. Hang on a minute. This is all very well practiced, and so share screen. Okay. Should be able to see it now. Okay. Are you able to see it?
Yes, sir.
Okay, right. So I'll get cracking. So I've been asked to sort of talk to you about various robotic colorectal training pathways, and you probably know, most of you, either doing or started doing or started training people, that this is a bit of a hit and miss. Just as well, we were starting laparoscopy many years ago. This is no different. So I work and live in Poole. Most of you been to England, so you would know this is southeast portion of England. This is Bournemouth. Poole is about here. I live at the edge of New Forest. It's about half an hour commute in the morning to come to work. Um, Thankfully, training landscape has changed. This is a historical picture from one of the cardiothoracic surgeon in Texas. I think his name is Dr. Cooley, who in 1970s trying to demonstrate his new technique of doing a coronary artery bypass graft, and surgeons from far and wide had come to see him do that. If you watch this picture very closely, some of us hanging around here would have no clue what's going on in the middle. So thankfully, minimally invasive surgery have changed the spectrum of how we demonstrate and how we train people. Teaching and training in robotic surgery, this is an older review. I just deliberately put it up. This is 9-year-old. Even at that time, people were recognizing that training has to be formalized and it has to be competence-based instead of time-based. It's not number of hours you spent. You effectively can do bad surgery consistently for a very long time without realizing. So it's important to learn the set of skills which are competence-based rather than time-based. Currently, these are by and large few sort of pathways, if you look up, that are available. So industry-led training, this is a single provider at the moment. You buy a robot, they would allocate some training budget, take you on some courses, ask you to fire a few staplers on animal models, and then bring you the proctor in, and following a mutual consent after 2 or 4 cases or the budget allocation limit that have been set aside, they would tell you that you are good to go. So that's how the whole sort of paradigm was sort of put in for a number of years until recently things have started to change. There is now increasing uptake of either traveling fellowships or hands-on training. And if some of you who are more or less my age would know that when we were trying to learn laparoscopy, it pretty much depended on how good your boss was. So if he or she was learning, you end up holding the camera and you have to learn by passively watching it, because they were over the learning curve. And I think robotic surgery is more or less going through similar timeline when I look around at the training scene. I put FRS, which is Fundamental of Robotic Surgery. This is a US-based program. My colleagues from USA would know more about it, but effectively it is a 4-module program based around Introduction to Robotic System, didactic training on robotic system itself. Module 3 is psychomotor skills, which are different simulation exercises they do. And the last module is team training and communication skill, but no clinical hands-on stuff or no assessment attached to that particular aspect. So I'm going to spend time talking about a European training program, which Venki briefly mentioned. This is run through European Academy of Robotic Colorectal Surgery, and I'm going to share some data and figures with you. So more or less, this is the spiral that you usually get. You buy a system, you learn through simulation, you learn through system-based tools. So buttonology, effectively learn which button does what. Then you have an index procedure depending upon what type of subspecialist interest you have. In our setup, it's a colorectal surgery, mainly left-sided resection. So most of us would learn TME or rectal resections, and the industry would then put you through some animal cadaver courses. You would be taken to some center of excellence, like Venki showed you a beautiful video. They probably would take you to see him, observe his team working, and then you would get a preceptor or proctor to come in. But there is no formative assessment attached to this loop throughout the process. They may have some assessment around this half of the picture, but further along, it's pretty much like a goodwill and a nod that you get from your colleagues rather than any objective assessments. We published this a while back. I genuinely believe, even before robot came in terms of teaching and training, it's hugely important to have a structure and standardization of any operative skills that you want to teach people. Why EOX? At the time in 2012-13, when robotic surgery was being adopted in my hospital in Portsmouth at the time, where I was based at, the idea really was to develop something which is European based. So we have our own training curriculum, develop our own faculty, develop data, and through that data, we would be able to look at various aspects of clinical outcomes rather than just having what was being sent to us across the water, for example. This is a generic sort of structure of the EOX. there are a number of institutions. So EOCS is not just one statutory body. This is what you call number of hospitals participate in this academy, which the coordination office is based around Chimpalimo Foundation in Lisbon, where the case of allocation and training is monitored, and where the assessments are carried out through a blinded procedure, which I would share with you. Different faculty member, because it is a European academy, it's important to sort of look at the demographics of where the training center and the proctors are based on. Because when trainees would sign in, they would give in 3 preferences for the people they need to be trained with. And based on geography and availability of the times from different faculty members, they would be allocated trainer. The idea was that you get to train with same technique and preferably with same trainer, so you would have a shorter proficiency gain curve. This is the concept. When you do have a system, you are taken through on-site, off-site training, surgeon-led courses around cadavers. This is procedure-specific course. Then they are asked to undergo up to 10 cases of closely supervised proctoring episodes. Now, why 10 cases? Why not 15? Why not 5? This is not a magic number. We had to come up with some number. In laparoscopy, we decided to come up with a magic number of 20. So we thought we start with 10. And actually now, as 3-4 years into the program, it has become very clear people who have passed the program or who are deemed competent with their set skills, the median number of cases they have taken are around 11. Now, some people would take less, others would take more, but this is just an arbitrary number to start with. And the idea really is to train people to become competent. That's the subtle difference that everybody have to realize. You're not being trained to become what you call an expert after 10 cases. It's a competence you seek, and you learn with structure. You become more proficient by doing more and more cases. After you've done your up to 10 cases, between mutual consent of your trainer and yourself, you feel that you're ready. You undertake straightforward cases at your own, and then you're asked to submit 2 videos of the procedure done by yourself without anybody being around, i.e. proctors being around. These videos are then passed to a central coordination office in Lisbon, and then they are allocated blindly for faculty to assess it. So if you get 1 positive, 1 negative result, a third opinion is sought at the back of this. Currently, we have about 20% of what we call re-sign or a failure rate based on the assessment procedure. This is how people are trained. We have divided the operation in module. This is not a new concept. We have known about it for years. We published that with laparoscopy. Our urology colleague actually published a lot of that back in early 2000 when they were developing a laparoscopic prostate training model, for example. So people are taken through each module. I spoke about standardization. We were first group in Europe at the beginning with SI system. Remember in those days, where the difficulty was the splenic fracture mobilization with single docking technique, and people were coming up with either hybrid techniques or dual docking or reverse hybrid. We decided to follow Sohan Kim model, where you only have to flip the arm once you have done the flexure down to the pelvic configuration. We published the first 100 cases. So we standardized the operative technique. Within those, then we had to develop among European experts to know what robotic TME should look like, what are the steps to some consensus. And this is a paper published in colorectal diseases highlighting each step of the module of the operation within the expert agreeing to consensus. Even within the modules, we have tried to what we call standardize each module. For example, a splenic flexure mobilization using an SI system. Now, this has become much easier now with X and XI systems now. But the idea really was that regardless of whoever operates, regardless of whoever come and learn from you, the picture that you want to show them should consistently look exactly the same way, so they are easy to learn and easy to reproduce. Same applies to proctectomy part. I mean, you saw beautiful videos shown by Venki a while back of the pelvises, and my colleague from Tata, he showed you the similar sort of pictures. But it really doesn't matter who does it and where they are being done, as long as you have absolutely consistent techniques to demonstrate the operation should become predictable. It should not really depend on individual patient factors. So small patient, big patient, post-chemotherapy therapy, it is exactly the same that you seek. Within the operation, each module has got exactly the same format to follow. So even if the patient is thin or even if is obese patient, the anatomy that you seek or the anatomy that you want to demonstrate to your trainees should look absolutely consistent. So then it's a similar operation they see every day of the week. Your operation or operative technique should not change on the basis of what your wife have said to you in the morning before you come to work. So it has to be look what I call boringly similar, because only then people are able to appreciate abnormal. This is the different part of operation steps. You all are well versed with it. The idea behind showing you all these sort of steps are to demonstrate to you that these are highly standardized now in our operative technique. And yes, there are days when it's difficult. I don't even pretend that every day. I have a lot of bad videos as well that I'm not showing you. But at that day, you realize that you probably have failed as a technical surgeon not to demonstrate the anatomy. So if you stick to what I call consistently same way of doing it, more often than not, you are able to reproduce the technique that you do on a consistently daily basis. So it's important for the trainees to recognize and see this. This is someone who's obese patient. This is a consistent way. We use a clamp now, do an endoscopy as a standard that we have, and using robotic stapler to divide it. So very, very similar outcome, regardless of whatever body habitus, wherever you're operating them, wherever you are sort of teaching or training them. So it's a boringly similar way. So this is the message that I wanted to sort of put across to you when you're teaching or training people. The idea really is, this is what we are after. What we are after really is what we remove from patient, regardless of whether you do it laparoscopically, robotically, but it has to be consistently same package that you use. Now, when we are training people, as Venki mentioned, we use an objective scoring system. This is a modified version of global assessment score sheet that we used in our LabCo program. This is how each module is scored by the trainer in real time. One being done by the trainer, not performed being to 6, proficient performance, so to speak. The idea behind this scoring system is that you can score each step of your operation. So you can actually roadmap how your trainees are being developed. So for example, if I consistently score less on splenic flexor mobilization, there is no point my trainer saying to you that you struggle with this part, let me just do this quickly and you can get on with the rest of the operation. Perhaps in that operation, the only thing that I probably should be doing would be splenic flexor mobilization, so I can actually improve my set of skill. It's also important to look at different trainees who learn at different stages. As a trainer, I'm sure people sitting in the audience would know that as a trainer, you probably would be interested in this trainee, because there's no point telling them at 22 cases that perhaps robotic rectal cancer surgery or laparoscopic rectal cancer surgery is not for you. As a trainer, you need to identify that problem somewhere around here so you can plateau those curves. So this is important roadmap, and there's a lot of data that we have. Now, just to break down some numbers, across Europe, actually outside Europe now, we have 153 consultant colorectal surgeons who have signed up in the program, 23 countries, and actually it has gone out of Europe as well. 80 delegates so far have passed the assessment in the criteria that I have outlined to you. This is just a short-term outcome data. This is in surgical endoscopy. Hopefully will be coming out fairly soon. We look at the first 26 colorectal units that were trained using that program that I've just spoken about. And they were asked to collect data once they were signed off. So these are some number breakdown. 26 trainees had 323 cases done under supervision. So this is being when the proctor, the trainer from EARCs have been around. This is the demographics of those. They got graduated and they carried out in the next 8 months to 10 months, total of 626 cases at their own. We also included 4 proctors data in the same timeline as a control group. So you could see the demographics very, very similar, except that malignancy were done more often by the proctors because proctors were doing more of the rectal cancers within the system. This is an interesting figure for you to look at. Of course, people who are trained, who are proctors, they did it slightly faster. No difference, no surprises along the operative time. Blood loss, statistically significant, but no clinical relevance between 30 and 50 mils. Length of stay, a day shorter in proctor group. The rest of the outcomes in terms of reoperation, mortality, anastomotic leak rate, R1 dissection rate, and lymph node yield rate is exactly the same. We looked at rectums out of those data. This is over 1,000 cases, and we extracted totally rectal cancers to figure that out, that if there is any difference between any of those components. To no surprise, there was no difference as long as people are supervised in a very structured and standardized way. Only difference in univariate multivariate analysis for Clivian Dendo 1-2 complication is the rectal dissection, not the grade of surgeon even. So the conclusion from this paper is that people who want to learn through structured training program, they can achieve similar and comparable short-term outcomes without harming the patients. I showed you this picture at the beginning. This is the shape of things to come. This is a program now.
There might also be a vein a bit further lateral.
This is the program now being developed and used in different parts of Europe, where you can do remote proctoring sitting in your office, perhaps more relevant in the time of coronavirus. This is Danilo Miskovic, one of my previous fellows, now is based in London now at St. Mark's Hospital, taking somebody through the training in Athens. This is something else which is in a pipeline now, remote operating using 5G technology. The group in Fuzhou, south of China, is doing a lot of work on that. And I've been involved briefly about 6 months ago when the travels were up and about to see their model being used. So this is something to look out for. So in conclusion, Mr. Chairman and ladies and gentlemen, I genuinely believe that only teaching and training can bridge the skill gap that currently exists in terms of knowing and not knowing. I have always been convinced about standardization and formative assessment being the key component for any training program. Simulation and remote training would play increasingly more role as we evolve and as the systems improve. And you have to remember that despite improvement in technology and skill set, the gains would be marginal in excellent hands. So don't expect the robot would suddenly do Bill Heel's operation with pressing one button. You still have to do it. In the words of Brendan Moran, a fool with a tool is still a fool. So you need to learn it better. Thank you ever so much for asking me to speak. I'm really grateful for the opportunity.
Fantastic talk, Professor Parvez. So I think we're out of time, so I will move to the next speaker. It's my privilege to present to you Professor Emery Gorgon. Emery, are you here? Yeah. So Emery, don't believe the way he looks, because he's one of prolific surgeons in the US. He's one of the guys who came over to teach robotic colorectal for, I learned it from him, basically. He came down to Chennai to teach me, for which I'm very grateful personally. And he's mentored around India, teaching lots and lots of people. He is professor of colorectal surgery at the Cleveland Clinic, Ohio. He heads the endoluminal surgery, which I'm very excited about, because he's taking robot and endoscopy, further. And we will talk about that a bit later in the panel discussion. But he's a master surgeon and a great friend. Welcome, Emre.
Thank you very much, Venki. I hope you can all hear me.
Your audio is not a bit clear, but we can hear you.
Thank you.
That's better.
Try to speak a little bit more clearly and bring this.
That's better.
Great. It's a privilege to be here, Venki and Avanish. Really, it's a true honor.
Sir, your audio is not available.
And privilege to be here, Venki. Thank you very much also for the kind invitation.
Emre, your audio is on and off. Emre, your audio is on and off.
Okay.
That's
I have a good connection here. I'm not sure why that is the case. Still not good?
It's better.
Okay. Again, thank you very much. And then I really enjoyed the previous speaker, Dr. Perez. It was very wonderfully summarized about the training. My talk will be a little bit
Emre, you're muted. Emre, okay.
Can you hear me now?
Yes.
Okay, perfect, perfect. I hope my sound quality is also better. Sorry about that. Maybe overseas things are a little bit different, maybe. So, Venki did ask me to talk about setting up a robotic colorectal surgery service. Obviously, here at the Cleveland Clinic, we have a fairly robust colorectal robotic program, and I will try to talk about our experiences here and the challenges we did go through. These are my disclosures, and I also would like to thank Venki for sharing some of his slides from his previous talks. The master-slave robot is actually times back, and Dr. Perez mentioned this a little bit too, from 1990s, like voice-activated controlling in laparoscopy, and these type of master-slave type of robots are introduced for minimally invasive surgery back in 1990s, now almost 30 years ago now, and the goal was to overcome the limitations of laparoscopic surgery, which led to more master-slave robots in the sense of what we use in these days with the robotic surgical platforms. And over the last decade, this has rapidly gained acceptance among us, among colorectal surgeons. And this is one of the pictures that I was down in Chennai, which has been now several years. And I really enjoyed my time there. And thank you again for the hospitality that I was given. But there are, needless to say, major robotic surgical advantages compared to regular laparoscopy. Certainly, there is angulated with 7 degrees of freedom of articulation and improved field of vision, stable three-dimensional view from surgeon-controlled camera. And we all know ergonomics. The tremor is filtered, and it enables also precise dissection in the confined spaces. And this makes the robot actually particularly attractive in the rectal surgery or in the narrow space pelvis. And I really enjoyed, and we did see this beautifully in Venki's and Avanish's videos as well, especially sharp dissection using scissors or hook down in the pelvis is unbelievably convenient and helpful in the pelvic surgery. There are a lot of tools that we use with robotic surgery, cameras, patient card, different instruments, and definitely they all articulate. And these are superior items than what we currently even have in laparoscopic surgery. We have seen how to staple the rectum down there, and they are constantly upgrading. There are other tools that we use with robotic surgery as well. Vessel sealer, and recently the vessel sealer device was also upgraded to a finer tip, and short form 60, a newer device of a stapling device, which angulates actually even more in a 90-degree angle, almost closer to 90 degrees angle. Certainly very superior, improved than the laparoscopic staplers we have, not to mention the Firefly that we can't always very easily introduce during our laparoscopic operations. But regardless of what we have, it's certainly a complex tool and requires buy-in from your entire team members. It is, as you see in a prep for a case in this operating room, a lot of people working on things. It takes a lot of understanding and setup even setting up the robot in the room, where to put it. Are we going to dock in from the sideway or from left lower quadrant in a 45 degrees angle? It takes a lot of experience and team building. Certainly, company needs to support the surgeons as well in the operating room in case also machine-related issues arises. So all this is a complex process, and Dr. Perez really nicely showed how to turn that into a science and make it in a systematic fashion. But also, we need to relearn completely how we do surgery. Even different than laparoscopic surgery, we come up with different port placements, and that also takes and requires some training, as well as patient positioning, and also where we extract the specimen, how much we extract the specimen. We heard about hybrid techniques, and we know that without the motion-activated tables, it is very hard to take the splenic flexure as well. Even nowadays, with the XI, it's also still harder. But certainly, that made some improvement for colorectal surgeons to be able to operate in multi-quadrant areas. But our port placement is completely changed with the XI as well. So it's not only important or enough to learn, but also you need to upgrade your learnings as new devices come into the market. But in terms of back to the original title and the topic of this talk, how to build a robotic colorectal surgery program, I can tell you that just training an individual surgeon alone is not enough to sustain and develop a successful robotic program. That's not gonna cut it. So any adoption of a new technique should be linked to teaching and training of a team, like we heard during the previous speaker's beautiful presentation. But how can we do that? It has multiple items, and they should be all linked together. That increase, of course, the main key item here is, I think, the team training and get the entire team build up. But also, you need to increase your volume and create your case volume every day to be able to maintain your skill sets, not only your skill sets, but also your team's teachings and learnings, that they keep practicing that. Subspecialization, needless to say, here at the United States, especially in our department, we only do obviously colorectal surgery. There's no other operations. Last time I performed a gallbladder was more than 10 years ago. And also the other item is, of course, OR efficiency, which goes with the team training, but certainly getting also a setup, nursing managers, allocated times, and also procedure times, of course. They are all a bundle together to be successful building a successful robotic colorectal surgical program. But it needs to be a standardization of this and structured training module, certainly. And typically, what's recommended is there should be set of protocols from surgeon selection to training curriculum. Typically, these start with case observation, lectures on pelvic anatomy for colorectal surgery and total mesorectal excision surgery, and training the candidates on a consult, which is followed by hands-on training using cadaveric material and clinical hands-on training that follows this initial steps under the mentorship of faculty members. Indeed, we did perform this as well in our program, and recently we came up with our Cleveland Clinic robotic surgery training program curriculum, and there are several pages. We really outline how we need to get this transferred across our trainees as well as new learners, and we came up with learning objectives and goals, which describes potential advantages and disadvantages of unique robotic surgery. We try to teach them the basic components of robotic operating systems and understand how to interact with each other. I mean, this all takes training and learning, like almost in the military system, talking back, yes, staple is going on, and cleaning the camera, yes, I'm cleaning the camera at the bedside, constant communication. This is different than how we operate face-to-face or side-by-side, even with laparoscopy or open surgery. And also the trainees should understand the indications of robotic surgery, recognize patient safety, and learn how to dock the robot. It's not only just sitting at the console, also bedside assistance and learning is very important, because if they cannot understand that concept, that portion, they're not going to be able to be a good console operator. And the goal is, of course, being able to operate independently on the robot at the completion of this training. But before we even train them, also we came up with requirements that they need to complete the online training modules. They need to attend skill labs, especially at the center, thankfully, and there's good support from our company that they give us some assistance with that, as well as that involves, of course, cadaveric training and bedside, as well as console training, and then to transfer these learnings into the console operating at real cases. And then, like we heard before, 10 cases, we did come up with, again, arbitrary 20 cases, but certainly our trainees, our fellows should be performing at least 50% of these cases, and at least bedside assistance, 5 cases they need to do before they can move on the console to do their cases. And at least, again, out of these 20 cases, we require that 5 cases, at least 5 cases are including post-case review with the faculty, with the teacher, and then they get a grading and scorecard, and they need to be competent on the console for all these 5 cases. And to be able to get a certificate at the end of our session or the completion of this training, they need to be competent and deemed competent based on at least 2 faculty members. And these are some of the robotic case logs that we have, and this is filled by the trainees as well as the faculty members. Like I said, again, at least 2. And there are some items like we really scrutinize their skills, camera and clutching, and the wrist manipulation, manipulation, energy and dissection, needle driving. All these are really singly, one by one evaluated. And if there are any areas that needs improvement, then they go back and complete these areas. Again, these are some case logs that they enter. But ultimately, to optimize a colorectal program, of course, training is one aspect of this whole planning. But subspecialization, as we discussed before, you can't be doing everything, or your nurses also should be subspecialized. Urology nurse probably should not be also assisting colorectal nurse in ideal world. But if you have the volume, that is possible. But subspecialization applies not only for the surgeon, but also for your entire team. Increasing volumes helps with that, and skill set. Team building, again, very important. As I said, with the bedside assistants, again, assigning nurse practitioners or PAs that are constantly with you in the operating room is an excellent way of developing a good robotic program. That also helps with the fellow satisfaction and fellow teaching as well. After, of course, the fellows complete their bedside learnings, they can move on to the console and get console training and console surgeon training. But if you don't have such a dedicated also bedside assistant, then they will never be able to move on to the console, because then they'll be stuck at the bedside, which is also not ideal. So for a good program to sustain and be successful, that's a requirement as well. Oh, and then also always standardize the indications and steps of the procedure. As you always do things in a similar fashion, obviously your team will learn them. And this is a great advice also, starting with simple procedures. As experience increases, progressing to complex cases. The example I gave is sigmoid resections, for example. I think is great cases to start with, very simple. You can just mobilize here and there and then staple. And then as things, as you gain more comfort level, then you can go into the more deep pelvic dissection and harder cases, bigger, bulkier tumors, and so forth. And dual console is a must. I didn't have this for a long time after I switched to dual console system. Really enjoyed and certainly have seen the the satisfaction on the fellow side as well. And then of course, once you are ready, you need to publish your experiences, do marketing and outreach, so you can grow your program. Well, we talked about SI, XI, and then Da Vinci SP. We're lucky enough also have SP at our clinic. FDA only is, of course, approved for urology, this platform for now, but colorectal is pending, and we certainly we started to use our first cases as well. There is 3 arms in the camera and 24 centimeter reach. So this is obviously a video I'm sure you have seen before. This is on a cadaver, but there are great dexterity with this model as well, and it's good for us, for colorectal surgeons, I think, and that's going to be once it's approved and available, more widely utilized, because you can use it transanally. We see here pictures, but similar to that, similar to training models, like this thinking what the presentation like I just gave, it starts even for training fellows at the lab initially, and then goes on to the actual case, and that's what I did as well. Not jumping in, trying something new, and this is what we did in the cadaver, and then use it in the cadaveric model, and see how it docks. How what can we use? This is an abdominal use, for example, doing more like a sigmoid resection or proctectomy from the abdominal side. But then you can move on to, certainly after a while, after this, to the transanal platform approach as well. I'm gonna fast forward here a little bit. This is actually a robotic ESD. Started out with robotic ESD, then transanal local excision. I'm sorry, transanal TME, and see how it works. I mean, obviously, you don't want to do a new device, all these more extensive procedures in a real life settings before you try this in the lab setting. And this is the transanal docking you see here in the lab model, as well as the transanal TME specimen here again in the cadaveric model. This is our first human experience with the SP in 2 initial experiences, and for actually this is endorobotics, utilizing it in the endoscopic view, in the endoluminal platform. It's first case is a 45-year-old man with a 45 millimeter rectal polyp. You again see in the real life the transanal docking, and then here submucosal injection. So here we're not doing a real TEMIS in the sense how we do it, like in a full thickness fashion, but this is more like what we are used to from our endoscopic training and endoluminal surgical experiences, staying in the endoscopic submucosal planes, so not necessarily taking it. And this is almost impossible with TEMIS, but here you see how much dexterity we have, and these and you can appreciate actually submucosal planes very well. The muscle stays in the base here, and you just operate in the submucosal plane and take a partial thickness removal of this pre-malignant lesions. And imagine that these lesions are up higher, and you're using this flexible robot. Here you can again appreciate the muscle layer and just operating in the submucosal plane. Something like this takes really like 10 minutes, whereas in the ESD world, like in Japan or Korean endoscopists and proceduralists do. Takes these like 90 minutes, sometimes 2-3 hours cases. And not only you can remove those, but also even close these defects. Of course, the access is limited, but that's up and coming. So this is the second case I can quickly, and the first one was actually my very first case. And very quickly, there's, of course, once you are trained in robotic console, you can very quickly adapt. And here you see the same thing. I switch from scissors on the right hand to a hook, which I think for endo robotics approach, much more useful and gives you precise dissection. The other one is a little bit bulky, but you can appreciate this endoscopic submucosal dissection beautifully, staying in the plane, muscle layer in the bottom, and we are in the submucosal plane. Again, the blue is from submucosal injection that we did before, like we do always with endoluminal approaches or when we do ESD. And these major vessels can be also coagulated very easily. Again, 5-6 minutes dissection, and it's done. And we can close the defect. So to finish up, it is certainly conceivable that in the near future, robotic systems will become part of routine surgical practice in colorectal surgery in a widespread fashion, not only very limited amount. And I strongly believe and know that endorobotic, like I showed you, will enable also endoluminal surgery and will be more part of our practice. In conclusion, increasing experiences and learning and building robotic programs like we discussed, me and my previous speaker, will advance with the help of the advancement in technology and competition. I think that's also a very, very important aspect which will bring the cost down, and this will help the robotic surgery, especially robotic colorectal surgery, to improve its value of care. And the utility of alternative strategies like we discussed, endorobotics, will be developed and expand. But again, for physicians like ourselves, should be responsibly incorporating these into our surgical practices. I again thanking both Dr. Venki and Dr. Saklani for the kind invitation here, and looking forward for the panel that is coming up a little bit later.
Thanks, Embry. What a great presentation, man, both with Professor Amres and Embry. Some great things. I think for all the trainees who are watching, everyone wants to be on the console there, but what everyone is telling you, without doing the basics, you can't build a skyscraper. The foundation has to be strong. You need to be a good cameraman. You need to be an assistant. If someone puts you on the console, you won't know what the assistant has to do. So you have to do all the roles well. Thanks, Embry. Very good. We'll do the questions in the panel now. So we'll move on to the next thing there.
Thank you very much.
I think whenever we start the robotic program, what we have is sort of unconscious incompetence. And then you have a level of skill that reaches unconscious competence. And when I introduce my next speaker, we're talking about tips and tricks in robotic surgery. We all learn with experience, and usually bad experience. But when we get through those, you learn those tips and tricks of the trade. So I think for the next speaker, I shall introduce Dr. Vincent Tobias, who is the Chief of Colorectal Surgery, Associate Professor and Chair of Robotic Program as well. And he's going to talk about tips and tricks in robotic surgery. I'm sure everyone has been waiting for his talks and videos. Thank you for coming, Professor Tobias. Okay,
Thank you very much. Share. Sorry. Can you see my screen?
Yes, that's great.
Can you hear me?
Yeah.
Great. Thank you very much for inviting me to speak at CRSA India. Very excited to be part of one of the first conferences in robotics in India. And thank you, Venki and Dr. Saklani and Dr. Bindal for inviting me. It warms my heart to see Cleveland Clinic training robotics, and Emory's doing a wonderful job there, leading the way. And I know that they'll continue to push the envelope in minimally invasive surgery at my alma mater. These are my disclosures. As everyone talked about, robotics is wonderful with a 3D view, good hand movements, shorter learning curve, maybe improved nerve and oncologic functions. And really, I did it because it's the future of minimally invasive surgery. We're going to be using robotics more and more in a variety of settings. You're not going to get to AI and machine learning without a robotic system, and that's the future. The problem with robotics is expensive, it's bulky, multi-quadrant, and there's a learning curve, and we'll go over some of these. But really my focus is on tips and tricks. You're not going to see a lot of data here, but you're going to see things that I ran into and how I avoided it and how I hope others avoid the problems I went into. And really, these are all important for people just starting up. When you're first starting, and the first two surgeons speaking today on this session talked about this, it's really important to have the same team. When I started at GW, I was basically the only one who had never done robotics. I was part of a urology team that everyone knew robotic systems, and I was the one with the learning curve. Now, when a new fellow or resident comes on board, they're the only one in the room who doesn't know robotics. When you have everyone learning robotics at the same time, it takes a longer learning curve. It can happen, but it takes a longer learning curve. Again, discussing surgical residents, Emory has the same issue. A lot of us in these panels have the same issue dealing with residents and fellows. You've got to train yourself before you train anybody else. And then of course, you have to expect longer operative times and a learning curve. Our article, my personal series just got accepted for colorectal disease. And really when you looked at deep TME learning curve, it's actually probably closer to 30 to 40 cases rather than 20. But we'll see how it's accepted in the literature when it comes out. So I like to do the same robotic setup every time. So no one asks me, well, if it's a right colectomy, do you want to do a supine or lithotomy? Every patient's lithotomy, bean bag, both arms tucked, etc. So that way, questions taken right out of the gate that they don't even have to ask me about positioning. Obviously, same team, same bedside if you can help it, every time. Don't change your technique when you're doing robotics. Robotics is made to, and you should be able to do medial to lateral, lateral to medial, whichever technique. Don't make it up. You don't need to with robotics. Obviously, low BMI patients, but certainly if you can start with low BMI, better. And practice, as mentioned earlier here, wonderful ways to train and educate in robotics with simulation after hours. You definitely need to learn the robot before you apply it to the patient, and you can. And laparoscopy was hard. You had a box, but in robotics, you actually have the console, and you can get your hands comfortable with clutching and swapping instruments. So when you're in the patient trying to do robotic colectomies and low anteriors, you're not making it up. So I thought the transition from laparoscopic to robotic was not as intense as going from open to MIS. You're seeing the same planes, you're just seeing it better. You're using different instruments, but better instruments. The loss of tactile sensation was offset by the 3D visualization of robotics. When you went from open to MIS, you lost a lot of tactile sensation. And you went from lap to robotic, you lost the rest of your tactile sensation, but you picked it up with 3D visualization. And so in fact, if you talk to most robotic surgeons, tactile sensation is not at the top of their list of what they want. They want other things rather than tactile sensation. Pelvic surgery and retraction is easier. Transection of the bowel is still hard. Even with a robotic stapler and all these techniques, transection at distal rectum is still a challenge. I did as many procedures as possible. I know that internationally and nationally, the TME is the gold standard for robotics. But to this day, I still do rights, lefts, subtotal, sigmoids, anything I can get my hands on. I trained at the Cleveland Clinic, and you start day one as a new attending with 5 rectal cancers in your clinic. When you're, in a normal setting, if you only use robotic TME as your only learning curve, and if it takes you 40 some cases, you're going to take 5 to 10 years to get through your learning curve. But if you do a right and a left and a sigmoid and a rectopexy, you'll get through it quickly, and you'll be comfortable for the tough cases down the line. And when you get trained, make sure your first robotic case is done quickly. You don't want to get trained on robotics, and then your first robotic TME is a month, 3 months down the line, and you forget. The decision between open versus lap versus robot really is a decision between open and MIS. You're not going to be doing a patient who's had a previous, X-lap, open abdomen washout, split thickness skin graft over their omentum, and do that case robotically or lap. There are some caveats. There are many cases that you can do robotically that are difficult laparoscopically, like high BMI patients and distal rectal cancers, and even complex cases. Initially I would avoid more complex surgeries when you're starting out, which I'll go into. So I think the terrific first procedures to do is rectopexies. It's a benign pelvic dissection and it's not cancer. The next best is a sigmoid colectomy, similar port sites without the pelvic dissection, and even a right colectomy. We're all comfortable with the anatomy of the right colectomy. It may not be the first thing you think about for robotics, but you'll get to learn the system and how it works in the belly in a relatively low stress environment. Avoid total colectomies, especially when you have an SI and you have to double dock. An XI, you can single dock and move the boom around. But it is troubling. Just choose a side. Go left, go right, and do the rest laparoscopically just to keep the pace moving. Low anterior resections for cancer. Look, we're doing robotics for rectal cancer for a reason. It is the hardest procedure we do when we do rectal cancer and we're trying to preserve nerve function, trying to take the cancer out. But it shouldn't be your first case. It should be, get through a little bit of your learning curve before you jump right into that bulky cancer eroding into very close to the levators there. And of course, complicated procedures. You don't want to be doing en bloc resections as your first few cases. So just some common sense. I have the same setup every time. This is my laparoscopic setup, quite honestly. Everyone's in yellow fins, lithotomy, legs are relatively flat and low. The robot is a bit easier to dock and the arms come from the ceiling more than it comes from the side. So getting the legs low is very important in laparoscopy, less important in robotics. Now I just wanted to go straight into the tips and tricks for various procedures. For APRs and deep low anterior resections, I really recommend keeping the SI ports a bit lower and more medial. And I'll show you on a sign here. But really, you want to have your ports more medial, so when you're doing deep pelvic dissection, your instruments can go down to it. The XI is more flexible with length and an extra joint, but definitely with an SI, you want to keep your ports a bit more medial, especially number 1 and 2, and that way you can go down to the pelvis. You also don't want your camera too far away from the pubis. You want it a bit lower down. You can put a bump under the perineum, so if you want to put pressure there, you're able to push the perineum up to you when you're doing a low anterior. And when you're doing an APR, I like to take the levators intracorporeally, and we have a nice video of that where you're actually taking the levators intracorporeally and then doing the anococcygeal ligament last and anteriorly. So that way you're basically just taking skin when you're in the perineal portion, and the patient can be in lithotomy. I don't necessarily flip. At the Cleveland Clinic, multiple surgeons like to flip and do that AP resection and prone. I just keep them all in lithotomy, and when you take the levators intracorporeally, you don't have to go that deep from below. Of course, use Lone Star, and of course, you may need to use a flap. So these are the port sites for SI. I really focus on keeping the number 1 more medial so you can actually go down. And here's the ports for XI. I actually put these ports, instead of quite so angular, I almost have it sort of a flattened angle here so that you can get to the pelvis. You can still mobilize quite a bit. And of course, for true AP resection, I might just go straight across because I know I'm not worried about the splenic flexure. Here we have a nice video. Might just bump it up a little bit so we can get there. Once you get to once you get down to the levators, you try not to cone in so that you can actually have a nice circumferential margin. Let's move it up a little bit more for us. And so when we're down low, here we are at the levators. We try not to cone in. We just start taking levators going all the way through. Now this leaves a fairly large defect, but oncologically is very safe. Now, if you know obviously where the cancer is, you can maybe you can be a bit closer on the side away from the cancer. But really what we're doing here is taking levators intracorporeally. You keep going until you start seeing the perirectal fat. And so we'll show that in a second. I remember as a resident fellow struggling to get all the way to the elevators and all the way through and connecting what we did from above. This just makes it fairly easy. On that side here, this is, again, we're going through, maybe now on the right side, I believe. And again, we're getting down deep. I know we're still on the left side and connecting down. And we'll go to the other side. What we've done. You can see that we've done a little bit on the right side as well. And I love using scissor cautery down here. Some people like to use a hook. It's a little bit cheaper than the scissor cautery, but I enjoy the scissor cautery the most. And the last thing you do after you've taken the levators on the right and left, and you can see here deeply the parietal fat, is the anococcygeal ligament. This is a hard ligament. You go right through it, and then you're basically done. The last part's the anterior portion. You can take some of that intracorporeally, or you can do it from below. A nice cylindrical AP resection there. Another tip and trick is the infamous vessel bleed and IMA bleeds. I always take the IMA with the vessel sealer. I don't use a stapler, but if you have a calcified vessel, this can bleed and cause an issue. I tend to use a laparoscopic endoloop intracorporeally to control this bleeding. Just want to show you a quick video. Emery, did you put a yellow line on my? Like a yellow line there, huh?
Sorry, wasn't intentional.
You're trying to draw my terrible videos. So here's my resident healthfully suctioning off my seal and causing a nice bleed. No, I'm sure it wasn't just a resident, but you can see the IMA going there. You know, the first thing is that you don't put the camera right on it, because if you put the camera too close, you'll get splashed blood, and then now you're chasing around. These are similar things you do for laparoscopy. So once you control bleeding, I then kick the resident out and get a chief to help me with an endoloop. We then come through, grab the vessel right through it, and then tie it down. You have to make sure somebody understands how to use this endoloop. Now, if this doesn't work, I would definitely think about using like a 3.0 or 2.0 Prolene to oversew. Just remember, when you're oversewing basically near the aorta. And what I tend to do also is I skeletonize the IMA a bit more now and take the IMA a bit higher after I've taken the lymphovascular pedicles. And so that way I have a little bit of a cuff so that if it does bleed, it's easier to endoloop or oversew. Tips and tricks for pelvic bleeding. Here, you know, beautiful TME earlier by Venki. But even when you think you're in perfect plane, every now and then you'll hit a vessel. Really, what you really want to do is you want to do direct visualization of the bleed. You would like to clear the area. You want to use bipolar cautery if you can, and then use robotic suction. I hardly ever use robotic suction, but when I do need to, it's wonderful. It's articulates, and it bends down into the pelvis beautifully. And I know some robotic surgeons in America who only use a robotic suction as their second or third arm when you're doing robotic pelvic surgery. I think it's overkill, but the few times you need it, it's nice to have it because it really does clear it and suction better than laparoscopy. Again, don't try to burn right on top of the bleed. I don't put the Bovie to 100 and burn a bigger hole. I like to just clear the area and then use bipolar, which I'll show here. So here we are doing the TME. Dissecting. I thought it was in the right plane, and you start bleeding immediately. And I mean, I have to admit, I think this was one of my fellows in resident doing it. They were kind of stunned by it. I took them right off the console and looking at it. So I just tried to burn a little bit on top of it, realized I just make a bigger hole. And then the question now is, you know, how to handle this. I like to clear again, not to get the camera too close, or else you get blood on the camera and you lose view. Clear out the area a little bit so that you're able to do the rest to identify the bleed. And then I would just use bipolar. You can oversew this, but I think if you use bipolar correctly, it works out fine. Here, I actually like to use the bipolar to the sides and let it arc between the two and sort of like coming in and arc welding around it, and it works beautifully. You know, you might get a bleed bad enough you need to oversew, which you certainly can do, but this works great here for the bipolar. And I don't, my number 2 and number 3 arms are not bipolar. They're longer instruments like the tip up or the grasping retractor, and I only use bipolar as needed. I know a lot of people like to use a bipolar as their second hand. So now what happens if you have the dreaded anastomotic leak? It's been a long case, you have a colorectal anastomosis, and now you have a leak. So at this point, I would think about different ways, and I like to oversew. This is not what the board answer is when you're getting your oral exam, but this is something that the robotic system and suturing is very easy to do. But you have to be very aggressive to check for the leak, and you have to be very aggressive to make sure there's no leak afterwards. So here's a quick video. Again, tough case, long day, you do your leak test, and you see some bubbles thinking, oh, it's just some air trapped in the pelvis. I'm sure it'll go away. And, you know, eventually you see it doesn't. So I would say that rather than using a rigid procto or a bulb syringe, you get a colonoscope to really assess where the leak is. And so now I've really assessed where the leak is. I slowly suction the fluid down to identify where the leak is a bit better. And you can start seeing it right there, that dreaded crotch bleed associated with the circular and linear stapler when you do double staple. So in this case, it was a tiny area. It wasn't multiple areas or complete disruption. In fact, it was the area where the 2 staple lines met. So I decided to do an oversew with figure of 8s multiple times with a 2-0 Vicryl. These days, I might use a bit more aggressive with 3-0 V-lock and oversew a lot more of it. But in this case, I just decided to do a bunch of figure of 8s. And again, you know, when you have a system like this and you're comfortable suturing, you can do this. Now, we have plenty of length. I can certainly redo the entire anastomosis if I need to, but I decided let's stretch some stitches here, and then we aggressively check afterwards. Just to move it forward. And then eventually I do about 2 or 3, and we do a repeat leak test, and it's fine. This patient I did not divert, did not have radiation, and went home in 3 days. Again, and you can see I'm aggressively pushing air in to make sure. Now that's not the board answer, but that's the answer that, you know, you can do just fine with robotics. So Firefly tips and tricks, you know, the Firefly is great for visualization of anatomy, feedback to get real-time clinical decisions, and multimodal. We use it to identify the IMA, poor perfusion, and rectal stump perfusion, but I usually use it for bowel perfusion. These are my last few videos. So here's a quick video here of sigmoid colectomy. You know, we had some people observing and they're asking me, hey, you know, do you see any kind of, can I show a Firefly? I was like, sure, no problem. This will be just great to show perfusion. And, you know, at this point in the case.
Sorry to disturb you. I think we're running short of time because the next session is also.
Oh, sure, no problem. Again, just showing that the perfusion isn't as what you think it is. So basically, you know, I just wanted to do a few tips and tricks. You can see here that I do Firefly for every colectomy and for every anastomosis. I don't just use it for what I think is worrisome. That way I'm comfortable with my hemosis every time. So thank you all for allowing me to speak on robotics tips and tricks.
Thanks, Professor Bass. That was great. Awesome. I wish you could have had more time, but I think there are a lot of sessions in there. So, so Venki, over to the panel discussion. We'll get to more discussion as we go around from the panel. Yeah. Thanks, Professor Bass.
We have, its time is 4:52. We have until 5:15. I've been informed by Vivek Bindal, because of time constraints. So welcome to the panel. So, Professor Pervez, Professor Obayas, Professor Gorgon, TK Rajesh from Plymouth.
It's Anil Hirul from Fortis as well. Hi Anil, good to see you.
Yeah.
Still operating on a Saturday.
So Dr. Govil is not joining us, so we'll jump straight into this. So I thought instead of, Avani sent me a huge presentation full of cases which are like, I don't think they are Friday evening material to be discussed. It will like drive us crazy because, the tumor here, peritoneal disease, I think I'll kill myself. But I thought, okay, let's just have some discussion, put it on the floor and say what people think about it. So So this, I want all the panel members to jump in, and I'll ask Avanish to ask other people as well if he wants. So let's start with that. So it's going to be a free-flowing panel discussion. Some of you might have. So the first thing started with robotic single port surgery. So Vince, what's your view on this? Does it have a role as it stands?
Well, I'll tell you, I've been on the system for the single port for the intuitive robot, and it's extremely accurate around the size of a tennis ball. And Emery can say that. I mean, it's very accurate. I mean, I would say that the robotic single port system might be better for vascular surgery than doing a right colectomy or a subtotal. I still have the largest series in the literature on single incision robotics, and it is all based on the SI using the cross arm system. So, you know, with my setup, I did a lot of it, but we had a lot of port side, single incision port side hernias if your BMI was above 30. In America, everyone's BMI is above 30. So I think that the single port system for intuitive is extremely powerful, can open new doors for robotic surgery. But I think it'd be great for transanal and TATME. But I wonder how difficult it's going to be for multi-quadrant colectomies.
Emery?
Yeah, can you hear me?
Yeah.
Yeah, so I did do a single port completion fructectomy.
Emery, we can't hear you properly. You probably need to get your mic closer on.
I did perform a J-pouch completion fructectomy with ilial pattern platform. So it actually works well. Again, in the confined space down to the pelvis, it really functions well, and you can do the full fructectomy from the standpoint. I think the J-pouch patients are.
We can't hear you, Emery. Okay, we'll come back to you.
Okay.
Anil, what do you think? Do you think in India, I know it's not available, but do you think it's a role, affordability, practicality? What do you think, Anil Hero?
Thanks, Vicky. Great presentations. Enjoyed it throughout. Now, I think the single port, we will have to see how it works. Whatever we have seen of single port surgery, as far as oncology surgery is concerned, we are not very enthusiastic. I hope the single port Da Vinci does better. As Vincent said, I think I would be worried about multi-quadrant surgery. I don't know how it will work there, because even with the current systems, it is difficult to have to work in multiple quadrants.
Avanish?
I think the most important thing, I think, would be the cost. I think we are already struggling with cost, especially if people have lost their finances and jobs. I think the cost of the consumable for single port is slightly higher, which I don't know whether Embry or Professor Parvez know about this, but I think the cost of consumable for single port is definitely much higher than for the normal robotic system. Anyone idea? Embry, have you got any idea?
I don't know the exact cost. Yes, I don't know. I think it comes as a package, full package with some sets of instruments. So it's not like the SI or XI, you know, depending how many instruments you open. It just comes as a bundle, and they charge you for that. I think, though, I believe they didn't. I mean, the administration did not give me a hard time. I don't think it is much higher than our regular XI or SI costs, so similar. If you can hear me, I can comment on that. I did perform single port completion proctectomy in the abdomen using this. Actually, it really is very convenient to use down in the confined space in the pelvis. Especially, I mean, there's certainly a learning curve, but I did complete the case, my first case, in 3-4 hours, less than 4 hours for sure, for doing a pouch, which is pretty normal. But like Vince said, I think changing quadrants can take a little bit longer, but also it's a different mode of it, and it really moves. Actually, once you get hang of it, it actually moves fairly well. But of course, you need to work in one space and then move to another space and work it. But I think the main I think benefit of this platform is this is going to be a transition into the more like endo-flexible robotic platforms. I think this is just like a segue into that new gonna be the role of this platform. I'm not sure if there's a huge role for abdominal surgery.
Professor Parveen?
Yeah, I think I concur with most of you. If you look at it, it suffers with the same problem with the single port laparoscopy, for example, particularly for people who do oncological operation. So the rate limiting step always is a specimen that is going to come out of a small hole. And with mesorectal specimen extraction or mesocolon specimen extraction, there is a problem. I have had a chance to work with it. I have spoken and shared the data with Hong Kong group who have done a lot of clinical work, and they struggle, for example, for staple division. So they almost are doing what you call SP+1 or SP+2. So effectively, they're trying desperately to show that they can complete the operation. That is not the whole point. The whole point is that it should bring us what we call add-on value to in our practice or to the patients. So I suspect it would sit conveniently with endoluminal approach. For example, oral surgery or transanal surgery as shown by Emery. So I think it would be useful there, but for most of us who are abdominal surgeons, the utility has got little to offer or few things to offer as compared to what we already have.
Professor Parvez, should I come back on this? Thank you, because I think initially the single port was thinking that you could complete the TATME part of procedure as single port. And now with the Norwegian thing and the moratoriums are merged, so somehow the single port is stuck somewhere. What are your views on TATME actually?
We're coming to this next, Avanish.
Okay, great, go on.
So I thought we finished with this endoluminal because the single port. Emmerich, your quick take on endoluminal, because you guys have put up a separate department. That's very exciting, and hopefully we'll come and I've spent some time in your endoscopy theater where you work closely with your gastroenterologist and you have parallel sessions with them. So can you just tell us about where this is going in this field?
Yeah, it's very exciting actually. Here we built an endoluminal surgery center. In the United States, 30,000 patients undergo colon and rectal resections for benign polyps, pre-malignant polyps. It's a huge number. I mean, some think, oh, it's a right hemicolectomy, but there are multiple studies from US and globally that shows the mortality, it's up to 1%. So it's not a benign procedure. We always see, like with a retroperitoneal abscesses or anastomotic leaks, and in older patients and so forth, as polyps can occur. I mean, there's certainly a huge benefit and role for this, and it should be in the hands of, I think, surgeons as well, since we are more interventionalists and more comfortable managing these lesions, definitely more than gastroenterologists. But we partnered with my gastroenterologist to keep these things, in a collaboration.
Yeah. What platforms are you using now?
What?
What platforms are you using?
Yeah, there are different platforms. I mean, I was just exploring this SP platform. Certainly there are MedRobotics. Vince knows about that as well. Platform. There are others like Dilumen, TRS, Boston Scientific platforms, and there are actually several fully flexible endorobotic devices that are in R&D. They are in development, so they are up and coming. In terms of the TATME, Venki, I can tell you that as well. I think for this platform, the SP, Da Vinci SP, it has to go in and then open up, and it takes about 8 centimeters to make that like a cobra move, if you will. And that actually is a little bit tricky with the transanal TME using the SP platform. That limits it. That really, I think, is the downside of that device for TATME. I think they need to bring that angulation distance a little bit closer, then it could potentially make that procedure a little easier, the SP platform.
Avanish, do you think in India we should start working on this?
I think single port has got a great potential, but I think we'll have to use it for limited cases. I think it has got Endoluminal, yeah. I mean, I think at present the number of early cases that we get are really very low, 2 or 3%. But even for TEO in a big center, we would be lucky if we did 10 in a year or something. We are not talking about post CTRT and wait and watch, but they're pretty low. So if we do it, we have to do it in specialized center. So you should be able to get a large volume of cases to get it there. So I think whoever does it, I think has to become a tertiary center, because the early cases are less at present.
Okay. So
Avanish, how is the screening protocols? I think that would depend, Venki, your answer would depend on how widespread the screening is in your country. I think that
that's the problem, because in the UK, for example, there are 35,000 cancers per year. In India, we also have 35,000 cancers per year, but sorry, about 50 to 60,000 cancers, but we have a population of 1.4 billion. So we can only screen high-risk people or people who are symptomatic. We just can't roll out a screening program. I don't think that's feasible. So that's where the problem lies. So
other thing, I think.
Sorry, go ahead.
Yeah, go on, Anil.
Yeah, no, I think the incidence of CRC in India is thankfully very low still. I mean, we have not yet crossed even 7 to 8. The last thing showed us an incidence of about 5 per 1 lakh population.
Yeah.
I don't think we can have a public screening program in India as far as CRC is. What do you think, Avnish?
But I'm sure still there is plenty of people that are getting screened, right? I mean, a good portion of the population probably still is diagnosed with some polyps.
No, so we don't have. That's the problem, because of the population, the way health systems are set up. That's a challenge. That's why we get advanced disease most of the time. So one of time going on to the next topic, Dr. Rajesh TK. Now I'm going to just call him TK because that's how we call him. So Rajesh, what do you think about transanal TME with robotics? Do we really need to use a transanal platform? I think with robotics, we can go really, really low. What's your view on this?
Yeah, thank you, Venki. Thank you for taking me as a panelist. Me and Mark Coleman went for the first training program in England on transanal TME, and we have been doing transanal TME. They were thought that it's by bridging between the robotic and the laparoscopic platform to access a difficult obese male patient. After going through many patients and reading through the Norwegian moratorium, we also found a lot of multifocal pelvic secondaries after the transanal TME. And the complication rates are slightly more than the laparoscopic or robotic TME. I think at present we have stopped. In England, there is a pause to the transanal TME, and we are all planning to do robotic TME. I would personally feel if you can access the lower part of the rectum through robotic without any difficulties, that is better than a transanal TME. And now I have improved a little bit more on transanal TME by double looping technique and making sure there is no mucus spillage. But if there is a male patient with a narrow pelvis with a huge prostate, even the robotic TME will be a difficult process. So proper MDT selection of cases and the pelvic area to be selected to choose between transanal TME and robotic. But in nutshell, if you can access the lower part of the rectum with the robotic, that will be a better preferred way of doing a rectal cancer than a transanal TME. That is my conclusion.
Avanish, what do you think?
I mean, I think TATME, it requires a lot of, even for robotic and laparoscopic, I think it requires a learning curve, and we don't have the systems like Dr. Parvez and Dr. Gogan sort about. So for TATME, we would have to find proctors and do it. I think a bit difficult.
Can you get really, really low with your robot, and you really need to do it? That's all. That's the question I want people to answer.
Maybe, I think most of the time, I think conversion rates are very low, so even for high BMI, but maybe 2 or 3 times in a year you feel you will not be able to get the staple across. And in those, when we do ISR, then you struggle because the plane is slightly low, and sometimes the camera there would help. But it would definitely be an asset to do it in these difficult cases there. But for everyone, I'm not very sure, but we need to learn the skill, definitely.
Okay, right, Professor Parvez. There's a big question. There are people arguing like, yeah, we can jump onto the robot straight away from, being an open surgeon. What you've been through the entire, I was a registrar, so I know You did open, you were doing lap, and now you're robotics. So what's your view on this? Do people, does it benefit to have laparoscopic experience for doing robotic colorectal surgery?
Yeah, I think the key really is anatomy. Anatomy holds the key for me. Techniques sort of follow the anatomy. So if you are a good anatomical surgeon, eye open or laparoscopist, then you change the tool and then you follow the same anatomical plane. I mean, when I go around and train people, it's really a prejudice that we all have in something that we don't particularly like. For example, when we were learning laparoscopy, people who hated laparoscopy were very good open anatomical surgeons because they keep telling me that they could do the same operation so much better. Now with robot coming in Europe certainly, people who are really against robotic surgery are very good laparoscopic surgeons because they genuinely believe they have to upskill or learn something different. We published this. One of our previous registrar, Manfred Odermatt, looked at previous skill set of laparoscopy, shortening the proficiency gain curve for robotics. So if the question is, can open surgeon learn? Of course they can. Does having a previous laparoscopic experience minimize the proficiency gain curve? Answer is yes, with the proviso that you learn the machine independently. There are two components of doing robotic surgery. One is anatomy and the modules or the patterns, as I call them. And the second one is the system. So your system, you don't need to fight the machine. I could actually walk into somebody's operating room and can figure out if he's a previous laparoscopist, because we try to do the laparoscopic operation, pushing medial to lateral using robotic arms. And you can hear the clunking arms in the room. The open surgeon using the robot would use both hands to separate the tissue, so they tear more. These are personal observations. It hasn't got a science behind it, but you could make it out. So you just have to go back and say, we know what the pattern should look like. I have got a different machine to demonstrate that. So it does help, provided you are not blinded by prejudice.
Great, great. Vince, what's your view?
Absolutely. I think that if you have a laparoscopic training, it helps just because you're used to the view. When you go from open to MIS, it's pretty jarring when you're trying to do open surgery. So I would say that it does help quite a bit. It helped my learning curve. I do know surgeons who went from open and hand assist to robotic and they liked it a lot. But absolutely, it does help. In terms of TATME, honestly, you know, if you can get there robotically, I don't think you have to do TATME. We're actually doing a study, me and Pat Silla, comparing TATME versus robotic TME. And it's just a multi-center trial between like 4 surgeons that ASCAR's supported. So we'll see what the data shows, but we'll be going head to head between Pat and I, and we'll see. But, you know, we just did a mid BMI male pelvis rectal cancer on elevators a week and a half ago. Once you get intersphincteric from above, it's a no-brainer. You're just scoring on the dentate and doing a hand sewn. So in my mind, you know, don't need to do TATME.
Thanks, Vince. Okay, anyone else wants to answer on this? So because we've got another 10 minutes.
May I comment on the TATME as well? I think I agree with Avanish actually. You know, I think it's not for everyone, TATME. I mean, I think initially it was a, you know, blast and everyone, like, it was like, we're gonna be salvaged with this, you know, no more proctectomies will be any difficult and gonna take over for robotic. That's not the case. Certainly we have seen some difficulties and bad complications, but having said that, also there are some cases, I'm sure we all went through that, you know, like open laparoscopy or even open, you can't really do it, you know, like very narrow, tight, you can't get down there. And that's actually how TATME was discovered. You know, I think for a very small group of patients, that's important. And especially if you're doing intersphincteric resection, you can start from there, these narrow pelvis, you know, pre-select these patients. And so I think as a tool, it's good to have that, you know, to have that skill set. But I by no means I'm saying, you know, that's needs to be used across the board for every patient. But when you are in trouble, if you don't know how to do it, you're not going to be able to get yourself out of the difficult situation. So from that perspective, in very select patients, I think it's good.
I mean, I just wanted to ask, you know, because we just had a panel on this at SAGES. It was Pat and I on stage a month ago, and you were there. And so how many cases a year at the Cleveland Clinic personally that you would think you could do TATME on?
I mean, for low rectal cancers that are invading into the intersphincter, that is a male patient. So I think you can do 8 to 10 cases, and probably these are number of cases that you will need and benefit from anyway. Yes, it's not a huge number, but as experienced pelvic surgeons, I think the learning curve is for TATME not easy, but it's not really like in more than 10 or 20 cases, to be honest with you.
So the average colorectal surgeon does not do 8 intersphincterics a year, and so we're talking probably like 3 or 2 or 3. And so even at the Cleveland Clinic, who does 8 to 10 a year, if you need to do 40 TATMEs, you're going to take about 5 years to get through your learning curve. And the average colorectal surgeon, we're going to do 10. Meanwhile, I can do a robotic right, a sigmoid, get used to at least robotics, but I'm not going to do a TATME for diverticulitis. So I think if you go all in like Pat and you're doing mid and upper rectal cancers just to do everything else, you're going to get through that learning curve. But I worry that the average surgeon who doesn't do this is going to start tackling bulky rectal cancers for TATME and have complications like we're seeing internationally.
Agree, Vince. Okay, last question, guys. We've got less than 2 minutes to go. So,
sorry, may I just have one comment before we go?
Sure, Papi.
Okay, because Avinash asked me that. I think if you remember, our president of Royal College of Surgeons many years ago wrote an editorial in BJS describing a place called no man's land in male pelvis. And he said you could never get there with laparoscopy. Now, all of us who've learned laparoscopy and done it since have not seen that no man's land ever. So I think the key really is, as all of you are alluding to, is the technique that you're comfortable with. So TATME came in as a fashion, just like laparoscopy initially came as a fashion. If you're not doing this, you're not sexy enough. So everybody's starting fiddling with it. Same goes with robot. Robot is no exception. If I don't have a robot in my hospital, I would like to be a TATME surgeon, because if I come to meeting, I have no relevance. So I personally think that you should learn anatomy. Most of us know that it's a numbers game. So those male obese, big prostate, low rectal cancer in busy hospital practice are not more than 5 a year. And the guy in USA have been doing an operation called TATA since 1980s. If you can't put a stapler across a big bulky tumor. So we're trying to reinvent something. I think this is the key thing that we have to remember.
Great comment, Prof. And so last, I was going to, this is a snapshot of all the cases in, robotic colorectal surgery across the country. Big hospitals, I just blanked the hospital names. It's slowly growing, but there are big hospitals who have high volumes, but adoption of robotics is less. And I think with meetings like this and the association, hopefully this will come up, and with proper teaching and training. So thanks for the panel. Sorry, we had to cut short. We could discuss this for another hour, but we have to keep it time. Thanks all of you for joining us, and thanks to the organizing team to give us this opportunity.
Thank you for the opportunity.
Thank you.
Bye-bye.
Thank you all. Great discussion.
Awesome.
Thank you.
Thank you, Dr. Venkatesh, and thank you to the esteemed panel. Now we'll be proceeding with the CRSA Gold International section, and the two chairpersons for the next section are Dr. Ramesh Punjani, who is the president AWRSA India, and a from Hospital in Mumbai, also the director of Dr. Punjani.
I've been watching.
We can hear you. So please go ahead.
Yeah. So thank you, Dr. Vivek Bindal, to give me an opportunity to chairing this session. Since afternoon, I've been watching this, and it's going really wonderfully, very well planned and very well executed so far. And we have now another very exciting session, one by Dr. James Bittner. He's going to talk on the robotic AWR experience versus evidence. Dr. James Bittner is a well-known robotic and hernia surgeon and is associated with St. Francis Hospital and Medical Center, Veterans Affairs, Connecticut Health System, West Haven, USA. So, Dr. Bittner, now you please go ahead and tell us about the robotic AWR experience versus evidence.
Well, if you can all hear me, I very much appreciate the opportunity to share with you guys this evening. I wish it was happy hour time here, like it's happy hour time there, because I'd be happy to join you in that as well. But if all can see my slides, hopefully they're sharing everything appropriately. We're going to talk a little bit about robotic ventral hernia repair and what some of the data show. This is a less than sexy talk because of the fact that there's no very cool videos like Vince just showed, but we will talk a little bit about what the science are. So these are my disclosures, which are not specific or germane to my talk today. We're going to talk a little bit about what the trends are for robotic ventral hernia repair, particularly in the United States at various levels, the national, the state, or even the regional or city level. We'll talk about how, at least in the States and other parts of the world, the indications for robotic ventral hernia repair continue to expand and different approaches are being used for these hernia repairs. And then finally, we'll hit a little bit on outcomes. So as you can see here, the real point of the slides with regard to trending is that we are seeing an increase across the United States in their use of the robotic surgical platform in general, and also specifically for general surgery cases. So this could include colorectal, hernia repair, and the like. We're even now comparable in general surgery cases compared to OB/GYN cases, which were predominantly the leader in robotic cases for many years. So, there's the line back, Vince. So in addition to that, we're seeing in a database in the national inpatient sample from 2008 to 2013, some unmatched cohorts comparing laparoscopic and robotic hernia repair just to look at a trend. And what we see is that over this time and the early adoption of robotics in the United States, they were being done in cities and in teaching hospitals, just like you would expect. But there was also some regionalization. So the southern part of the United States, the Midwest part of the United States were adopting it first. The more staunch academic places, perhaps like New England or Southern California, were a little slower to adopt, but now have done so. If you look at the state level, the state of Michigan has a surgical quality collaborative. And between 2012 and 2018, they looked at their data over those 6 years and found that the number of robotics cases has increased 8.4-fold over that time. And it's not just because they're stealing from laparoscopic cases and converting them to robot. They're also decreasing the number of open cases performed and converting them to robot, which is in contrast to some data that might suggest we're taking from laparoscopic and moving it simply to robotic cases, which doesn't seem to be the case when you look at a population level study. If you look specifically at the type of operations being done in Michigan, you can see that the number of robotic ventral hernia repairs over this time frame increased by 44.8-fold. So basically it jumped appreciably. And this is one of the largest growing areas of the use of robotics in the United States. This even applies at the city level, where I used to live in Richmond, Virginia, just down the road from where Dr. Bias is. We looked at our prevalence of robotic ventral hernia repair within the city limits, and it mirrors that of the national frequency, which is anywhere from 17 to 34%. So even at smaller to mid-sized cities, the trend is real. So as we increase the use of the robot to attack ventral hernia repairs, it begs the question, which ventral hernia repairs should we attack? And obviously, you can see the one on the left is a poor choice. Anytime the abdominal wall is blue, that's bad. But we are increasing the number of hernias that we attack robotically, both in their complexity and in their defect size. And while the point of this slide is not to review everything, I understand it's small text. The idea here is more a global one, in the sense that the number of indications where we choose a robotic approach for complex abdominal reconstruction or recurrent incisional hernias is dramatically increasing even in my own practice. So everywhere you see a blue arrow is the end of an algorithm, and the end of that algorithm ends in some type of a robotic repair. And if you look across the bottom, you can see the number of times the robotic repair is preferred over, say, an open repair. And that has shifted even in my own practice over time. Those of my colleagues here and other places around the world, that mirrors their experience as well as they adopt robotics more and more for complex hernia. So that's cool that I do it. It's cool that the trend is positive, but what do the data actually show, and should we keep doing it, and should the trend continue? So looking at the America's Hernia Society quality collaborative data, they compared two matched groups looking at traditional laparoscopic intraperitoneal onlay ventral hernia repair compared to robotics. So hopefully the only thing difference between the two groups is just the technique used. And not surprisingly, the robot group took longer, but more often than not, the mesh was secured to the anterior abdominal wall using sutures only, where in a traditional lap repair, it's often secured with not only sutures, but tacks as well, which we all know have their own issues. They also found that in the laparoscopic group, there are more complications, and they had a higher risk for bowel injury compared to the robotic group. So, you know, even for the most traditional IPOM repair, there may be some outcomes that are benefited by using a robotic surgical platform. But let's move into the more interesting types of hernia repairs, looking at the preperitoneal and retromuscular repairs. So friends of mine, Alfie Carbonell and Jeremy Warren, put together a study where they compared two cohorts which were propensity matched, looking at open retromuscular repairs versus robotic retromuscular repairs. The great majority of the cases, as you can see, were transversus abdominis release, or TAR. Not all of them, but most of them. And what they found wasn't terribly surprising, but was interesting. Sort of rubber meets the road, if you will, was that they shortened hospital length of stay on median by 2 days. And it's interesting because you're going to continue to see that theme in the data that I present with regard to shortened hospital length of stay. So in this study by Liu, published in Surgical Endoscopy in 2019, where they looked specifically at a Reeve-Stopa repair. And in this study, they were comparing a laparoscopic versus robotic, totally extraperitoneal approach to Reeve-Stopa. These cohorts were not matched, so take that with a grain of salt. But they looked at ETEP Reeve-Stopa, and not surprisingly, the robot took longer, but they were able to close larger defects and generally had a lower complication rate compared to the laparoscopic approach. They also looked at quality of life scores. Oops. They also looked at quality of life scores, and what they found ultimately was that 1 year, the quality of life between robotic and laparoscopic was similar. So there may be some short-term benefits. Now this doesn't project terribly well, so I apologize for that, but in this particular study by Yusuf Kudzi out of Boston, they looked at short-term comparisons between a preperitoneal mesh and an intraperitoneal mesh done robotically. So this isn't a robot ETEP Reeve-Stopa, it's truly a preperitoneal repair or an IPOM. And you can see the course of the study allowed for propensity matching, where they had 68 IPOM cases and 68 preperitoneal cases. And what they found after propensity matching the two groups was that the robotic ETEP approach compared to the IPOM approach resulted in less adhesiolysis, which makes sense given the technique, but it also resulted in a larger mesh to defect ratio. So they got bigger pieces of mesh in compared to the defect. They had longer operative times, which again, shouldn't shock anyone, but they had overall complications and morbidity that were lower in the robotic ETEP group compared to the robotic IPOM group. So not only could the robot be helpful with regard to certain outcomes, but the actual approach used may also improve outcomes. And this hopefully demonstrates that to some degree. So if we look at improving other select outcomes and we start to say, okay, well, that's great. We're comparing two specific techniques done robotically. That's somewhat granular. Let's look at the big picture and say, what's just open versus robot? right? And so the AHSQC was used to do that, looking at data from 2013 to 2019. And they simply compared big open approaches to robotic approaches in the retromuscular techniques. And not surprising, again, the robot took longer to perform the operations, and they did bigger defects open. But despite that, when they looked at the 1-year follow-up, which you can see here, when they looked at the 1-year follow-up, the open and robotic ventral cohorts showed comparable improvements in abdominal wall quality of life. So in reality, what we're basically saying here is that at 1 year, they were comparable with that score. But if you look at their length of stay, as I highlighted earlier, the length of stay in the robot group was statistically significantly shorter. So here it's about 1.5 days versus 5 days. And that can become pretty meaningful when you think about it from a cost analysis standpoint. So my group at my previous institution, we looked at comparing open and robotic TAR specifically. So we eliminated all the variables associated with other retromuscular repairs and looked specifically at TAR. We matched 2 cohorts, so these are data from 2015 to 2016, and they represent consecutive cases and initial experience with robotic TAR. So this isn't my robot TAR today, this was my robot TAR of the first ones. And we compared 76 open versus 26 robotic, and you can see the exclusion criteria there. The groups were the same, of course, and here's what we found. Again, longer operative times in the robotic group. Not only was I overcoming a learning curve associated with adopting a new approach to an existing technique, but also we know the robot simply takes longer regardless. We used more often permanent mesh in the robotic cases, and during this time there was a shift in the fixation strategies for mesh. So 74% of the time, more often, we used fibrin sealant only to secure the mesh, which influenced post-operative pain compared to open, where we may have all been traditionally taught to use suture fixation to secure the mesh. Now my practice has changed, and I largely use fibrin sealant for mesh fixation and to decrease seroma rates in both robotic and open approaches, so they mimic one another more closely now. The other interesting thing we found in the robotic group was there was 20% less morbidity. And though that did not reach statistical significance, what it did show was that there was a lower comprehensive complication index, i.e. the complications that the patients suffered were less severe than those patients who underwent an open abdominal reconstruction. But here's where the money is, and that is that in comparison, the 2 groups, the robotic TAR group spent 3 days less in the hospital than the open group. And these data were mirrored by Yuri Nowitzki's group from data from Cleveland before he moved. And basically, their results were almost identical to ours. In fact, they're published even in the same journal of, same issue of surgical endoscopy. And he also showed a median of 3 days shorter hospital length of stay in his comparable cohorts to ours. So there's some growing, and subsequently some data has also demonstrated that shortened hospital length of stay. So there's some potential for improved value related to these operations because we know they take longer in the operating theater. So in summary, at least in the US and other parts of the world as well, frequency in robotics is increasing, specifically to ventral hernia at both the national level, even down to the city level. With that increase in frequency are an expanding number of indications that are being adopted for robotic ventral hernia repair. The thought process now, at least for myself, is a bit different. When I see a patient, I used to think, when could I use the robot to address this hernia? Now I simply assume I'm going to use the robot unless there's some reason not to. It's just a different thought process. And now I look for patients that might require an open repair. Otherwise, the default is robotics. Adopting these new techniques for robotic, whether they be ETEP Reeve Stopa, whether they be single dock, whether they be bottom-up TAR, down, top-down TAR, whatever you want to call it from a alphabet soup standpoint. As these operations develop, I think training on them and also producing data related to them is so critically important. It's fine to try to adopt a new technique, but understanding the data behind it, helping produce the data for it, I think are both important. And then ensuring that your learning curve is something that you address during this period, whether that be with the help of proctors or online training or courses, to assure quality assurance, I think is important. As we get more data with regard to these procedures, I think adopting the right strategy for the right patient, marrying the right technique to the right hernia is so critically important. And you can see from my previous slide that can be really complicated. And then finally, I just want to say thank you. I think one of the things that is so great about robotic ventral hernia repair is the sense that it gives you a chance to have your cake and eat it too, right? So here are my kids having milkshakes and Coca-Cola because they can't decide whether they want ice cream or sugar in one form or another. So the robot is a nice way to be able to construct the abdominal wall and do so in a minimally invasive fashion. So that's what I have for you, and I very much appreciate being here.
Thank you, Dr. Bittner. It was a very good talk, and it really briefed us well on the role of robot in AWR. Now, I've seen, I'm a member of IHC, and I see your comments quite often in the International Hernia Collaboration. But from the ETEP TAR, and I've seen many times you do a laparoscopic TAR because you have the arms which can move in all directions. So you think which is better? Because what is the idea of getting claustrophobic in ETEP rather than doing a laparoscopic TAR, robotic laparoscopic TAR? What I mean to say, you enter the abdomen and then do a TAR.
Yeah, so you mean doing it as an ETEP approach versus a transabdominal approach?
Yes,
yeah?
yes, yeah.
So I will tell you, realistically for me, technically speaking, and one who's teaching fellows and residents, unless there is a reason I should not go into the intraperitoneal cavity, I tend to do it as a transabdominal approach with 6 trocars, 3 on each side. It's technically easier for them to understand and comprehend. It's certainly ergonomically, if you will, ergonomically easier to get to. It's very repeatable. So for the OR staff, they know exactly what we're going to do. When we're doing it as an ETEP approach, whether that's from the bottom up or from the top down, it's more often than not in patients who are going to undergo a ETEP restopa, wherein we find during the operation we can't significantly close the defect, or the defect is wider than anticipated based on CT scan. They need a larger mesh overlap, and we have to sort of create a TAR at that point, and then we'll do it as an ETEP. So I'm not one that chooses an ETEP TAR from the beginning most often. That's my personal preference, simply because, like you said, it is technically a bit more challenging to do.
Your ETEP TAR, when we do it, often we find that we have to judge the PRS tension. So robotic, there not being any tactile feedback, you think it is more difficult to judge that, the PRS closer?
Yeah, I think so. The things I do to try to decrease the tension when I close midline, for instance, whether as an ETEP or as a transabdominal, besides decreasing the pneumoperitoneum, and sometimes we use the continuous CO2 device, the air seal device, to keep the pressure low. I actually close the midlines with self-locking sutures with V-lock, and that helps alleviate some of the tension. But to try to gauge how much tension there is can be difficult, especially without tactile feedback. And so those patients where I feel that I'm either going to tear muscle or fascia in order to close the defect, maybe I bit off more than I could chew, and I tried a 14-centimeter defect robotically when I should not have. Those patients, we talk to them preoperatively, and we consider doing it as a hybrid approach. So we'll do the entire TAR robotically, we'll close the posterior sheath, and then at the last minute, essentially open the midline or open the hernia defect, having already reduced everything, lay in the mesh, close it linear vertically, and call it a day. So those patients that undergo a hybrid approach are usually selected preoperatively based on hernia defect size and based on me trying something probably bigger than I should robotically.
Yeah, that was great. You showed in your data that most of the advantages were on the length of stay, the robotic versus the open. Now here in India, our if you see the typical bill after a TAR procedure, very little contribution is from the stay because our stay is not as expensive as it is in USA. You think there is still a role of robot here?
I do, because what we are also seeing in addition to length of stay, which makes the administrators happy, we're also seeing some improved short-term patient satisfaction, both because of decreased postoperative pain. I mean, it still hurts when you pull their linea alba together, and we counsel them about that. But overall, they seem to have less postoperative pain. Their drains seem to stay in for a shorter period of time for what that's worth. And they tend to mobilize earlier. And I think there's a psychological component to it as well. When the patients wake up and they see small incisions, they feel like they got a smaller operation, even though they did not. And they mobilize a little bit earlier. They sort of aren't afraid to take physical risks like, you know, activity level. Whereas when they see a big open scar, I think there's a psychological component that the data don't really get into about the fact that, you know, they should be laid up in bed and they just had this major operation. So I think that contributes, even though there's no data to suggest that.
If somebody who is doing an open TAR very well, he has done say around 50 or 100, should he move to the robotic straight away, or he should first try a few endoscopic
I'll tell you what, I mean, Igor and I and other people have done, you know, laparoscopic TAR, both transabdominal and ETEP. And quite frankly, it is hard, okay? It's ergonomically painful, at least for me. It's exhausting to teach. Eventually you just need to, you know, go take a bathroom break or something. So it's actually quite challenging. And if I have a robotic platform available, the ease of using that robotic platform is so much better than doing it laparoscopically. Now, that said, if you don't have a robot available to you, can you do it lap? Yes. I actually think that the learning curve of a laparoscopic, you know, transabdominal TAR or ETEP TAR is probably harder than the robotic one, because the intuitive nature of the robot allows you to do the same maneuvers you do open. Whereas in laparoscopy, you obviously have to change your technique a bit to fit the operation in the enclosed space in which you work. So if you have a choice, the robot is ergonomically easier, it's easier to learn, and it's easier to teach than the laparoscopic approach.
Thank you, Bindal. It was excellent talk, and we had a good conversation. We'll go for the second talk now, Daksh.
Dr. Anubhav?
Yeah. So thank you very much for having me here, and it was wonderful listening to Dr. Bittner for his wonderful talk. And now I would like to call upon our next speaker for this session, Dr. Francesco Bianco, who is a well-known instructor and trainer for robotic surgery, and as a coordinator of the International School of Robotic Surgery in Italy, and as director of the Advanced Robotic Surgery Lab at University of Illinois Health. He has trained more than 150 surgeons from around the world in advanced robotic surgery techniques. And today he'll be talking on amalgamation of newer technologies on robotic platform. So over to you, Dr. Bianco.
Thank you very much for having me, and I want to thank my friend Vivek and the entire panel here for the kind invitation and giving me the possibility to share our experience. I will start sharing the screen. And we should be ready to go. So I was asked to talk about the amalgamation of newer technologies on the robotic platform. I think we cannot start this talk. Well, of course, my disclosure is that we will be discussing applications that are off-label. This is mainly for the American people. I was saying we cannot really start this talk without really thinking at the nature of what we are dealing with here. We have been, you know, part of this revolution for the last 20 years, and what we really understand after this time is that we are really shifting the way we are doing surgery from an analogic world to a digital world. These robots are just the actuators of this revolution, and the revolution is way bigger than just the improvement in the manipulation of tissue and technical things. It's a revolution that keeps growing, following a different algorithm. So now the growth is exponential. I brought a little example here. This is probably something that people have seen already, but those are companies that didn't exist 15 years ago. The power of the digital world. Uber is the largest taxi company in the world and doesn't own any vehicle. Facebook is the most popular media content owner and doesn't create any content. Alibaba, for instance, is one of the biggest retailers and has no inventory. And Airbnb, despite the fact that those doesn't own any real estate, is the world's largest accommodation provider. All this is possible thanks to this digital revolution, this change in the world. In our field, if we think about it, it took us centuries to go from the traditional way we were doing surgeries using the traditional instruments to go to the first robotic applications. But from the moment that the first robotic applications were developed, it took only a few years to go from there to the systems we have right now and the systems that are coming and will be ready very soon. So it is really a world where the innovation keeps going very, very fast. And from now to the future, we go even faster. Of course, it's our choice to see and decide where we want to be. We want to be in the innovators group. We want to be in the early adopters group, in the early majority, the late majority. We want to stay ahead of this curve as much as possible. And of course, based on our experience and final goals, we need to understand that these are things that we will need to deal more and more with in the future. I present here my experience about starting this new application of the Da Vinci SP in my clinical practice. This is really starting from scratch because the system is not even, again, approved for general surgery use. So I will describe a little bit what I did. We know that this is a part of the constant evolution of these systems. I had the honor to start working with Dr. Gianotti in 2003. And I've seen throughout these years all the models of the Da Vinci. We started the single incision applications in 2011 with the SI platform. And this was a first attempt of try to perform surgeries using one single access through the umbilicus usually, using curved ports and flexible instruments that recreate the triangulation inside the abdominal cavity with the computer that reassigns the control of the instruments left to left, right to right. I've used this technology and I performed about 240 cholecystectomies. I start very slow. I start with very strict indications, and I never really changed much from the initial indications. I went up with the BMI of the patients, but not more, much more than that. We start to understand right away what are the limitations of this technology. We have no end of wrist on the instruments. The instruments are too flexible and sometimes they are not strong enough for this reason. There is limited, almost no possibility to do intra-abdominal suturing. The system overall is very rigid. There are challenges in docking the system. There are collisions during the operation. The assistant is also in a very difficult position when it comes to help during the procedure. Is a procedure difficult to teach with a steep learning curve. In this context, of course, the new technology arrives. The new technology is a true revolution because it's a completely redesigned platform. Here we can see some details. The platform has a 6 millimeters end of wristed instruments and an 8 millimeter articulating camera, which is 3D HD. the system allows to do complete rotations around the port, so we can really work in a multi-quadrant, rotating through the single axis. And the system is very efficient in recreating the triangulation inside the abdominal cavity, so we don't have this triangulation at the umbilicus. Here you can see some applications we were discussing in the colorectal session before about some of the limitations. I feel like some of these limitations can be easily overcome with the experience using the technology. As I was saying, the device is approved for urology and ENT applications. And this was pretty much my path to start using the system in general surgery. Of course, the first thing you want to do, it will be to discuss with the administration and obtain support from the administration, leadership, department, division level, and hospital level. This is a process that will take some time and resources. Here, of course, you have to put together an IRB protocol to be able to conduct this under a research protocol. And then the next step, of course, you want to have access to the technology in a protected environment, ideally a training lab where you can do some dry exercises, animal models, cadaver models before starting using it in a clinical setting. You really need to have a deep knowledge of the new technology. For some of these applications, like this one, for instance, you have limited support from the company, because if it is an off-label use, the company will not support the clinical application. So it's very important to have a deep understanding of the technology and be able to troubleshoot. And then you want to put together a team, a strongly motivated team that is willing to work together to overcome all the problems that will come with the application of the technology. You want to be extremely cautious in the initial case selection. You always want to think 2 steps ahead and anticipate possible difficulties based on the different surgeries you want to do. And then comes the part of the review. You collect videos of the every single case, and you usually review it with the team. You do the briefings after the procedure to discuss problems, how to improve problems. And then, of course, from there, a meticulous data collection and review that usually is done on a weekly basis. This is the experience. I've done 112 single port procedures so far. We have 42 hernias and 70 cholecystectomies. I started, as I was mentioning before, selecting cases very carefully. So for the first 20 cases, I didn't want to do any acute cholecystitis, no super obese patients, no patients with previous abdominal surgeries, and of course, no porcelain gallbladders. And then after the first 20 cases, when everyone was more familiar with the technology, we start to see what are the power of this platform. We start to open the inclusion criteria pretty much to everyone. So right now we do everything from acute cholecystitis to patients with previous surgeries, porcelain gallbladders, and obese patients. At the same time, after the first 20 cases, the 20 cholecystectomies, I start to apply this technology also for inguinal hernias. We start again with a very careful selection of patients. And again, soon we were able to expand the indication, and you can see some of these cases are here. Those are, of course, not for cosmetic reasons, but just to see how the technology can be pushed. The first patient is a patient who had an exploratory laparotomy after a gunshot wound. We were able to do the inguinal hernia repair without problems. The patient below has a laparotomy after a perforated ulcer. An inguinal hernia repair done open, which recurred. He had an inguinal hernia repair done laparoscopic at that point, which recurred. And then we took him to the OR for the third repair, and we used the single port technique. It was a 40-minute surgery, so again, feasible and safe. We need to understand some of the limitations of the technology. Of course, we learn as we go. There is a space, ideal space, where the platform works within, and this is a range that goes in between 10 centimeters to 25 centimeters from the port. This allows some clearance of the instruments, from the port itself and allows the triangulation. And then we have an ideal sphere where the system works that is about 15 centimeters diameter. So sometimes if we want to work in wider fields, we need to readjust as we go in order to cover a wider surgical field. Here are little tricks. This is the introduction of the port. We try to make the incision very tight so there is no leak of gas. Sometimes the incision, as you can see in this clip, is too tight. So even extracting the gallbladder can be a little bit of a challenge. So we had to decompress, in this case, the gallbladder to be able to remove it. For some other application, we develop other tricks. We have this setup, which we call the floating port, where we, in order to gain more space from the anatomy, we connect this through an Alexis retractor, and this allows us to stay outside the abdominal cavity completely and still be able to maintain the pneumoperitoneum. Other tricks, we develop our own suction device because there is no suction available. So in this case, for acute cholecystitis, we bring in a tracheal cannula in between the skin and the port. In some other cases, like in this clip, if you need to decompress the gallbladder at some point, you can introduce it through one of the ports. Of course, in order to maintain the pneumo, we use a wet sponge. But those are all part of this process where we need to develop new skills, and this is the entire team that works on this. This is an example of application of this technology for obese patients, which are way less of a challenge compared to the old technology. And this is a short clip that shows some applications. We have in the biggest video, we have a straightforward cholecystectomy for symptomatic cholelithiasis. And then on the other two short, small frames, we have a case of an acute cholecystitis. You can see pus and the decompression of the gallbladder. And in the lower frame, we have a porcelain gallbladder that also is very challenging in terms of retraction. Here we are dissecting the hilum of the gallbladder. You can see that the instruments are end of wristed again, so we can take advantage of the technology to go around the anatomy. We can easily control using clips and dissect the elements of the hilum. I use, if I have enough space in between clips, I use Bowie in order to save money. I usually do for all my robotic gallbladders a top-down dissection with the grasper holding a peritoneal reflection. And as you can see, the procedure can be done without much difficulties. On this end, you can see instead I open the gallbladder, I identify the cystic duct from the inside, I dissect everything, and then at the end I suture the cystic duct closed. So again, you have different possibilities. Here I'm retrieving the large stone through an endo bag. Those are the results. I have a video that plays. This is a combined case with urology. Urology team did a nephrectomy, and I joined them to do the cholecystectomy. They placed an assistant port, so I used this port to record the video of the device working. So you can see how you have a perfect setup, a perfect triangulation with the camera in the center that can be moved to reach the perfect angles. And as this video plays, I will talk about the results. We have 70 patients. The mean BMI was 34, so we have, of course, a large prevalence of obesity here in the States. It's interesting to notice that 70% of the patients were obese, and the average BMI for the obese patients was close to 40. Docking time, 3 minutes. So this means that this is extremely simplified in terms of docking. After all, there is only one port that needs to be connected. The consult time for the cholecystectomies was only 19 minutes, which tells about the efficiency of the system in these applications. We had 61 patients that were sent home the same day, and 9 patients were admitted and were discharged with a mean length of stay of 1.6 days. This is another application of the inguinal hernias. Again, we have a perfect control of the anatomy. The system here is set up with the camera coming from the inferior portion of the port, and yet we have a perfect exposure. I don't use the cobra position that was mentioned before that much. I feel like it's easier sometimes just to stay more in line with the target. Here is the dissection of the hernia sac. Again, we can use all techniques. We can use energy. We can use blunt dissection, as you can see here, to reduce the sac. So we are in control of everything pretty much like with the multi-port. Things that were not really feasible before with the single site. Here we continue with the dissection of the elements, and then I want to just go faster. For time's sake, we introduce the mesh. We position our mesh, and again, we can fix it the way we prefer. If you like to fix it, you can stitch it fixed. A lot of times, if the pocket is snug enough to the mesh, I don't even fix the mesh, providing that the hernias are small. And then we can resuture our pocket. Another combined case with urology. This was, again, another nephrectomy. This patient was in lateral decubitus, so a little bit more challenging. But regarding the applications and the results, we can see that we pretty much explored every possible indication, including sports hernias and recurrent hernias. Some patients had laparotomies, patients with the previous prostatectomy, which are usually cases we don't like to do, was done also without difficulties, or I should say with the usual difficulties. In 5 cases, there were umbilical hernias that also were a good indication to use the single port. Same docking time. Consult time was 36 minutes, slightly different in between unilateral and bilateral. In this case also, all patients were sent home with an average recovery time of 119 minutes. So pain-wise, these patients do very well. We haven't seen any incisional hernias so far at the umbilical site. We have done this procedure for about a year so far, and we are following up these patients. Problems in terms of the application. Of course, we record everything. We have some draping issues that require to readjust the sterile adapters. We had some 5 expired cameras. This require really to redesign again our process here in the OR because these cameras have 20 use, and then it needs to be sent to the company to be reprocessed. We had 1 system error that required to restart the robot, and 1 instrument function error that was just a recovery fault that required to press a button. So overall, extremely reliable. And I will conclude here with just some pictures. Those are, of course, the application in the obese patients. The obese patients are, in my opinion, the patients that benefit of this the most, because really the scars disappear. Those are patients where we cannot really do 2-millimeter ports or mini-invasive cholecystectomies. And of course, the aesthetical results, cosmetic results, even in normal weight patients, in my opinion, are amazing. We expect to see in the future further developments in terms of instruments. What we really are looking forward are the advanced energy applications that will allow us to expand the application of this technology even more. The system doesn't have ICG right now, but we expect this and more to come soon. So I think this is just the beginning of a bigger revolution that is to come. I will stop my presentation here to be within the time assigned, and I will be happy to take questions if there are any.
That was an excellent presentation, Dr. Bianco, and we really enjoyed every bit of it. It is so interesting to see how new technology is developed and goes from the bench lab and into actual clinical practice. So I'd like to take your opinion on this. What do you see? We saw your fantastic series of cholecystectomies and hernia that you've been doing using the single port platform. But what do you see? Where will this technology be in 5 years from now? What other indications do you see apart from these two that you've been doing?
But I think the technology has value in all the multi-quadrant applications where we, so starting from colon, surgery, upper GI. I think that the moment the instruments array becomes more mature, we will be able really to apply it in many different applications. I see colorectal and upper GI for sure, endocrine surgery. I don't see why we'll not be able to do adrenalectomies, even considering a different approach like the retroperitoneal approach. I still think that the technology is already at a good stage for transanal procedures. And of course, it requires more sophisticated instruments in order to grow further.
And do you think the learning curve for the single port platform in robot would be any different than the traditional robotic platform?
I think that the multi-port platforms are really intuitive. What has been always striking with these robots is that you sit down and you really understand right away what you are doing. The system allows you to be in control very easily. The single port is a little bit more challenging in terms of work at the console, because now you have few more controls that you need to be aware, because you can angulate the camera, you can move the camera, you need to move the entire system. There are different pedals for that. But it's something that, you know, I don't see a very long learning curve, mainly coming from a multi-port experience. So overall, I would say easier to learn compared to the single site technology, and the learning curve is still, you know, probably slightly bigger for the basic manipulation of the controls, but not long at all.
I think Dr. Bianco, wonderful presentation, and this is, you know, I was just comparing the same thing. You have been doing single site surgeries as the first center, one of the first in the world, and now you're using this one. Single site surgery did not pick up that much, and it was not replicated. So what do you think this platform, you are yourself saying the limited instrumentation and the difficulty in you know, learning. So you think it is going to stay, or do you need a better platform for something to be sustainable?
No, I think this platform is a great start. It's for sure a major improvement, or I should say a revolution, compared to the old single incision. I agree with you, the single incision, we were all very excited at the beginning, but then slowly, you know, we start to see the limitations, and we could not really grow the indications for that technology. This one, I think, is a revolution, is a completely different platform where the indications can grow and can grow a lot, to the point that, you know, if we can keep the costs within reason, even basic applications like this, gallbladders and hernias, could be perfect for a routine use with this platform.
Wonderful, wonderful. And I have a question for Professor Bittner. Dr. Bittner, your talk was wonderful. So we have been doing some robotic TALs, but most of them have been ETAP approach, because I think we just replicated our laparoscopic ETAP approach into robotic. And we found that, you know, the number of ports are less as compared to transabdominal, and we don't have to dock again in case you are able to go bottoms up or up craniocaudal direction. So what do you think? Should we try some transabdominals one, or should we just continue with ETAP till it works for us?
I'll tell you what, it's largely what you're comfortable with. I sometimes also switch it up based on the platform I'm having to use that day. So when I'm using the XI platform, the ability to double dock on each side is very simple, right? Press of a button, it spins, it's quite simple. When I'm using my X platform, it's more difficult to do that. And you have to spin the patient, and anesthesia doesn't like that. So in those patients, if the hernia is appropriate, and ETEP works very nicely, because as you said, I don't have to redock. I tend to do subxiphoid from the top down if I can. And so I vary it based on that. And the reason I do that is couple-fold. Number one, I want to be able to train the fellow to do both things. So I have to switch it up a little. Number two, it may be hernia specific. So there may be reasons I need to go into the abdominal wall. If patients have had multiple bowel obstructions before in conjunction with their hernia, I think they're owed an enterolysis. So I want to be in the belly anyway to do that, to take down all the interloop adhesions and things that have probably, increase their risk for small bowel obstruction and readmissions. But I really do take it on a case-by-case basis. If you have a bunch of ETEP experience laparoscopically and then converted it to robotically, that's awesome. I would run with that, but there are some times when a transabdominal might be worth it, especially if you have a reason to be in the belly, like enterolysis or stoma takedown or things of that nature.
Thank you so much. Dr. Panjani?
I think the microphone
Dr.
is
Panjani, you are on mute.
Sorry. Yeah, so the robotic, the port side hernia after the single incision robotic is less than that of laparoscopy? Because in laparoscopy, we have seen a lot of setbacks in the port side hernias.
Yeah, no, that's a great point. We start understanding more about these incisional hernias also with the single site. A major change was in the sutures we used to close, because we started also in laparoscopy. We were starting our experience closing these incisions the same way we were closing our 12mm ports with Vicryl or pass reabsorbing. I've seen a major change when we switched to slow absorbing large sutures. So I close all these incisions with one PDS, and we have seen a major decrease in the occurrence of incisional hernias. I haven't seen any so far on the SP. I've seen, of course, some on the single site before, and that's where I was talking about this experience. The SP has an advantage because the incision ends up being even smaller than the single site. The port is metallic, is very rigid, and you can really snug it into the incision, stretching the incision a little bit. The old technology required, or in laparoscopy was the same, required a larger incision, because in order to accommodate that silicone port or whatever port we were using, it was a little bit more difficult. We tend to break that port if we didn't make the incision big enough. So this is a real 2.5 incision. I think that in laparoscopy and single site, that was always slightly bigger than that.
So Francesco, one question. So I've only played with the SP in the lab and in the PIG lab in Atlanta and other places. Haven't used it live yet. And one of the reasons was, as I was thinking from an indication standpoint, when we have patients with ventral hernia and they already have a hole, can we use that for abdominal wall reconstruction? And so I wanted to get your thoughts about that.
Yeah, that is a great point. The difficulty, and I've been thinking about it too, the difficulty with that type of application is the distance that we need from the port to our target anatomy. I mentioned that trick that we use, that is the floating port. That floating port might allow us to go further enough in able to work on both sides of the abdominal wall. I think there are, there is the gel port as another alternative that even allows to use an assistant port. So I think that the moment we have better energy, I don't see a big limitation in trying to do this applications.
That's why I thought when I saw what I hadn't seen before, which was the floating port, it reinvigorated the question, because, you know, closing the abdominal wall on your way out from the anterior aspect was seemingly impossible. But with the floating port, by moving it further away from your target, it seems like maybe you could do that.
Yeah, absolutely. That will facilitate that task. We developed that for the inguinal hernias to be able to close the peritoneal flap.
Right.
Yeah, and the application will be very similar for hernias. So I think that, and there are more things coming in terms of ports. So I think that that will really become an option soon. I'm very curious to see when you will start using it on these complex cases.
Right.
I have a question for Dr. Bittner. Dr. Bittner, an excellent presentation. Really enjoyed your presentation. So one statistic that you showed was a comparison between your robotic ventral hernia repairs compared to the laparoscopic ventral hernia repairs. So there you mentioned that the use of polypropylene meshes were more in case of the robotic procedures, and also the choice of fixation was more in favor of a non-traumatic, that means a fibrin-based fixation in robotic repairs. So any particular reason, was it basically because of the different plane in which the meshes were placed, or was there any other difference?
No, I think it was a component of both training and experience, for one, in the sense that when we performed open TAR, especially early on in the early onset days of open TAR, we were still doing transfascial suture fixations of the mesh laterally and so forth, much like we would have with an IPOM. And I was trained to do it that way. And quickly within that data set, I sort of got away from that. So that's one reason why there was a transition in fixation, because robotically, I never really adopted the use of transfascial sutures. We started right from gluing from the beginning. And I think that's one reason the data are reflected as they are. Yuri's data are similar because his progression is somewhat similar as well, in the sense that we adopted a new strategy for fixation in an effort to decrease post-op pain. And that was the big part of it. That, and we're using large pieces of mesh that there's nowhere for them to geographically go to. So we've also found anecdotally that the use of fibrin sealant in these enclosed spaces has decreased seroma requiring procedural intervention. That data are not yet published. I'm working on that. So because it obviously increased costs, we have to figure out if there's value to the cost of the glue. And I think probably the value in the cost of the glue is the decreased seroma rates and the decreased seroma requiring procedural intervention. But that data aren't quite mature yet.
Thank you.
I think it has been a wonderful session, and thank you, Dr. Bianco and Dr. Bittner, for taking out time on a morning when I know that you have surgery scheduled. I think Dr. Bianco is already late, getting late for his procedure, but we enjoyed talking to you. Thank you, Dr. Punjani and Dr. Anubhav Bindal, for taking out time and chairing this session, moderating the wonderful discussion. Daksh has been the backbone of the program the whole day, and he has been moderating. So thanks to Daksh. I think we'll call it a day. Now with all these virtual conferences, we will miss all the fun, but we'll just talk about science and then go back to work. So we'll definitely love to have both of you in India in our future events once the situation is better. So Daksh, can we call it a day?
Yes, sir. Yes, sir. Thank you. Thank you so much. Thank you to all the chairperson and the speakers.
Thank you, everyone. Thank you.
Thank you very much. Thank you.
Bye-bye. Stay safe. Bye-bye.